everyone. Good morning and welcome to day 2 of Native Rejekts EU 2023. I'm Benazir Khan, by the way. I don't know if I've introduced myself to a lot of you before, but yeah, I'm also one of the organizers here. I just wanted to quickly say that I know we're running right on time and Karthik's talk will begin, and we'll begin like in about 5 minutes. Yeah. So sit back, relax, enjoy the program. Couple of logistics, like you've heard already yesterday, but I'll reiterate for today. We have the lounge area there. You can get coffee, tea, snacks, water. There's also some here, right at the corner. I don't think a lot of people noticed that. And yeah, and we're sort of moving around different rooms. But yeah, you can quickly grab some water there as well. Try and be quiet when you move between rooms so as not to disturb the talk, the speaker, or the audience. We're going to stick to 30-minute slots today. I know a few talks ran over a little here and there, but we'll try to stick to schedule. There are talks happening in parallel upstairs as well in the suite. This is the warehouse, and that's the suite. So yeah, room 1, room 2, accordingly. Yeah, are we ready?
Are you ready?
Do you need? Is everyone ready? Yeah. Yay! Let's kick this off.
Awesome.
Yep.
Yeah, TLS first thing in the morning. As soon as the screen comes up.
No question yet.
Good.
No, your laptop. No connection.
It's a little bit loose here. There we go. Good. Welcome again. I think I met a few of you yesterday. And give me a second. Let me just, it's my 1 second of meditation. Thank you. Okay. How many of you guys have heard this or seen this story happen? Someone from security walks in and says, hey, look, you got to protect your application workflows. Right? And everyone's encountered that. Everyone might have seen that for their own apps. Certainly seen it for other app teams, right? And the different ways that people respond, I've seen a few of those as well. And I definitely see this, which is like, okay, I'm just going to go take a holiday. I'm going to ignore this for a few months and let's see what happens, right? Please don't do that. Encryption. That's easy. I just like, there's something I figured out I could just create a tunnel, you know. You need keys for that. Oh, but they need keys to talk to my app. Let me just push the keys on, self-sign them, put them on an S3 bucket, be done with it. Happens a lot. Way more than you think. And if you give options to an application developer who is under pressure to get something released quickly, they're going to take the shortest path, right? The quickest path. Try a service mesh. And first of all, generally when people think mutual TLS in this community, how many folks instantly go, okay, that means service mesh? Okay. Well, that's actually not bad, because usually most people go that. And by the way, I think that is a genuinely legitimate opportunity. There's been a lot of work that's gone into really characterizing the key elements that you need for security and packaging them into a deployment mechanism that works reasonably well at scale. The challenge is always usually like, okay, look, it requires additional thinking, additional work, additional overhead. When people think service mesh, they generally think proxies, sidecars, node proxies, some other form of proxies. You do have proxyless options in service mesh as well. But there usually is some level of work involved. And also with the service mesh, it's not just the fact that you deploy a service mesh and suddenly you get mutual TLS. You do have to pay attention to what's happening there. When your sidecar proxy starts emitting errors saying, hey, unable to process certificate, error, don't ignore it, right? There's a lot, for example, you've probably seen many of my talks over the years around How do you enable MTLS with Istio or Envoy or various sort of elements? I was part of the team that helped, part of my team helped build external authorization in Envoy back in the day, right? There's a lot of work that's gone into technologies like Spiffy, how it's implemented. Lots of best practices there, but not everyone follows best practices. A lot of folks still use a default service account for everything. So it defeats the purpose if you can't assign a different identity to every workload. If you give them all the same identity, then everything is, what's the point of having fine-grained zero-trust security? So this is genuinely a valid option, highly encouraged. There is a cost associated with that, learning, resources, and so on. And the fourth option that people do consider, even in the presence of service mesh, I've worked with a number of banks where they have a very sophisticated team that's trying to deploy a service mesh, but there's a number of app teams going, that's fine, I'm just going to build all this like spiffy identities natively into my app. And then they start digging into it, and they dig into it some more, and they go, ooh, the stuff, maybe I'm not ready for that yet, because there's genuinely things to learn, right? So oftentimes it ends up in panic again. Oops, what do I do? So those are usually the main options. And just out of curiosity, like option C versus option D, how many folks look at option D and go like, maybe I could build a little app, but I don't? And yeah, exactly, right? So it's sort of there, it's doable, but here's something that will help make this easier to think through as we go forward into the future. This is where HTTP is going. It is here today. HTTP 3 was a standard as of last year. It uses a new transport protocol called QUIC, which is a standard as of 2 years ago. HTTP 3 says there is no more HTTP. There is only HTTPS. So in the past, part of the patterns that people have used is, hey, including for service meshes, is why don't you just send HTTP from your application? We can intercept that in the proxy, and then send HTTPS from the proxy out. In the new world, there is no more HTTP, only HTTPS. So HTTP 3 says, you shall provide TLS. That TLS is built into the transport layer that H3 uses, called QUIC. So TLS has been taken and implemented as part of the protocol exchanges. Benefit of doing something like that are things like performance. If you imagine things like a connection handshake with a TCP SYN ACK, followed by a TLS client hello, server hello, and then exchange traffic, the benefit of something like QUIC is that you're doing if you've already spoken to your peer prior and the session tickets are still valid, you will be exchanging traffic in the very first packet. And that's a huge win from a performance and latency perspective, right? But the challenge is now TLS is part of the protocol. It's also an opportunity. And it's a huge opportunity because taking this, if we are in 2023, TLS is been around for such a long time. It should not be something that is hard. It should just be part of the stack. But it does make a lot of us in this community have to rethink our architectures in a good way. Because it's no longer the case where you can just say from your application, I'm just going to send unencrypted traffic, and someone else can look at my packets and figure out what to do. Because now your traffic will leave your application encrypted. Secondly, and by the way, you can have proxies in the path of H3. There's work that's going on H3 UDP-based proxying, but that requires the application to still send encrypted traffic as a capsule typically, and with sort of an outer wrapper that the proxy can take a look at and send it to the destination. So the proxy will have less visibility. And this is intentional from an end-to-end principle that we generally follow. So given all of that, the other question you want to ask yourself is the concept of identity. If TLS is mandatory, that means you need a certificate. TLS works with certificates. So where do you provide that identity? Do you pick a fake identity like a self-signed and put it in the application and then have something else in the proxy? My general stance on this is every application needs to have its unique and attested identity that talks to what that application is. A couple of the challenges we've had with having identities just delegated to a service mesh proxy in the past, but not in the application, is one, that identity gets fed into the mesh proxy, maintained there, but not passed through to the application. Usually it's in the memory space of the proxy. Which means if you're trying to use that identity for validating what client identity is talking to you at the application, you typically can't do that unless you do some extra work on the side. Second is if you're trying to use that identity for other purposes, signing code, doing other sort of work in the application itself, you don't have visibility. Third challenge, what if you're talking to something external to the mesh? Something outside, right? How do you establish the trust from the application outside? So these are some of the challenges that people have had. There are sort of ways to work around that. I've worked with a number of folks to implement different approaches in production. But if you step back and look at all of this in this new context of where H3 is going, or where H3 is today, because this is widely adopted today in the front end, just get every workload an identity. And I'll talk about why that needs to be trivial, but why that has become trivial in the context of some of the products that make getting identities to workload just automatic, right? So bottom line on this is H3 is now made TLS mandatory. You don't have to, it's just part of the transport of the protocol. So here's the other approach we can look at. This is a new project that we just started. We started a few months ago in collaboration with the Cert Manager team. And specifically, this is an alternate approach of saying, yes, absolutely, service meshes are one way you can tackle this. Yes, it comes with typically some level of complexity, usually some significant amount of resource utilization. But another way you could tackle this is, let me pause here. H3 is awesome because it builds everything into the protocol. The challenge with H3 is it takes time to update the applications. It is a new protocol. It works on UDP. It takes, you need to understand now that TLS is mandatory. So your applications need to go figure out certificates. They need to figure out rotation of certificates. They need to figure out authentication, authorization, hopefully, right? And all of that takes work. So QuickSec is like, well, rather than having applications do all of this additional work, why not let applications, for the period that they're going to be transitioning, whether it's months, years, whatever, let them continue to use the same system calls, the same library calls they've been using all along. Regular HTTP 1.1 or HTTP 2 calls. And let's plug in, like in some of the language bindings, middleware with a very thin language binding that says, okay, look, you take your H1 call as you've always been doing, but the middleware converts it to H3 on the wire. So the application continues sending H1 as it normally does. And if it's, for example, in our examples, if it's a Golang service, you would be doing a HTTP listen and serve. And you'd still be doing a listen and serve, but now with QuickSec. And what QuickSec does is, in addition to listening to H1 and H2 on the wire, we are also making the application listen to H3 on the wire. And as H3 requests come in, they get converted to H1 or H2 up to the application. If it's a client, you'd be doing a client do. And now with QuickSec middleware injected, essentially that request will go out on H3 on the wire, giving it better performance. And interestingly enough, there's other benefits around service discovery, automatic failover from a client side. So there's some very significant benefits. I'm going to defer those for a future talk, right? But for now, just keep in mind that you could just inject this middleware, keep using your application as you were, and with that tiny little update, you now have the ability to use and consume H3 on the wire. So super simple, no issues whatsoever, and you don't have to wait years to get to this new platform. Now, what's the benefit? The benefit is, in the process of doing that, we also enable pluggability of a few optional components at runtime. One is all of the workflows around certificate provisioning, rotation, validation, verification, and on the identity part, with things like certificates, for example, we'll talk about how we integrate with Cert Manager, but specifically Cert Manager now has a CSI driver, and the CSI driver, the storage driver, essentially mounts the certificate into the pod automatically with the SPIFFE SVID, and the SPIFFE verifiable identity is essentially a certificate that has the metadata associated with that workload. That certificate typically has a lifetime of 1 hour, so the certificates are rotated hourly. There is, and when you have short-lived certificates like that, you can that's generally considered a better security approach than having things like OCSP, Online Certificate Status Protocol, or other, like CRLs hardly anyone uses in practice. So this is generally a better approach to deal with short-lived certificates. And QuickSec does all the work to make this transparent to the application. The application is still sending just regular HTTP 1.1 transactions. Certificates being rotated, verifying them, validating the CA, all of that's automated by QuickSec. Second plugin is authorization. Being able to say transparently at runtime, look, what peers do you want to allow to talk to this workload if it's a service? If you're a client, what peers are you allowed to talk to? Giving the controls in a very simple schema, but something that can be plugged in by external authorization plugins is something that, so our team had actually done in Envoy back in the day with external authorization and contributing that to Envoy. We're taking a similar approach where, look, you have a variety of security technologies out there. They should be able to plug in. But at the base, we have a very simple policy-defined architecture. And by the way, while we're at it, why not plug in observability too? We're seeing the HTTP requests, so let's generate logs, let's generate some metrics, and there's additional work we're doing for additional observability components, but why not do that as well, right? So that's the basic concept behind QuickSec. Let's make this super easy to use. TLS is just part of the transport. Don't worry about it. And if you're going to do TLS, you're going to do encryption just once typically in your stack. Just make it mutual TLS. Authenticate the remote side and authorize it. So that way you don't have to worry about all of the additional things that you are not doing. And so that's part of the intent by QuickSec is if you're going to do TLS, just make it mutual TLS and plug in the controls at runtime. So when we built this, the intent was to make the application experience as easy as possible, right? So very quick, just a setup for what we'll be demoing. It's actually the same demo application we were talking about yesterday. And this is one of the Azure microservice demo applications, a bunch of microservices. In this case, these are all written in Golang, so we plugged in the QuickSec middleware fairly easily. Other languages are coming. And in effect, it consists of a handful of services, a book buyer microservice talking to a bookstore, which originally was using HTTP 1.1, and that's talking to a book warehouse with MySQL at the back end. And what we're going to show is essentially this application has had QuickSec middleware injected, essentially this import of the QuickSec. And now that it is using HTTP 3 via QuickSec, how do you enable mutual TLS at runtime? So that's the quick demo I have. Sorry, quick demo. I keep using quick as pun, and it's like, should I say it's pun intended? At some point you go, oh, might be too early in the morning for jokes. Okay. So So what we have in this cluster here, I'll come back and talk to the role of cert manager, and specifically cert manager CSI driver spiffy. So we have that running already in the cluster. We have some of the QuickSec provided add-ons for observability already running. Prometheus, Loki, Grafana, standard stuff. And that's basically what we have running here. So I'm going to go ahead and deploy the bookstore pods. Two-factor. Okay, let me start this up again. All right, so it's coming up here. Fairly quick to start. You can see it's like it's already started. Just a single container running in the pod, nothing else. And now if we do a port forward to access the UI for the book buyer and the book thief pod, so let's just do a port forward. And if we go to the UI for this, book buyer is able to access the bookstore. There's a count that's incrementing, saying, okay, look, there's so many books being bought. It's all being purchased from version 3 of the bookstore, which happens to be on HTTP 3. You go to the book thief, which is a workload that is a compromised workload in your cluster. Maybe you have an attacker in your midst you don't know about yet. Also able to access the bookstore. All of these transactions are going on one-way TLS right now, because that's the default in H3. If you do H3, you're doing one-way TLS. But you haven't, it's not MTLS. So let's enable MTLS. To do that, we are making one change to the deployment manifest of the application. And the one change we're going to make is right here, where it says MTLS enable. We're going to set that to 1. And when we do that, in effect, we're saying, look, get your auth config from this file, and this config map, actually. And the config map that we have deployed has right now just one rule, saying authorize this spiffy identity, book buyer namespace, book buyer service account, right? That's the only thing authorized. We'll talk about how that trust is established, how that trust domain is established. For now, we're just saying within the cluster. This could easily span multiple clusters. This could easily have trust established with a peer service mesh if you want to as well. So let's go ahead and apply that. Sorry. Okay, and it's strictly speaking, it's not required to restart the pod. It's just an environment variable, but if you assume GitOps, let's say this has restarted. So in effect, we've essentially restarted the pod. Now the policy should take effect. And in effect, if you go take a look at Book Thief, you should see that this is stopped. I'll give it a second here to make sure it has. Yep. And so Book Thief no longer works. If we go to book buyer, that should start kicking in again and start working. There you go. So you should see book buyer working as normal. So essentially, this is a one environment variable saying enable MTLS rather than one-way TLS, and that's it. Nothing else to do, no other components in place. And so that's working, but let's verify that it's working. Let's go take a look at our logs. And if you go look at the logs, let's look at the, might have typed out again. I might need to do a port forward. Okay. There we go. So if we say app equals bookstore, which is the one doing the authorization, and if we go look at the logs here, you will note, let me make that bigger. You notice that now there is this log saying accesses from unauthorized SPIFFE ID. We are also providing a dashboard so you can see book thief has dropped to 0. Book buyer continues to work because it is authorized. You see the SPIFFE errors saying, look, there's a SPIFFE error here, authorization error, so you see the errors. And we also give some basic service graphs. Again, you guys typically have more sophisticated dashboards, but some basic service graphs showing book buyer continues to work, book thief has dropped, traffic here has dropped to 0, right? So basic observability, which can be integrated with your own platform. So what's the takeaways here? So question, where's the mesh? Right? So MPLS, basic observability, super simple, pluggable plugins for various purposes. And these days, there are a variety of ways to make your plugins in any language. The intent is to enable these different options. And so takeaways, don't be afraid of certificates. What you saw there was Cert Manager CSI driver, which automatically takes care of creating SPIFFE SVID X509 certs with trust established based on how you've set up the cluster automatically. Pod comes up, certificate is available. You can choose to mount it into the application. If not, QuickSec takes care of all of that. Certificates are rotated hourly. The app doesn't have to worry about it. QuickSec takes care of it. Your policies, look, at runtime, you say, do I want MPLS or do I want one-way TLS? That's it. Right? If you don't specify that, it's one-way TLS. And you can specify your authorized workloads. So I have a lightning talk just talking about Cert Manager. If you're interested, I'll give you a quick update there. Bottom line, TLS is now mandatory. Let's just make it mutual. Let's make just 2023. Let's not. Why is this such a big thing, right? Every transaction, every access. Let's just do it. It's as easy as this, right? So keep it simple. We're trying to take you, and by the way, the intent is there's a lot of complexity in things like the data plane. What we are trying to do with QuickSec is make it as easy to use as possible. So the workflow from an application perspective is I'm doing a DNS lookup and I'm doing a HTTP request. If you have to troubleshoot this, that's all you need to go troubleshoot. Yes, if there's certificate errors, if there's validation errors, there's going to be logs emitted. Please do keep an eye on those. But the data path is as simple as can be, right? So that's the takeaway. Keep it simple. If you can, join us. We have an evening event. JetStack, who's our partners in helping build this, doing an evening event. We're going to debate SPIFFE and identities in general. Come join us. That's tomorrow evening. And feel free to, in fact, would love collaboration. We are at the very early stages of this. The intent is H3 is going to bring a lot more capabilities. Let's leverage the power of TLS now being built in. And Quick really now becomes the point at which security policies can really have their full power, because that's where encryption is happening. Quick is going to enable the ability to dynamically change context, how you can have different streams multiplexed in a connection, and all of that. The point of convergence is that Quick layer. And what we are enabling here is at the endpoints, either the server or the client. It doesn't have to be both. Your client could be a web browser just as easily, right? But we are enabling pluggability of security controls. Let me take a question if you have a, yeah, go ahead, Alex.
A couple of questions.
Wait.
A couple of questions for you.
So the first one would be, so I think what I've understood is that rather than having a sidecar in the container or just one on the node, like Waypoint and Ambient Mesh, we're going to go in process and then use a client library instead. So that
Correct.
makes sense. That seems a lot simpler. There's still that problem of the certificate provenance of the CA and the rotation. So there's still a lot of complexity in this, just like Istio Ambient Mesh is going to have. So I think what do you do when you have an external client?
Great
This is
question.
a problem that I have.
Great question.
Right?
Yeah.
And I've considered mutual TLS, but to actually bootstrap it to the point where there's a trusted CA that both of them can obtain certificates from, what is your answer there? That's part one.
Yeah. You want me to take that, or do you want to answer? Why don't you just ask part two as well?
Part two is why are you enforcing quick when really the main value here is switching out sidecars for CSI?
Yeah.
So you could potentially get a lot more traction, or you could apply this to HTTP 2 and 1.1.
Yeah.
Because the main value here I see is just switching to CSI instead of a whole bunch of microservices to create the certificates.
Great question. So the first part of the question is, yes, when you have things outside of your trust domain, how do you enable MTLS with those other external? So in the policy schema, we have the ability to say, look, if you have spiffy IDs with a certain trust domain, yes, that's part of the same trust domain, they can be trusted. If you have external trust domains, one of the things we are adding is, and this is something we have in flight, is how do you inject external trust with external trusted authorities, right? So in other words, you can do that in Envoy as well today, but in Envoy you can actually go in and specify, if you see this domain, here's the root of trust. So same thing, the intent is, ultimately, there has to be a trust. You can't just arbitrarily say someone with a self-signed certificate, allow it. So part of this is enabling the flexibility, but how it is implemented is going to be rooted in, can you establish trust with that remote external device?
So this is like a kind of federation. You would trust the
Correct.
thumbprint of that CA.
Correct.
And the remote client would generate it.
Correct. And we would validate that that root of trust is established and valid, right, before.
Okay. And then you don't have that problem of the service mesh where all the certificates need to come from the same root CA.
Exactly. That's one of the limitations. Now, even in Service Mesh, there's integrations with external providers to enable this. But the challenge there is it's usually constrained to the mesh proxy, if you have a proxy, right? Here, you're essentially building it into the app. Second question is in terms of, why quick, right? We actually thought about this because there are actually solutions, middleware solutions that do this with traditional sort of environments, usually longer-lived certificates or CSP, right? But there is a significant amount of benefit to helping move folks forward to H3, and there's a few other benefits to H3 which I haven't mentioned here. Automatic service discovery, automatic client-side failover, and the performance is also better. So interestingly, we found that by H3 transactions with Quick, some of the simple benchmarks we're doing 30% faster than non-encrypted H1 transactions, right? So there's benefits there. And TLS being mandatory and built into the protocol, there's a significant amount of benefit as opposed to dealing with, okay, look, I want to tweak my TLS to 1.2 and then deal with the issues around session tickets that used to exist. So the intent is the H3 stack with Quick is a lot cleaner. So yes, there's a little bit of we are moving folks forward, but there's a significant benefit to it, right?
Thanks.
Thank you. I think I'm out of time. I'll be around, so we can probably have further discussions. Right? Thanks, everyone.
I'm afraid that's all we have time for. Great. Our next talk is at 10:10, so it would be great if you remain seated, and yeah, we'll try and balance the time out for the rest of the first half of the schedule. All right, it's time for our second talk for the day in the first half. This one's by Rafael Franska and Tim Ebert. We were just having a chat about the fact that they're speaking for the first time at such a conference. So yeah, let's give them a round of applause, cheer them on. And yeah. And they'll be talking about credentials rotation in Kubernetes. All right, take it away, guys.
Right. So thanks for the introduction. Welcome everybody to our talk. This is Tim, my name is Rafael, and as already mentioned, we will cover the topic of credentials rotation in Kubernetes today. So, setting the scene, and what is actually the problem that we'd like to talk about. So if you have set up your Kubernetes cluster yourself once, or if you're just using one, then you are probably aware of the vast majority of credentials that come with such a cluster. So there are CAs and certificates, there are tokens and keys of various kinds, a Kube API server talking to etcd with a client certificate. Then there are pods that use service account tokens talking to the API server again. This entity needs to encrypt secrets in etcd, and then there are even human users or operators that have kube configs or SSH keys to interact with the nodes. Yeah, and if you now think about managing and rotating all these things, then actually don't worry if you start to feel like this. Actually, that's how we felt when we started to look into the subject matter of the course of the past year. And we'd actually like to present a few insights and learnings that we made on our journey. Just to complete setting the scene, we are working on this project Gardener, which is open source. If you don't know it, it's actually a Kubernetes extension for managing further Kubernetes clusters as a service. So think GKE for basically any infrastructure or environment. And this system is actually built for scale by using this Kubernetes in Kubernetes model, also sometimes referred to as kubeception. What is interesting about it as part of this talk is that basically Kubernetes is the workload or the application that we deploy again in a Kubernetes cluster. So yeah, we see it here in this diagram. We have a seed cluster that's just a regular Kubernetes cluster where we create namespaces. Those are these colored boxes. And in these namespaces, the control plane, etcd, maybe further controllers are deployed as regular pods. So that means we have Kubernetes everywhere, also for the secrets management. And what we will discuss today is, of course, applicable to Kubernetes, but can also be applicable to any other application that runs in a cluster. Coming back to the rotation topic and thinking about it at scale. As said, the system is built for managing hundreds or even thousands of clusters. And if you now try to come to an approach, how do you orchestrate all the rotation and management of these credentials, then you pretty fast come to the conclusion that you need to achieve these goals in order to survive. So you want to have a disruption-free process. You don't want to cause any downtimes during the credentials rotation. You want minimal ops, so some human involvement might be needed for some cases, but this should be as minimal as possible and as fully automated as possible. So we have basically two main topics today that we'd like to discuss. One is about short-lived credentials. So those are mostly things that can be rotated quite frequently and quite dynamically. And in the context of this talk, that's actually the service account tokens of pods running in the cluster. And the other big section is about more static credentials that need a bit more of orchestration, human involvement. Those would be the CAs and keys in the cluster. So then let's get started with the service accounts. I assume pretty much everybody is aware of this. So whenever there is a pod that needs to communicate with the API server, then this is done as part of a service account. That's like the identity of this pod. And the service account is simply referenced in the spec. And what then happens when you apply this to the Kubernetes cluster is actually that you will get this kind of volume. Since Kubernetes 1.22, that's a projected volume, which has several sources, most prominently the service account token with some expiration seconds, the CA certificate of the cluster, and then, this is not visible here, the namespace of the pod itself. What else you will get is for all of your containers a mount for this volume to this quite well-known location. So when the kubelet now gets started and starts the containers, it will use the token request API of the Kube API server to fetch a token for exactly this pod and this service account, and then set up the mounts and the file systems. The thing that clients now need to do is to actually read the credentials from there, and they should also regularly reload them, since now the token here has an expiration time. The kubelet automatically re-requests a new token when the validity time approaches, and publishes this in place to the same location. So the client needs to reload it in a regular way every 5 minutes or whatnot. Actually, all major client libraries, Client Go and so on, are already supporting this since quite a long time, I think since 1.13 already. So most likely all of this works already quite well in your clusters and more or less out of the box. There's nothing you have to do explicitly other than using a more reasonably large version of this library. Okay, I'd like to quickly demo this token request API, since not everybody might be aware of it. So we have set up here a kind cluster. I hope the font is large enough. And we simply create a service account, which is called robot in this case. And then we use a kubectl command, create token, and we increase the verbosity so that we can actually see what is going on. And the interesting part is basically happening here. So we are sending this kind of request body to the API server that's here. It's the local kind cluster. And we're basically using the token sub-resource of the standard service accounts API. So when we decode this request body here, oops, a sec. Then we basically get this JSON document. So that actually looks like a Kubernetes resource of kind token request. Actually, it is not a real resource. It's just the data that we now send for this single API call. And in the spec, we could configure certain things, audiences, the expiration seconds of the token, maybe a bound object it should be assigned to. kubectl is not doing it here, but the kubelet obviously would set these things when it really starts a real container. Okay, and what we will get from the API server in response is basically the following. So we still have this token request object that is now filled with some values. So in the status, we get our real token that we now can use to authenticate against the API server. We even get informed about the expiration time, and in the spec it also defaulted a few things that it used for the configuration of this token. Okay, going back to the presentation. Here we are. So that's actually the same slide that we saw before. And what I want to point out is the following. You might have seen it. This is the default expiration seconds that Kubernetes uses when you simply deploy a pod without further configuration. Sure. And so that says that it should be something like an hour or so, an hour and 7 seconds. That's actually good so far. So an hour seems to be reasonable, not too long, not too short. Actually, what you can find in the source code, because this number somewhat looks suspicious, right? 3607, why is it such a strange number? If you look into the source code, then you will find the following, and this here is extracted from the Kube API server and basically from the function that is issuing the token. And the interesting part is basically here. So when the extend expiration value is set to true, and the expiration seconds is this 3607, then it actually silently overrides the expiration to a year, right? And that's probably something we should be aware of. We as a client said we want to have a token for an hour, but what we get is a token for a year. Why is that? Well, in the past, Kubernetes was using tokens without any expiration at all. So clients didn't need to join the game basically and reload the token regularly. It was just valid all the time. And now the community is transitioning to get rid of these tokens without any expiration. So that's why the community wanted to provide enough time for everybody to update their client libraries and to basically adapt all the controllers to play nicely and reload token regularly from the file system. Conclusion out of that is that you might probably want to set this flag on the Kube API server to false. This is actually the thing that controls this kind of magic overwriting of the expiration time. It's still true by default, even in the latest version, 1.27, just released last week. Of course, you should first make sure that you have no controllers that are still using a very old library, but in this case it should be indeed quite old, right? But most probably you can go ahead and do this and set it to false. If you cannot control the flag, maybe because you are using managed clusters, GKE, where you don't have full control over the API server, then you can also simply use another expiration time, 3606, something else, to ensure that you have a short validity. Okay, and to complete this service account story, one word also to the static token secrets. So as said before, Kubernetes 1.24, the Kube Controller Manager was generating such a so-called static token secret for each service account. And you could also not disable that in any reasonable way. So it was always doing this and generating such a token which has no expiration date at all. And that's something we actually don't want, and obviously a security risk. Okay, and that's why the community started this cap, which is 2799, with the goal of getting rid of all these static token secrets. And as you can see, the community is still in the process of implementing it. So there are basically 3 pillars. The first one is about the auto-generation. As said, this is already beta and enabled by default since 1.24. Meaning that at least no new such secrets will be generated by Kube Controller Manager. Then there is a feature about tracking the usage so that you can check if you still have entities in your cluster that might rely on such token secrets. So there will be, I think, an annotation where you can check the last usage time. And the last thing is actually also an important one about auto cleanup. And that's actually not yet implemented at all. So that means that most probably you still have static token secrets in your cluster, and the community will only make it in the next release, 1.28 as alpha, if everything works well, of course, and only to beta in 1.29. So that's at least 8 months ahead of us. So conclusion here would be that if you are on 1.24 or higher, then you might want to simply manually get rid of these secrets. Of course, first making sure that you have nothing in your cluster that is still relying on them. But as said, all this projected thing and the libraries are updated since quite a while. So chances are quite high that this is already working for you. If you are stuck below 1.24, maybe you cannot upgrade your Kubernetes version for some reasons, then there's also a thing which is invalidating these tokens. So you cannot prevent Kube Controller Manager from creating new ones, but you can at least invalidate them. And if you are interested in this, then just talk to us. That's actually something that we implemented for our clusters in Gardener, because we also support older Kubernetes versions, like below 1.24, and still want to have the same security level for all of our clusters. Okay.
All right, so now that we know how to use short-lived credentials in Kubernetes with projected service account tokens, let's take a look at the other part of the house, so static credentials. How do we rotate them? In every Kubernetes cluster, there are several static credentials involved. So most importantly, there's the cluster CA, which is used to sign the serving certificate of the API server. But there's also a client CA that is used to sign client certificates for the kubelets to authenticate against the API server. These CAs are typically valid for quite a long time. In Gardener, it's 10 years. In GKE, it's even 30 years, so quite long. There are also other type of credentials like the etcd encryption key or the service account signing key, and these don't have an expiration time built in. So to keep our clusters safe, we should frequently rotate these static secrets. But how do you do this at a scale where you manage thousands of clusters like we do with Gardener? It has to be highly automated, and most importantly, it has to be disruption-free for our clients to get the best experience. So for this challenge, we came up with the following approach for rotating the static credentials in Kubernetes clusters. The rotation is happening in two phases. In the first phase, we issue new credentials, but keep accepting both old and new credentials. And in the second step, we invalidate the old ones, and with this, all the old credentials are gone. What you notice now is that clients need to comply with this process, otherwise it will be a disruption for them. So they need to refresh their credentials after triggering the first phase. And then, once they are ready, they can trigger the second phase and invalidate the old credentials. How does this look like in more concrete terms for server certificates as an example? So before the rotation, we have the old CA that is used to sign the server certificate, and the clients only know about the old CA, obviously, so they only trust this one. In the first phase, the server certificate is still signed by the old CA because our clients don't know about the new one yet. But they start trusting the new one as they fetch the credentials after triggering the first phase. So they will pull that asynchronously and start trusting the new one. So they are ready for the next phase where the server certificate is finally signed by the new CA. And then again, asynchronously, the clients can refresh their credentials so they don't trust the old CA anymore, and then it's completely gone from the system. Looking at client certificates, it's a bit different. So again, before the rotation, we have the old CA, which is used to sign the client certificates, and the servers only accept clients authenticating with the old CA. When we start the rotation, the server keeps accepting old, but also the new CA for authentication, and we start signing new client certificates with the new CA. So when the clients refresh their credentials, they get a fresh client certificate that will be trusted from the API server from now on. And in the second phase, the server stops accepting client certificates signed by the old CA, so all old client credentials are invalidated. By the way, this bundles approach, so keeping old and new in parallel, also works for other type of credentials like the service account signing key. There we use the same approach. The key elements of this principle is that clients need to comply with our rotation. Otherwise, it won't be possible to do it in a disruption-free manner. So they have to refresh their credentials after triggering the first phase. The clients could be humans, for example, using kubectl with a kubeconfig, including a CA bundle, but it could also be cluster components that we control, like the kubelet, using a client certificate. But obviously, we cannot control all the clients, for example, the human clients, so they have to comply and trigger the completion of the rotation once they are ready and have refreshed all their credentials. But if we do control all the clients, if there are non-user facing credentials, we can use the same approach to automatically rotate in a disruption-free manner. So now that we know about the approach we took, how did we implement this? We introduced a new library in Gardener, which is called the Secrets Manager, and this is our implementation in Go of this approach I just described. So we can use it in all of our controllers. And the Secrets Manager manages all types of credentials involved in every Kubernetes cluster in all of Gardener's clusters. So without talking too much about it, let's jump into a live coding session where I can demonstrate this. For my demo, I have prepared a small Go program that is set up to talk against my local kind cluster using a controller runtime client, and I have already initiated a Secrets Manager instance. It just takes a context, log, and a Kubernetes client, most importantly a namespace where it should manage all the secrets, and an identity to distinguish it from other instances. We will take a look at the config later on. I have already written some code to generate a CA that we can use in our demo to sign a server certificate. This is this call right here. We get a secret back, and we just log the name of it so we can start using it. So let's start running this against my kind cluster. Right below, I'm watching all the secrets managed by the Secrets Manager. So there should be some after running this. We see that the Secrets Manager now generated 2 secrets actually. One is the actual CA secret, which includes the public and the private key. And the other one is a bundle secret that includes all the public keys. Right now, there is only one instance, one version of the CA, so the bundle only contains one. If I run this code again, we will see that nothing happens. We can still use the secret that the Secret Manager manages for us, but it keeps the source of truth in the Kubernetes secrets, so it won't regenerate them if not needed to prevent any disruption. Okay, so now that we are set up, let's write some code to generate a server certificate. So as seen before, we can use the Secrets Manager instance, call generate, and then we give it a secrets config. This time it will be of type server certificate, not of CA. Let's give it a name for the Secrets Manager. And now we can pass all the usual properties of a certificate, like the common name, for example. The last thing we need to do is tell the Secrets Manager which CA to use for signing this. So let's give it this option right here. Tell it to use the demo CA we just generated. Let's make sure we don't hit any error or otherwise panic. And let's log again the name of the secret. Okay, let's run this again. As we can see, the CA is still the same. It didn't regenerate it as before, but there's a new secret in the system, which is called demo server-something. Let's take a look at this one. So as you can see, this is just a plain Kubernetes secret. There's nothing fancy happening here, no custom resources or whatever. It uses the usual keys under the data section, and we can see a lot of labels that is used by the secrets manager to distinguish this secret from others, determine when to regenerate the certificate if the config changes or the CA that is used to sign it changes. One interesting note here is that the secret is configured to be immutable, meaning that the data section cannot be changed. This is interesting for scalability purposes because the kubelet doesn't have to watch the secret for changes if it's marked to be immutable. This takes off load of the API server. And instead of changing an existing secret, we just generate a new one with a random suffix instead. Okay, so now that we have prepared our credentials, let's start rotating them, because that's what we're here for, right? So in order to rotate them, we can trigger the first phase by telling the secrets manager when a given secret should be rotated. So let's say the demo CA should be rotated right now. We pass this on to the config of the manager to tell it about this. Now let's run it again. So as we can see, there is a new demo CA secret with another suffix here. It was just generated 8 seconds ago, and the old CA secret is still kept. And right now, a new CA bundle secret was generated, which should include, at least in theory, both our CA. So let's take this one. Okay, there are 2 public certificates in the bundle secret that we can use for trusting our server now. The last thing we need to do is complete the rotation, because right now the demo server certificate is still signed by the old one. You can see that at the timestamp. So to trigger the second phase, we need to ignore the old secrets of the demo CA, basically just dropping them from the system, which will automatically generate a new certificate for our server. So let's run this. As you can see, the old CA secret is gone. It's basically disappeared from the system. Our bundle was again regenerated to only include the new CA, and the demo server secret was also regenerated to be signed by the new CA. Okay, let's come back to our slides. Okay, to wrap up this demo, we have seen that the secrets manager uses the Kubernetes secrets as its source of truth, and this is how we implement this 2-step approach. But it is obviously also applicable to other applications, not only Kubernetes as an application. And if you want to give it a try, the Go library is also available for importing in your controllers. The secrets manager has even more features that we can take advantage of. So for example, next level would be our automatic rotation. We can activate this for non-user facing credentials. So for example, for our internal webhook CAs, we specify a validity of only 30 days. And the phase 1 of the rotation is automatically triggered when approaching end of the validity. After 24 hours of this first step, we complete the rotation by triggering phase 2. And with this, we have a completely disruption-free and fully automated rotation mechanism to adhere to security best practices. What are the key takeaways of our talk today? Let's wrap it up. First of all, we should use short-lived credentials wherever possible, because they are rotated for us, right? We don't have to take care about it. If there are any static service account tokens remaining in our older clusters, we should delete them or at least invalidate them to minimize the security risk. And if we can't use short-lived credentials, then we can rotate the static credentials in two phases. We use the bundles approach in between the two phases to make it disruption-free. We implemented this for Kubernetes as a workload in Project Gardener, but the concept is also applicable to most other workloads. And with this, on to your questions.
Any questions here?
Thanks for the talk. Was there a specific reason for using the secrets resource inside of Kubernetes when storing these certificates that you generated? Is it kind of the idea that these kind of controllers that manage these ones are privileged because reading and creating and kind of updating secrets is quite a powerful privilege in the cluster? So I guess this is not something that each individual controller will do, more that they will kind of get it all set up before they even start. Is that correct?
That's correct, yeah. In our case, there is a central controller running inside a component called Gardenlet that manages all of our user clusters and manages all of them. So it also has to know all the secrets to talk to these clusters. So it's already a privileged component, and all the other ones don't need privileges to read and write the secrets. But we keep it central in this location, and it's native to our workload to use just simple secret resources. It matches our pattern, basically.
Okay, yeah. I was just thinking if you had considered kind of using a custom resource because there is not more or less kind of encryption in them, if we say it like that.
Right.
Our planes. So, yeah. Okay, thank you.
Do we have more questions?
I think this is it then. We will be back for a panel talk at 11. So we have a little bit of a break now. And we'll see you then. Yep.
Thanks for listening.
Yeah? Okay. Yes. I can hear that reverb, right? Can you? Yes. Yes. Works fine now. No? Frank? Yeah, okay, perfect. Okay. Sorry. Testing. 1, 2, 3. Okay. We're back for a panel talk now by Adriana, Reese, Rin, and Austin's going to be moderating. It's on. It's something that I'm actually curious to hear too. It's about how community powers the adoption of open source. It's going to be a 30-minute panel talk. It's just a quick word in for panel talks on rejects. We've done very few of them. I don't even remember if we've actually done one with a proper moderator built into the panel talk, and one of us didn't have to moderate ourselves. So this is quite exciting. We have another panel talk after lunch. So yeah, watch out for that one as well. That's, can't wait. Take it away.
Well, if you're excited, then imagine how I feel since I got off of a plane at 8 a.m. local time, so.
Woo! You're here! Yay!
But I'm here! I am here with some of my wonderful friends that I have made through this wonderful thing we call community and open source. See what I did there? Nice little segue. So, I am Austin Parker. I am a developer advocate. I am a community maintainer for the Open Telemetry project. And today, me and some of my friends are going to talk about how we have brought community together to help grow this project, Open Telemetry, from something that was honestly fairly small a couple years ago to now the second highest velocity project in the CNCF behind Kubernetes. So this is a pretty free-form discussion. We're going to start by kind of introducing everyone and talking about, who we are, how we came to this project, and then we're going to tell you about kind of one specific case study of a thing that we made called the End User Working Group, and then we have some takeaways for you at the end, where if you are a maintainer of an open source project, maybe those will be very useful to you. Without further ado, let's talk about who we are, how we came together. First, I'd like to introduce Reese.
Oh, I am first. Well, hi everyone. My name is Reese. I am a developer relations engineer by day at New Relic, and I also work with these lovely people on the Open Telemetry End User Working Group.
And how did you come to telemetry?
Oh, how did I come into it?
Yeah, like how was your first interaction with the project, or how did you get into it, or even into observability in general?
Oh yeah, so New Relic is a data analytics platform, and I was hired onto the Open Telemetry team. Actually, I came there from technical support. Shout out to whoever else has done technical support. Vital teams to a lot of software products. And yeah, I kind of heard about OpenTelemetry as a peripheral. I was supporting our proprietary APM agents, and it sounded like something really interesting. I never worked in open source directly before, so it looked like a really interesting challenge, and here I am.
Now, here you are. All right, next up, Adriana.
Hey, I'm Adriana Villela, Senior Developer Advocate at Lightstep by day, Boulder by night. Also involved with the Open Telemetry project.
I'll ask you the same question. What brought you into Open Telemetry and observability?
So my first foray into observability was my job before current one, where I was actually managing an observability team at 2 Cows. And I was trying to pivot the team from just managing tools to instead focusing on practices. And I wanted a way for the teams to be able to instrument their code in a vendor-agnostic manner rather than be beholden to a particular vendor. So I stumbled upon Open Telemetry and spent a fair bit of time trying to convince the organization to use it and to convince developers to embrace it. So that was my initial involvement with it. And then when I joined Lightstep, I actually got to become an Open Telemetry contributor, which has been really awesome.
Cool. Next up, we have Rin.
I'm Rin Mancuso. I'm the community manager at Honeycomb.io. I'm on Team USA Paraclimbing by night, and am a karaoke nerd.
I hear this is a good place to be a karaoke nerd. How did you get involved in OpenTelemetry and observability?
Yeah, so before coming to Honeycomb, I actually was working at New Relic with Reese and was sitting on the marketing team and really excited about trying to work with OpenTelemetry. Clearly felt like this is the future. We need to be talking about how well we can interoperate with other vendors, because the reality is things are complex and very few DevOps teams are using one solution for all of their monitoring, logging, observability needs anymore. And, didn't quite manage to convince the marketing team there, but when I had the chance, I jumped to Honeycomb, which explicitly mentioned this in their job description, and kind of pretty immediately dove into the project, set up by Liz Fong Jones, who was one of the founding members of the project, who was there and was ready to step down. I got really involved with the end user working group, which felt like the right place for me to work, and we'll talk a little more about that in a second. I was wondering, how many of you need a definition of OpenTelemetry? Does everybody kind of know what it is? It's not that important to this talk, but.
Do you want one? OpenTelemetry is a, oh gosh, see, this is why you shouldn't do this on 2 hours of sleep. OpenTelemetry, I actually should know this.
I know, it's like we might have 4 different definitions, that might be a game.
I remember it. The goal of OpenTelemetry is to make observability a built-in feature of cloud-native applications. It is an instrumentation framework and library, right? So if you're familiar with Tool, if you're familiar with StatsD, if you're familiar with Prometheus, if you're familiar with various logging frameworks or application performance monitoring, APM tracing frameworks, then the goal of OpenTelemetry is basically to create an open standard for creating that data and expressing that data, and then having a vendor agnostic way to kind of ship it off somewhere, right? So instead of being tied into like a particular vendor, one proprietary platform for both instrumentation and analysis of data, now your instrumentation and the data itself is agnostic to where it goes. And we believe as a project that this is really good for you, the end user. And might as well pivot over to myself. I am, of course, Austin Parker. I run the developer relations team at Lightstep, and I have been involved in OpenTelemetry since the jump, quite literally. I was looking through my Google Drive a little while ago, and I found the document that I had put together about this very nasty Twitter fight that was directly responsible for the rise of OpenTelemetry from all the way back in 2018. So on the project, I am a community maintainer, so there is both elected and unelected sort of governance positions in OpenTelemetry, and I am one of the unelected ones, so I kind of manage the overall community engagement with the project to make it great for our contributors and end users alike. Outside of that, I wrote a book on distributed tracing. I'm the guy that did the Animal Crossing DevOps conference, if you've heard of that, and I have a fun hat. So, let's start by, we all talked about how we individually got kind of involved in this project and what brought us to observability, but I think to discuss, to really dive into this, we need to understand, what brought us together in the roles we're in, right? Because in a lot of open source projects, especially large cloud native ones, right? Because there's a few decent examples of what does a cloud native project look like. You obviously have Kubernetes, Prometheus, all these sort of things. But one recurring trend is that for the most part, they tend to be aligned around one single very large contributor, one very large single commercial contributor, right? And this is not a value judgment. This is just the way things are. Kubernetes broadly is run by, Red Hat and the IBM, and various components and SIGs within Kubernetes are run by effectively large vendors in those spaces. And this isn't, again, it's not a bad thing. This is just the way that expertise tends to flow, right? Like there are people that know a lot about storage that work for storage vendors, so obviously they're going to be very interested in solving storage problems. You also see projects like Linkerd or Backstage, where these are very much attached to like one particular commercial interest. OpenTelemetry came into this with a slightly different portfolio, where OpenTelemetry says, well, there's all these different parts of actually instrumenting software systems, and historically, a lot of that has been tied to a particular vendor. So if you're a Datadog user, then you install the Datadog agent, and Datadog has all these integrations they maintain for Spring or for Go or for MySQL or whatever you're using, and you click on that and it integrates and da-da-da-da-da. But then if you wanted to switch to another vendor, you would have to replace that instrumentation. And if you were a developer of a framework or a library or some sort of open source product, you had this really challenging problem of how do, my end users want metrics, they want logs, they want traces from my software, but what do I target? If I target Datadog, I am now kind of like writing everyone off that isn't a Datadog user. If I target various open source things, then there's still conversion work that needs to be done. So this is the world that OpenTelemetry was sort of pushed into, where there's a lot of options and none of them are great. Meanwhile, there is increasing volumes of data, increasing need for developers and DevOps and SREs and operators in general to understand these complex systems at scale. So how can we fit into this? Well, we can create OpenTelemetry. We can create a project that standardizes all this stuff and gives a standard for developers to actually like plug into, right? So if you're a framework author or a library author, you can just target OpenTelemetry SDK and data model for your telemetry, and bada bing, bada boom. So, but this also causes another problem, which is all the expertise on doing those integrations and instrumentations is also all wrapped up in vendors, and vendors are also like extremely interested in how OpenTelemetry gets made, because if they are going, if I'm a sales or marketing or a product person, and I'm, someone's like, hey, you should put all of your eggs in terms of data ingest into this project that you don't have any control over, a lot of them look at you like you've grown a third head. So invariably, OpenTelemetry becomes a place where a lot of different vendors are interacting with each other. And when you have all these different vendors interacting with each other, how do you kind of square the circle, right? How do you make sure that people are actually focused on the project users and not, just their commercial customers? And this is kind of the question that led to the formation of the end user working group. And I think, Rin, you have some thoughts about this.
Sure, yeah, and I'll add to what Austin said that a very real-time example of this is we're talking about sampling right now. So every vendor, if you work in the DevOps space, prices a little differently. Some might price on events, some might price on gigs of ingest, some might price on gigs of storage. And so sampling, deciding what you send to the tool and how long you retain it, has a tremendous influence on vendor pricing. And so the decision we make there could literally cause people to reevaluate their pricing structures. So lots of interest, lots of different vendors, and lots of decisions in the project are like this. But what we figured out that we were missing, back in the day, I used to work at a place called Tidelift, which works with individual maintainers. In the individual maintainer space, you talk a lot about incentives not quite being aligned. They're about to do a conference this summer called Uplift about maintainers being put in a supply chain perspective, like having to literally worry about security or worry about filling out like your vendor procurement forms, and like what's their incentive to do that? They don't have an incentive to do that. At the cloud native level, pretty much everybody is participating on behalf of a company. Their company's paying them, so we don't have the solo maintainer problem of I'm not actually being paid and I've built this thing that's holding up part of the internet, please help. The problem that we have is that the companies that are incentivized are all vendors. And how do we get to the point where we're actually able to take the feedback of end users seriously and give them ways to engage that fit with the amount of time that their company is able to prioritize for this work, and that give them meaningful return on their investment, like growing in their use of OpenTelemetry. That's how we think about sort of aligning incentives here. And frankly, this is probably a challenge in your cloud native project. It's probably not quite the same as how ours is mapped out, but you've probably got end users who don't really have any particular need to participate right now.
So, Reese, you've been involved in the end user working group really kind of almost since the inception, I think.
Yeah.
Can you talk a little bit through like how that was put together and sort of what what it does?
Yeah. So, at the core of it is what good is a software project without end users, right? You could write like the best code, most efficient code, but if no one's using it, where do you kind of go from there? Like, what's the goal? And so there was recognition for a need for a group, so the end user working group that we are now all part of, to create a space that's vendor neutral for our end users, so that they can have this community of people that can help them navigate the project, help with adoption implementation questions, and then also thinking about it from the other side, which is, hey, this community of end users is a really great way for us to get feedback on the project and feed that back into the people that are working and creating the software to help improve the project and help increase adoption and implementation. And so to that end, we have two overarching goals, which I kind of touched on just now, which is to create that vendor neutral space for end users and to create this feedback loop, which is another challenge that we're kind of working through right now, as how to kind of streamline the whole process so that we can make sure that the SIG priorities are aligned with user priorities. We have several activities that I think we're going to go into that we host every month. We have a lot of end user resources that we've created and are still working on improving. So we have like a monthly user discussion group, OpenTelemetry in Practice, which is a series of talks, which I think we'll get into a little bit later, as well as Q&A sessions to document like interesting use cases and common challenges that end users face when they are getting into OpenTelemetry, and a couple other, I think we have like a private Slack channel and, what am I blanking on right now? I feel like other things that I think we will come to in a minute here.
I think there's even a link at the end so you can find all this stuff out for yourself.
Yes.
So Adriana, like let's talk about some of those. Let's talk through some of those activities, right? Like what are you involved in, and which ones do you want to highlight?
So one that I think is really worth highlighting is our end user Q&A sessions. We hold them every month, and they're actually lots of fun because we find folks who are practitioners of OpenTelemetry in the community, so we can hear like stories of how it's used out in the wild, and it's basically an interview style session that we hold every month. And I think we're having one every month except this month. But basically the format is, it's an interview style, and users share like how they're using OpenTelemetry, how they got into OpenTelemetry, what some of their challenges are around OpenTelemetry, how they brought it into their organization, because we do find that a lot of users are curious, like, how is it that you are using it? How did you convince folks in your companies to bring OpenTelemetry in? And then another thing that's super important from these Q&A sessions is we take user feedback. We want to know the good, the bad, and the ugly, like what has worked for you, but what are some of the things that are super challenging for you in terms of using OpenTelemetry? And the whole point of that is to be able to bring that feedback back to the maintainers of the various SIGs so that they can help to improve the project.
I think there was a couple more. Want to go, Ren?
Oh yeah, OpenTelemetry in Practice.
I think.
Yeah, so I run the OpenTelemetry in Practice series, which is we were trying to solve a couple problems with this. One is that there's no good place to go for intermediate to advanced OpenTelemetry education. At conferences, usually because it's a broad audience, folks are giving pretty broad, introductory level talks. What is OpenTelemetry? Because it's only a 3-year-old project. Maybe if you're lucky, sampling 101 in OpenTelemetry. So part of this was the desire to be able to create spaces where we could go and talk about implementing OpenTelemetry in specific languages. The second thing was to create a speaking opportunity for end users. So the way we've created this is generally we have one person who gives a hands-on code tutorial. A lot of times that is a DevRel from one of the vendors, because that tends to require a lot of time and prep. Sometimes it's actually been an end user, but and then we have an end user come in and do a conversation with them on like, how am I actually implementing this in my company? So maybe you see the DevRel do a demo of, here's some of the basics of how to implement in .NET and some of the considerations I might have in like how I'm going to set up my architecture to support this. And then the end user comes in and is like, well, okay, this is how I'm actually doing it in my system. These are some of the hiccups and challenges I've encountered. And then we kind of open it up to a discussion with the two of them and with everyone else. And if there's an audience there who is already actively implementing in that language, we kind of do polls and questions to kind of hear from them as well. And this is monthly. It's a ton of work, and we might shift to a less frequent format. But it's been really great as sort of a flagship to, I think, pull people into the end user working group and make them aware that this exists and is a place that they can come and give feedback. Yeah. Reese, you should talk about the discussion groups and the feedback.
I'd also want to point out, though, just like one interesting compare and contrast is that if you look at like how this is normally done, is a lot of times you'll get published case studies, right? Where like Kubernetes is a good example of this. I think when Kubernetes graduated, I think there was like 35 case studies from actual, production users. And what we're doing, I mean, it is a case study, but it's not quite formally documented in the same way, right? And I think there are trade-offs here. And I think we've experienced a lot of those, right? Where we're doing something that is more, very much focused at the implementer level versus maybe the buyer, if you could think of it that way. And one of the rationales, at least I have, is that OpenTelemetry doesn't really need someone to sell it, because we actually have this very strong vendor community that is selling it for us, right? Like observability vendors are very motivated in making sure that OpenTelemetry does eat the world. So I don't really need someone to go and say like, oh, you should use this, it's better than blah, 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 blah. The work itself will prove that out. What we need are places for, actual implementers to come together and be like, hey, wow, this thing changes quite frequently, and here's how we're dealing with that problem. But anyway, yeah.
No, so I think like that's another kind of good use case for the end user discussion groups, which I'm recognizing, there might be some confusion around like the different names. You have like the Q&A, which is more of like an interview/feedback style session where we talk to just one team at a time from like one specific company. And then we have the end user discussion groups, which are monthly and available in the Americas, EMEA, which is Europe, Middle East, and Africa, and then also, as of earlier this year, the Asia Pacific region. And it's just a chance for end users of OpenTelemetry to get together and discuss challenges, questions that they're facing with implementation and adoption. And we also have either a member of the governance committee or a maintainer come on to provide extra context and insight into questions that these end users might have. And we also started making these more discoverable. So we used to keep them kind of more private and not recorded, but they are now recorded. We are summarizing these discussions on the blog. So you can go onto the OpenTelemetry blog at any time and see the summaries for the past few months since we started doing them. But we're going to have them every month so you can kind of see like, okay, what are people facing as they're trying to use OpenTelemetry, and how can these help me with my journey as well.
I wanted to add also, like, it's so useful reading the summaries, because I find like every time I either read the summaries or attend one of these things, I always learn something new that I did not know was happening in the world of OpenTelemetry. And I also wanted to add that we also do blog summaries of the OTel Q&A sessions.
Yes.
So on that point, let's talk about sort of the takeaways from this, right? Obviously, it's hard to get through all of this in 30 minutes, but maybe let's just go down the line. Like, what's your one big thing that you want people to take away from this panel? Start with Adriana.
I think the one big thing is I want to make sure people understand, like, this is like, we really foster a sense of community. This is something that is open to everyone. We want to hear user feedback. I think like for any like open source project, having an initiative like this is so helpful, both to the folks who are using it and for the folks who are involved in maintaining it.
Mm-hmm. Grace?
Oh man.
Player pass.
Rit, you go.
Yes. Yeah, I think the biggest takeaway I have from it is that you have to decide at some point in the life of a community who you really want to hear from and who needs to be evangelizing. And in our case, as Austin pointed out, we do not have a problem with vendors evangelizing OpenTelemetry. A lot of them are bought in and doing very well. But like, who trusts your vendor to tell you what you want? So something that was really important for us is not only to get end user feedback for, as Reese talked about, the maintainer community to make the project better and improve our developer ergonomics, but also to get end users out there talking, feeling confident about talking about their use of the technology, because they're not doing that naturally.
Yeah, no, the best advertisement is a happy developer. With that said, we unfortunately don't have a lot of time left for Q&A, but we are all here most of this week, and if you would like to see what the working group is doing with this QR code, you can also go to the OpenTelemetry organization on GitHub, look in the community repo, and you will find links to notes and various other things. We're on the CNCF Slack in the OpenTelemetry channels. Again, just go looking for us and you'll find us. And if I can plug one thing. So if you want to hang out with us and you're here tomorrow night, then we're doing a little party. But yeah, like, would love to, if you would want to continue these conversations or learn more about OpenTelemetry, feel free to come by and have a drink on our employers tab.
Let me also throw in, we have a workshop with the Maintainer Circle.
Yes.
That is at
Thursday.
11 a.m. to Wednesday.
Wednesday.
And And it's not on the CNCF program because it is limited to folks who have a substantial amount of skin in the game with some CNCF project. You don't have to be formally titled maintainer, but so if you're interested in actually like grouping up with other CNCF projects and talking about how you can implement this framework of identifying who might not be incentivized to contribute in your own project and creating ways for them to contribute, come hang out with us for an hour then.
And if you would like some slashy OpenTelemetry limited edition KubeCon 2023 Europe sticker, as
it does not stick well to my mask, but it sticks well to everything else.
That means to measure is to know in Dutch, apparently. Thank you, Google Translate. So if you would like one of these, please come find me this week, or other people in the OTEL community. Check out our project booth if you want to learn more about OpenTelemetry and see a demo. That's about all I can really think of. So, yeah, I hope to see you all around. If you'd like to ask us any questions or anything, you can do it after this. And thank you so much for your time, and thank you for having us today.
Thank you. Thank you all.
Thanks for the lively panel talk. We can take a quick question, if there's any. Just very quickly.
Hi, thanks for sharing. It's really interesting. You mentioned, happy developers are the great evangelists. What's the secret trick to get, end users to share and talk? Because that's something that I think every project always struggles with. You always have like the 3 or 4, they're always everywhere. Like, what do you do to foster more people, especially newcomers, from like sharing their expertise?
I would say there's they're always like hiding out somewhere, the enthusiastic end users. So I think like the socials really help, like social promotion of our various things that we have throughout the month. And even like because we all work for vendors, like we do have access to users who are using OpenTelemetry. So we do encourage, like if we hear about like someone who is super stoked about OpenTelemetry, I often I'll be like, hey, how about you come and talk to us for the Q&A session, or maybe you want to do something for OTEL in practice, and that seems to that seems to help like get some people out of the woodwork and get them to present their stuff out to the world.
Yeah.
And then as other end users see that, then they're like, oh, actually, I also have something kind of interesting, or either parallel or perpendicular to share.
Right,
That
and
makes sense.
the discussion groups as a place to ask questions, that is super easy for you to implement. You just kind of need to hold the space. It's not a lot of prep, and the discussion, we hook them by saying, we're going to answer your questions, but pretty soon we find out a lot about their setup and who might be excited to talk, and it becomes a little circle, and soon those people are on OpenTelemetry in practice giving formal stuff.
Yeah, and there's always someone in the end user discussions who you kind of identify, like they ask a lot of questions and we're like, hey, how about, are you interested in coming and talking about these other things? So that's a really good way to identify people as well.
And from my perspective, the real goal is just get people to become, advocates in their own right, right? I think the work, and I want to be clear, most of the work that is actually all them, right? I'm just up here to look pretty. But as a community maintainer, my goal is how can we take people that are coming into these end user sessions and have them build confidence so that they can go to their communities and that they can go into their localities or whatever, and they can start doing this sort of stuff, and they can become evangelists for the project as well, because that's the only way that it's going to actually work, right? People trust other people. They don't trust banner ads. Anyway, we'll be around if you want to continue talking with us about this. Again, thank you for your time.
Thanks, guys. That's all we have time. Our next talk is at 11:40. We'll see you then.
Be upstairs for the next one. I want to be
All right. Yeah? Okay, wonderful. Yeah. All right. Settle in, everybody. It's now time for a talk on using WebAssembly. And yeah, we're still waiting for people to settle in a little bit, but yeah. I'm going to repeat that. It's now time for a talk on using WebAssembly and how easy it is. And we'll have Brooks and Taylor talk about this. They're from Cosmonic. Yay!
Alrighty. Is this thing on? Y'all can hear me? Yes. Great. Hello, everyone. Welcome to Using WebAssembly Now. It's easier than you think. I think we can go ahead and start off with a couple introductions before we talk about the agenda for this talk. I'm Brooks Townsend. I'm a lead software engineer at Cosmonic. I've been a Wasm Cloud maintainer, which is the open source side, for the last 3 or so years. Serial open source contributor, love writing code in Elixir, WebAssembly, and Rust. And I'm a demo enthusiast, which you'll get to see today.
Yeah, there'll be plenty of demoing here. I'm Taylor Thomas. I'm a director of engineering at Cosmonic. I am primarily a Rustacean. I do a lot of Rust. Got that way from being a Gopher. So I have, just as a little bit of background, I write in a bunch of different languages. I was the co-creator of Crestlet and Bindle, 2 different WebAssembly-related projects that are out there. I'm also a serial open source maintainer and an emeritus Helm maintainer. We'll talk a little bit about that some more later. I have another talk later where I'll talk a little bit more about that from the Kubernetes side of things. So yeah, we're gonna go ahead and get started. It's really cozy up here. I kind of wanted to start like napping on this couch right here, but instead we're just gonna go ahead and get started. So what's the agenda of this talk? This is what we're gonna try to like achieve by the end here so you all know what's going on. So what's a WASM? We want to answer that question first for those who might not be familiar. Where does it all fit in with everything? And then we're going to have a whole crap ton of demos. And then we'll say, well, what can we do now? And then we'll finish up with some how to get involved. So with that in mind, I want to ask a question before I dive into this. How many people have heard of WebAssembly? Okay, good. I'm hoping so if you're attending this talk. The second question I have is how many people here have actually used WebAssembly for something? Not just like looked at it, but like actually compiled something to it or whatever. Okay, this ratio is holding pretty true at all the past things I've talked to right now. It's about 1/3 of the people who know about WebAssembly have tried doing something for real. So I'm going to go over what exactly is WebAssembly so that we're all on the same page, and then we'll go from there. So if you've been paying attention at all, you've probably heard me and several other people in the industry say this several times. WebAssembly is neither web nor is it assembly. Kind of a dumb name then, I guess, but that's what it has. And it kind of came from first being adopted by the web community. And it was really appealing to the web community for a couple of reasons. Number one, it was a completely open standard. It's in the W3C. It's controlled by the standards and governing bodies there. That's something we all desire as developers nowadays. We want it controlled by not a company. The next thing is that it's very safe and secure. So WebAssembly is all like sandboxed by default. It's very, very locked down. That's critical for a browser. It has capability-driven permissions, which if you're not familiar with that model, that's exactly what happens on pretty much any modern phone nowadays. Can I use your mic? Can I use your camera? That's capability-driven permissions. And then it's very, very small and fast. So when we're talking about this being small and fast, it's way, way small. You're talking about really tiny binaries, and it runs at closer to native speeds, a lot closer than you're ever going to get with something like JavaScript. It's also polyglot, meaning most languages can compile to it, and you can reuse existing libraries in each of those languages. And last but not least, it's portable, right? You can't have something that works in the browser that only works on Linux or only works on Windows or only works on Mac. You have to have something that's portable and goes across all the systems. Now, if you stop and think about it for a second, these things all right here are the exact things we want inside of cloud-native applications as well, right? We want open standards. Why do so many projects in the space belong to the Linux Foundation or CNCF? Same reason. People want it. As a developer, we want something that's not controlled by a company. It's also very safe and secure, right? One of the selling points of containers was we're all completely locked down. It's very efficient and fast. And I'll talk a little bit more about some of this in a second, but essentially, these WebAssembly modules are about 1/10 of the size of an equivalent Docker container, even if it's trimmed down doing the same thing. And it's going to be running without the overhead of a Docker runtime. Then you also are looking at polyglot, right? We don't want to have to write or adopt specific languages to be able to do things. We want to be able to use the tool sets we're used to. And then last but not least, it's portable. Once again, this is where containers, we say they're portable, but they're actually not, right? You have to build a separate one for every architecture. And then Windows containers are an entirely separate beast from Linux containers, and Mac doesn't even have containers. We pretend to by shimming a VM. So WebAssembly is truly portable. I can build something on a Mac, have it run anywhere else. I can build something on a Linux machine and have it run anywhere else. That's one of the powers of WebAssembly. So good versus bad here. Okay? I wanted this to be very practical. So, what's the good stuff on the left and what's the stuff that's not so good right now on the right? And what is it good at? And the first thing is that it's very good at general server-side computing. So we're talking about microservices, functions as a service, those kind of things. It's very good for general server-side compute. I need to calculate an interest rate if you work for a bank, or I need to calculate permission thing this, or whatever, common stuff you see at most businesses, it's very good at. It's also very good if you need runtime optimization things. There are multiple runtimes for WebAssembly. It's not just one. This isn't like what happened where Docker kind of steamrolled everybody unintentionally or intentionally, depending on your opinion. This isn't one of those things. There's WASM time, WAMR, WASMer, WASM3, I could keep going. And all of these runtimes are catered to different profiles but run the same WebAssembly modules. It's also very good for constrained devices, which I'm using with big, huge air quotes, the edge, right? Like we all like to call it. So I'm talking about small devices on in storefronts or Raspberry Pis. I'm also talking things like cell towers and power stations and those kind of things where you can have constrained or devices that are very separated from your network. Also, I think WebAssembly is very good at plugins. It has the potential to be the last plugin model to rule them all. Because you can write from any yes, the last one. Because it's every language can compile to it. It has standard formats you can call, and then you don't have to worry about this whole defining an interop or using standard in, standard out. It's also very good at libraries, which I'll mention a little bit more here in a second. There's some things around the component model, which I'll talk about there. And it's, of course, very good at the browser. So think things like Photoshop or AutoCAD or those kind of things that they now have online. That's powered by WebAssembly. The difficult thing is that we have networking is still an issue. This is becoming very close to not being an issue anymore, but it's still an issue. You want to do networking with WebAssembly, it's a little bit more difficult. We didn't get socket support until about 6 months ago. Roman's in the crowd, he helped do this, so 6 months ago-ish, right? 9 months? Anyway, and we didn't get it until that long ago, and it's still not fully available and easy for everybody to use in all situations. We are also now very much in the fast-moving stage. If you were here for the Kubernetes wave of innovation, we're very much in the middle where things are changing on sometimes a weekly basis, and so that can be difficult for some people to swallow. It's also never going to be as fast as native code. Now, let me just be, the flip side of this is unless you're doing something super performant, this doesn't matter because the performance penalty is still much better than running an overhead of running it in Docker. But if you're talking over a network boundary, it doesn't really matter if you're optimizing for microseconds of time when you're actually running. Also, tool chains just aren't there. You're never going to have a lift and shift with WebAssembly. There's not going to be the equivalent of taking your bajillion gigabyte Java application and dropping it in a container and calling yourself cloud native now. You can't do that with WebAssembly. So that is an important downside. And also, there's some domains that really aren't a good fit yet. They could be in the future, but right now they definitely aren't. Think performance-tuned applications, things like databases, or I don't mean this in a derogatory way. I mean legacy or well-established applications, right? I mentioned some of these up here. You're not going to go port Nginx or Redis or MySQL. People have done that, by the way, to WebAssembly, but you're not going to get all the performance and stuff for that right now. So that's just kind of the good versus the bad. Now, this is where we come into Wasm Cloud. Wasm Cloud is a CNCF-maintained open source project, and this is really to answer the question, why do we even have this Wasm Cloud thing? And I want to answer that. If Wasm's so good, why do we need something like Wasm Cloud? So this is where we get into the difference between a runtime and an application runtime. Runtimes are things, think about Node or JavaScript versus React. and think about Docker versus Kubernetes, right? One is a runtime, one is an application runtime. One lets you run things at a whole application at a bigger scale. And Wasm Cloud is an application runtime. But I'm actually going to let Brooks dig into this a little bit more about what the different components are, because it matters for what we're showing you today and that promise of being able to use WebAssembly now.
Yeah, so Wasm Cloud has been around since late 2019. That's when I started working on the project, just a little bit after it got created. And at the very base level, what we're doing is running and orchestrating WebAssembly modules. We have the goal in mind for you to be able to write full applications with WebAssembly. And for a lot of people, just like using React versus just straight up JavaScript, working with the primitives of WebAssembly, which is really numbers in, numbers out functions, and instantiating an engine and a store, those are lower level than you usually want to be when you start thinking about a cloud native application. Think about Kubernetes the hard way. It's a useful exercise, but not what you're going to do every time. We provide the secure access to application level capabilities, things like HTTP servers, key value stores, message brokers, open telemetry, those kinds of things that you expect from cloud native applications. We provide to the WebAssembly modules. Wasm Cloud also handles the scalability of your application, so being able to run multiple copies of a WebAssembly module, multiple Wasm Cloud runtimes, and that's all kind of facilitated by the networking layer, which we use NATS under the hood. It's another cloud native project in the incubating tier, but we manage request routing and failover and all of that. And one of the reasons why we call this a cloud native technology is because it's built on top of so many of the great existing standards that we have today. All the WebAssembly modules and capabilities that we distribute, we do so via the OCI Open Container Initiative spec. So we distribute them as artifacts, not inside containers, but just in OCI registries. We use the open application model for our declarative deployment, so you can define an application manifest and go, hey, please go make this the reality. Same thing that you do for a Kubernetes deployment. We use cloud events for all the events in our system, so they're easily digestible, ingestible from all of these different technologies. And that's, of course, under the hood to power our networking. And as I said, open telemetry, we instrument the entire trace through the system, even though it's a wildly distributed system. So you just basically give it an OTLP exporter, and we can use Honeycomb, Grafana, any of those things. Now, I like going through a couple of the different core things in Wasm Cloud, just so you know when I'm talking about these applications. And the first thing is actors. These are your WebAssembly modules. You write and then compile it to WebAssembly, and you implement only business logic. All of the capabilities, all the runtime things that you access are done in terms of a common contract. So you think of a key value store, basic operations, get, set, delete, those type of things. And the actual implementation you choose at runtime. So your actual WebAssembly module, the application you write, is completely agnostic from all of that. And there's a lot of benefits that I'll show you during the demo. They're really small. WebAssembly modules generally tend to be around 20 kilobytes to 2 megabytes in size, so they're really quick to distribute and then don't require a lot of runtime memory. And they're easy to develop just because you're using those common contracts. You don't bring in a lot of copy-paste code from your other projects. Now, these capabilities are the other side of the contract. It's the implementation for things like HTTP server or message broker. So for message broker, you may use something like NATS. We do it a lot. You may use something like Kafka, where you can consume a topic and publish to that topic or produce to that topic, things like that. And because you choose the implementation at runtime, you can hot swap between those two. So if you want to connect to Kafka one day, next day you want to try out NATS, you just change that. Nothing in your application has to recompile or redeploy to do that. And that decoupled libraries from the business logic is really important for things like vulnerabilities, where these open source libraries that you bring into your application are now kind of managed at the platform layer instead of by every single application piece. And what we call our networking layer is the lattice, which, I had to look up the word or whatever. It's like the linked fence pattern, I don't know, whatever, you can see it. And we use NATS for this. And what this enables is a flattened topology network where cluster members can join and exit and kind of time out and then come back in later on just seamlessly at runtime. You don't have to deal with IP addresses. You don't have to deal with connecting to different DNS names or saying, hey, I'm going to run 3 instances of Wasm Cloud. You just kind of add or remove that as you need. It's very seamlessly connected, and it kind of just feels like it just works, which is really nice. And so, in general, where we see WASM and WASM Cloud and the whole trend of the cloud-native landscape is over time we've seen this trend of looser coupling from the application to the platform. Essentially, the developer responsibility is getting less and less. So from where you might previously image an entire PC to run an application, we got VMs with public cloud. We went on with containers, which run like mini containers probably on top of a VM in public cloud. And so you're abstracting away the operating system, you're abstracting away the kernel. And with WebAssembly, what we see you abstracting is truly the entire host. The WebAssembly binary is completely platform agnostic, and it's really powerful when you're making an application that's going to go and run in a lot of different places. Additionally, that kind of brings in the completely deny by default security model. So everything the WebAssembly module does, it has to ask the host, like, hey, can I please go access this network socket? Can I please access this file? And that's so much more powerful than having something like a container where you can add on many different layers. There's always potential to miss that, especially if it's done by a developer who doesn't really care about what happens at the end of the day. Now, where WASM Cloud comes in is just past this, abstracting libraries out into common capabilities, being able to pick that at runtime, being able to flexibly swap that out, resolve vulnerabilities kind of at the source and only one time. It's a really powerful model to build applications. And so, I'll kind of show you what this looks like, but really the developer just manages their little bit of application business logic, and that's really nice. All right, enough talking. I'll show you one more slide, which is just an architecture diagram, and then we'll get into some demos. So the title of this talk is Using WebAssembly Now. It's easier than you think. And if you've heard of WebAssembly, you look at some stuff on the server side, you probably see some things that look like little demo applications. I want to talk about a few, specifically 2 different domains that WebAssembly is really successful with today. And the first one is like a serverless style, function as a service style microservice, where you just invoke it, it does some quick data transformation or interacts with the database, and then returns some updated data. This is our key value counter demo. If you've seen WASM Cloud before, you may have seen this before. We love this demo because it's very simple. The business logic is, hey, you need to accept some kind of request and then increment a counter and store that new counter and then return, the new value. Very serverless-y. If you break it out in the WASM Cloud terms, you have the HTTP server capability to be able to receive requests and the key value capability to be able to interact with a persistent store of some kind. When you actually write the application, you don't actually pick what store you want. So let's take a look at some of the code really quick for this before I show the actual application. And now this KV counter, we wrote it in Rust, compiled it to WebAssembly. But even if you haven't used Rust before, it's really not difficult to understand the business logic in this code. We have one trait, which is similar to an interface or something in other languages, has one function called handle request. And this is an abstraction of an HTTP server. So you receive an HTTP request and you return an HTTP response. Very basic abstraction of an HTTP server. Do a little path matching to do some fancy stuff. I'll show you in a second with like getting assets, but really what we do is we match the path for a GET request, and then in this function, what we do is we create a new key value sender. We're going to send a request to a key value store, say, hey, please increment the value at this key, and then return that response as JSON. Right, it's going to read really similar in any language, but these are abstractions. You'll notice in just a little bit of code that we have here, what we don't have is how we're going to receive that HTTP request or how it's going to interact with the database or am I going to use TLS certificates, any of that stuff. So when we actually take a look at the application, let's see, I actually have it pulled up. Let me show you it first. It's pretty fun. This is what it looks like. I said we were doing something a little fancy. We have static assets in here too. When we click the button, we're incrementing a counter, right? Getting fireworks, that's also fun. But the actual application is still very simple, and that is actually all powered by that code that I just showed you. When you look at the way that this is organized at runtime, we have our key value counter WebAssembly module, and that has its 2 capabilities that are runtime linked to one HTTP server. It's written in Rust. It's running locally on my machine. It's just like I think it's a warp HTTP server, whatever. And then the actual key value store is just a Redis server that's running on my local machine, right? This is like exactly what you would build if you were proof of concepting this like little bit of business logic. Now, it's great for writing this type of application, but what makes it really powerful when you start to use WASM Cloud is the type of runtime flexibility you get for this app. So right now I have it running all on my local machine. I'm going to actually take this and migrate it fully up to the cloud and then remove my local machine entirely from the equation. So the first step, what we want to be able to do is have a public endpoint. You all need to be able to hit this endpoint on my local machine. You can't go on your phone and hit localhost 8082, whatever. So what we can actually do is we can draw another link and we can connect our key value counter to this publicly accessible HTTP server. It's implemented by Cosmonic. And if we access this wormhole, we can wait for a second. This is going to tunnel down to my local machine and actually hit the same WebAssembly module. And I'll actually open this really quick just while I talk. If you want to scan this on your phone, you can actually do the same thing. Send a request up to a public endpoint, tunnels down to this WebAssembly module running on my local. Really fun.
Pretty sure the public endpoint's running in like US East somewhere.
Yeah.
And Brooks's laptop is in Amsterdam South or wherever we're at right now.
Yeah, so super fun. You'll be able to hit it. You'll be able to increment it. I'll be able to tell. Looks like everybody kind of got it who wanted to. Whoever hit this, oh yeah, a couple people, I guess, hit it. That's pretty fun. So you can actually, you're sending requests, you're storing things in my local database. Great. But we probably don't want to be running everything on my local machine, right? We want to run an instance of this in the cloud. So we can take the same WebAssembly binary that's running on this MacBook, and we can run it on a cloud instance. We call this Cosmonic Managed. It's just running in AWS. And now we can launch another instance of that, and it's great. It'll download and run. And once we do that, we can actually see that there is, where'd it go? There's one running in Cosmonic, running on my local host. Everything, of course, is going to work exactly the same because we're just kind of scaling this out. And then last but not least, what we want to do is instead of storing in a local database, we store it in a cloud database. This could be your DynamoDB, your Elasticache. We have a built-in one with Cosmonic, which just makes it kind of easy to use. You can connect it to any key value store. If you're trying to hit it right now, I did break it. I removed that link to Redis, so it's not going to work. But as soon as we relink that up with the Cosmonic key value store, we can actually go hit that endpoint. And then, of course, see a slightly different number now that we've hit a different database. I've run this demo a couple of times before. So now we've actually taken that application and completely moved it to the cloud. I can find my local MacBook here that's running here in Amsterdam, and I can just terminate it entirely out of the lattice. So it's gone from the network. I could have unplugged an Ethernet cable or whatever. And if you go hit the key value counter, everything works the same because it's gone completely from my local machine up to the cloud. So that type of runtime flexibility with the network and the capability abstraction is really powerful. It's not like you would ever do this when deploying to prod normally, but the flexibility is all there. So this is kind of like the first domain, serverless style microservice. I was able to run it on my local, do some testing, and then migrate that to prod. Same logic, all works the same. Now, I want to hand it to Taylor for a second to talk about, we're doing some things here that are kind of WASM Cloud specific, and let's look at what the future looks like with WebAssembly standards.
Yeah, so I mentioned a little bit about libraries when I was talking earlier, and what I wanted to mention here, this is just a brief aside. We're going to be giving some more talks on this in Cloud Native WASM Day tomorrow, and if you're here for KubeCon, which you probably are, we're going to be at our booth. We can talk about it more in detail, but components is something going on in the whole WebAssembly community right now. And the idea behind components is why not just have everything defined behind an interface, and then that interface can be implemented in whatever language you want it to be because WebAssembly compiles to any language. And so right now what we currently have inside of WASM Cloud is something that looks like the left, where the user managed code includes a library that we have to manage called WASM Bus RPC. But in the future, and we've actually already demoed it, that's what this QR code is for. We've started demoing this. This is our coworker Bailey at WASM.io a few weeks ago showing the component model in action with somebody who is working for Microsoft, running their stuff in Azure, and then our stuff running in Cosmonic using the same code and then talking to each other. This really starts to break down boundaries, but we see a future where you just write your code like you see it now, but we bring all the other components and things to do this. So we already have been thinking about components for a long time in WASM Cloud, but we take it and we distribute it out. These things are at the code level and also make it way easier when you're running your code, because when you put your code together and actually run it, you can choose what you need at runtime for your local machine. And then we take that and make it very distributed. So this is, like I said, this is just an aside, but I wanted to note that this is where the WebAssembly community is heading, and we're really excited for it. But it shows this power of being able to abstract away your dependencies into something that can be represented by some sort of contract or interface.
And then all of that, of course, is just a WebAssembly module. It's not Wasm Cloud specific at all. You can take it around. So I want to show one other, this QR code is for Bailey's talk where she showed this. Feel free to grab that. I want to show one more application domain that works really well for this type, or for WebAssembly right now, which is a stateful microservices type of application. So the previous, the serverless, is kind of just like a nice little function invocation. This one is actually managing a I'm actually showing a different application than this. Wow. So I'm actually going to show the Wasm Cloud Pet Clinic, which is a little more involved. It has a couple of different services, which if you've heard of the Spring Boot Pet Clinic, that's actually the same example that we're showing here, the same architecture, where it's a Pet Clinic HTTP API, and then a couple of different microservices for managing customers, vets, and visits, so people going to the pet clinic. And so I can actually show you this application. It's the same kind of thing where it's a very simple business domain. But if we hit this, I can actually open up. Well, I'll just leave it for now because we're running short on time. What we're actually doing is we're managing a couple different people in a vet system. So we have all the Cosmonic employees and their pets. You know, I have my two dogs, Archie and Douglas, in here. A couple of different vets that are in the system and pet types that it can manage. So this is like a real application that people use to show off the Java Spring Boot example with microservices. And so what we have is this application. I have it running in the cloud, but then when you think about where this would ideally run, it may not be in the cloud. Ideally, you want to run this application as close to the data and the user as possible, which would be actually in the vet clinic itself. But that brings in a whole swath of complications. What kind of machine am I going to be running on? Can it run Kubernetes or containers or any of that stuff? The actual Spring Boot application takes like 1.5 gigs of memory to run just in the jar form, so it's even more running in Docker. So what we actually have, I have this application running completely in the cloud minus the database, which is running on a Raspberry Pi at my house in DC. And I'm kind of, SSH'd in here so I can do some things. But when we think about runtime optimization, if I take this endpoint and I see how long it takes to hit it from my Raspberry Pi, and we can go like grab the list of vets or something, then it takes almost half a second to go query, go to this public HTTP URL, go down to the Raspberry Pi to hit the database, come back all the way round trip. It doesn't really make sense to do that. And so when we talk about runtime optimization, pushing this compute out to the edge or into the actual place where we're running the application, which is in the pet shop itself, it's really easy to do this with WebAssembly. We can do it in just a couple of steps. So I can take our HTTP API and I can run an instance of it on the Raspberry Pi. And then I can take our vets microservice, the thing that actually interacts with the database, and I can run an instance of that on the Raspberry Pi. There. And then instead of going out to the public internet and hitting the publicly accessible URL, what happens if the network ends up going down in the vet shop for a second, they lose access to everything? We can actually live link this to the local HTTP server that's running on that Raspberry Pi, and then say, we'll hit this at localhost 8083 or something. Now, instead of going out to the network, hitting this publicly accessible URL and all those things, we can actually just go on the Raspberry Pi itself, and we can hit this URL. So instead of going all the way out, hitting the database, it takes a long time. We can hit it locally on the Raspberry Pi, and it takes about 1/3 of the time in order to make that request. So we're constantly optimizing that to run kind of at the edge. So when we think about people who have done this, people are getting pretty good at running cloud native apps today, right? They're pretty good at running it in the cloud, even high availability things. Pushing it out to the edge is taking it to that next domain of optimization for apps, because the network boundary, the network cost is really high when it comes down to the latency of an application. So Taylor, do you want to talk about what you can do now?
So this is okay, we just showed you all this cool stuff, all of these things you can do now, but what could you do right now with the applications you have. There's a couple different ways. The easiest is, they're listed from easiest to hardest. One of them is to do some sort of basic data, image, something processing, which you can do in WebAssembly and hand back to something running in like Kubernetes. We'll show some more of that. I'll show some more of that this afternoon, actually. You can take one small part of a service that you want to run smaller and cheaper and rewrite it so that it can compile to WebAssembly and then run it like this. Or you could do a full stateful application if you have greenfield type things. And we can talk through more of those, but we're getting close on time, so I just wanted to put up this slide. If you want to check this out and get started, we have our main landing repository that has links to everything else on the right, and we have our Wasm Cloud Slack on the left. All of those are available to join and start the conversation with us. So with that, we're going to go ahead and finish the talk, and if there's a little bit of time for questions, we'll try to do some of those.
We have a minute or two for questions.
Nice.
Yeah.
Looks like one in the back down over there.
All right. Shall we start?
Go back.
Thanks for the talk. Have you considered porting kind of Kubernetes webhooks or controllers or other kind of extension mechanism to this? Would it be possible to kind of, for example, in the API service, instead of going to a webhook, build and compiling it somehow to some kind of Go plugin or similar, or writing a controller kind of actuating in Kubernetes state based on this?
So if I understand the question correctly, I think the answer would be that WebAssembly is extremely flexible for this. So like if you want to compile this to a different model or hook it into a plugin thing, you could do it, and there's multiple points you can connect in. You could be publishing over a messaging bus. You just have to either use the contracts we have or write your own. That's something that we actually didn't mention, is that each of these contracts that Brooks was showing, you're not restricted to using the ones we create. You can bring your own. So it's pretty much flexible to do any type of infrastructure you want. I have to talk more specifically to you to give you a specific examples of what you could do in that case. And were there some questions? Bruce up here?
Yeah, thanks. About the lack of lift and shift for certain tool chains, could you please just dig into that a little bit? And how does that relate to the actual programming languages themselves? Because is that related directly? I mean, I'm thinking, as you mentioned, you gave the example of Python. It's not there yet, really. And are we seeing an evolution, or I guess it's going to turn out where the majority of WebAssembly applications will be written in Rust primarily? And when and how are we going to see the other languages really being able to be adopted? And
Yeah, that's a very good question. It's a very common question. The answer is actually pretty soon. We keep seeing it's at this rate, I've seen about a new one starting to get there every 2 to 3 weeks at this point. There's even some people experimenting with Java, which I thought would not get there for a while, at least with the Graal VM to make it compile to WebAssembly. And so the lack of lift and shift is from the fact that there are some missing things there. I think we'll get closer to a lift and shift as WebAssembly evolves, but part of it is language support, and that's rapidly evolving. Python is almost there. You have JavaScript that's almost there. JavaScript, dynamic languages here. PHP is also there. You have Rust and C and C++. You have Go just landed support. So that doesn't mean everything's there. It just means that progress is being made when you get something merged into a main tool chain. So that is where that lift and shift becomes better. I don't think people are going to be required to write in Rust to be able, in the long term, to be able to write things that compile to WebAssembly. I think it's quickly changing.
They won't be able to because it's so hard.
I think a lot of the trouble with lift and shift is when you take an old Java app and you put it in a container, you're still able to work with the same assumptions that you had before. You still have the kernel available to you in an operating system. When you compile to WebAssembly, a lot of that changes. You have to think about everything that you're interacting with in the outside world. You can't just willy-nilly go load a config file from disk. You have to give permission to go access that. So a lot of times applications just don't work the same out of the box.
That's kind of where we should be, though, right? I mean, the developers working in their application language, their choice, without having to worry about that, obviously, right?
Yeah.
But what, actually, real fast, though, the way I understand it, though, Rust, I think C++ as well, they lend themselves better two WASM modules because they're working at a more of a direct CPU level as far as the runtime goes, or
Yeah,
not?
there's no runtime, no garbage collector, none of those types
It
of things.
uses like an LLVM, the intermediate, so it just compiled to the WASM backend.
Right.
Runs itself really
I mean,
well.
but why does Rust works more on a CPU level?
It's a systems level language, so yeah, it's a little bit closer to that target, but it's definitely, that's why other languages have added support and they've made it very efficient in a lot of cases. So we're going to see that. We're going to see more explosion of languages being added to that because a lot of them already did the work to do it for browser support WebAssembly. So we'll see them doing it, I think, as well for server side. Okay. I think we're at time, right? Yes. Okay.
Sorry, I'm afraid.
No, we're
that's
good.
all
Thank
we
you
have
so
time
much.
for.
And yeah, we'll be hanging around. We'll probably just post up in the back or maybe in the other room to not disturb the next talk. So please feel free to come up and ask us questions. We can talk a little more.
All right, this is it for the first half of the program at the warehouse here. We're back at 2. We break for lunch now, and we're back at 2 for a panel talk, a very special panel talk on the end of programming that's going to be mediated by Alex Williams, the founder of NewStack. So we'll see you then, and yeah, hopefully you can carry on with your conversations of to WASM or not to WASM after.
Welcome back, everybody. Thanks for joining us after lunch. I hope you had a good lunch break. And now to start the talks again, we have this very interesting panel about the end of programming. Is programming ending? Well, we'll see what the panel says. We have a slight change in the panelists, so I'll let them introduce themselves. But welcome.
Well, thank you. Hey, everyone. I'm Alex Williams, founder and publisher of The New Stack. And why are we here to discuss this topic? It came up when Matt Welsh of Fixie.ai, he's a former Harvard professor, and he wrote an article for ACM on the end of programming. And it really sparked my curiosity as someone who's using ChatGPT. Do I even need to ask who's using ChatGPT? Okay, let me ask a question. How many people use it every day? How about twice a week, 3 times a week, once a week? So not that much, right? So, I'm very curious on how people, view the use of ChatGPT and use of generative AI and other forms of AI in programming. And so the discussion is about the end of programming, but we know it's not going to end, right? We know it's always going to be here, but the question is, what will be the impact that it will have, and what questions do you have? And so that's really what I want to get to in this discussion. And so joining us is Bob Van Loot, who's with Weaviate, and I'm going to ask Bob kind of what he does. And I asked Amanda Brock to join us. Amanda is the founder, and would you say the founder, the chair, the CEO of OpenUK. And so maybe we just start. You can tell us a little bit about Weaviate and a little bit about OpenUK, because I want to ask Amanda, because I think there's such a story about open source and AI that we want to discuss. So maybe, Bob, you could tell us a little bit about what you do.
Yeah, sure. So first of all, thanks for having me. So I'm Bob Van Luit. I'm one of the co-founders of Weaviate. Weaviate is a vector database. It's also open source. And vector database is a new type of database. And it stores the vector representation coming from machine learning models. So if you want to store information, or sometimes they nowadays call it I guess the marketing term is the long-term memory for AI, is that you basically store these representations in a vector database. And I think one of the things that we've seen is that these databases are used kind of as the backbone in these AI applications. So last year, I think it was in November or December, OpenAI added to their website, hey, if you want to do something or you want to build ChatGPT plugins, then you can use Weaviate. So that was a first bump that we saw in usage. And now you have AutoGPT, those kind of things, and they've all integrated Weaviate as their core database. And especially because Weaviate is open source, a lot of people appreciate that. So that's growing very fast. We're now 30 people distributed all over the US and the EU. So we're growing. So we're hiring. So if you're looking for a job, if I may intersect that.
Sure.
So that's what we do. And I think in a bit we can also talk about this, because with this growth of usage of these AI models, you also need infrastructure to support that. And that's what we do. We're an infrastructure company that supports storing these representations from these models.
Amanda?
Yeah, hi everybody. I'm Amanda Brock. I'm CEO of OpenUK. I've worked in and around open source software for the last 15 years. I joined a company many of you will know, Canonical, in 2008. And I joined to work on the legal side. I was the general counsel, and I set up and ran that legal team for 5 years. And then 3 and a bit years ago, You can't hear me? Okay. You want to turn me on?
Okay.
Which one? You want the handheld? Yeah, totally. Let me get rid of this, though.
Should she use the headless or the...
Yeah, so there we go. You've got a mic now. So hi, I'm Amanda Brock. I'm the CEO of OpenUK. We are the UK's organisation for the business of open tech. So we work with open source software, hardware, data. We bring the 3 communities together. We're geographically focused, but we work with everybody who is either working in that space or wants to work in that space in the UK. So everybody's welcome. We're not a pay-to-play organisation. We're about bringing the community together. We focus on individuals, not companies. Although our funding and sponsorship comes from companies, we focus on anybody who is geographically based in the UK who wants to engage. And it doesn't matter whether you work for a UK or an international company, on your own account, whatever it is, we want you to be part of our community. I personally have worked for Open UK for just over 3 years, nearly 3.5 years. We've grown massively, and we have about 150 people who are pro bono or giving their time to make the organisation work. 2 of us are employed. We've intentionally kept the employed staff very low. We work with contractors, and then we have lots of people in pro bono roles, like our CTO, people who run our board, our leadership team. We have lots of ambassadors. I think there's about 10 of them speaking at KubeCon this week. So you'll see people across there. And it is a model that allows us to bring a community together to have a voice. And we try to represent the voice of open in the UK. And we do that in responding to legislation. We've got a new AI bill in the UK. We do it in creating policy and sharing information with government. And then the third thing we do is skills development and learning. So right now we're building an AI advisory board, and we're looking for people in the UK, ideally with skills in that space, to help us to influence government around AI. And I've mentioned we've got an AI bill in the UK. We are also working on a report later this year which will look at open source and AI. So I've avoided it. I've avoided it because I think it's really hard and I don't know the answers. And now we're reaching out to community to try and work together to find the answers.
Great. And one of the things I like to do with the panel discussions is making it less about the panel and more about the people who are here to learn. And so I would like to just start with getting some perspective from Bob and maybe from Amanda. But then I would love it if you would have a question or something or a thought that you have that you might share. So I'll be calling on you for most of the discussion. If you don't have anything to ask, that's fine too. We'll just keep moving on. But I'm curious, Bob, on when you think about workloads in a traditional sense, right? They always accompany a workflow, correct?
Yeah.
And it's one of the kind of the blockers I've had with AI is like, what is the workflow and what are the workloads and what is the workflow? And as a developer, how has that changed how you work?
Well, I mean, so in the end, and sort of like a lot of different models that we use, right? But the thing that is now the hype is the generative model. And the generative model doesn't do much else than make a prediction of like a bunch of tokens after other tokens, right? And the reason that I bring that up is because if we specifically look at that in the concept of code, it's the exact same thing, right? It makes a prediction of like, if I have a certain a structure or I have a request, I have a prompt, I have a certain structure that I store the words, in this case code, after one another. In my mind, when it comes to pros, that's not very different than, when the whole RESTful API thing came up, we got like the Swagger, now open API definitions, and then basically you could, push a button and then your API rolled out in whatever language you preferred. It's just that, but just way more sophisticated. And we still need to make sure that the thing that it actually predicts that's helpful. So one of the things that we see the most that what people are working on is coming up with applications and tools where they leverage that prediction, but it's more the function of a tool, right? So where it helps the developer, where there's still this human creative interaction on how to structure things. So long story short, to answer your question, it is just a way to automate the workflow, right? It's like it's making it more efficient and faster to do your job, regardless if that's as a journalist or as somebody who writes code or what have you.
And so, if you look at the evolution of open source, it's always been built on code, and which is really interesting because code is a way for us to talk to machines, really, essentially, right? So what are some of the kind of the first inklings that you're hearing out there about AI and open source, and how does that affect people in this room who basically, have learned through open source communities how they work, how to use technologies. Where do we see that evolving?
So I'm going to read something to you, and it's from a LinkedIn post by someone called Peter Nixie. And Peter's in the UK. I don't know him. It was shared with me 3 weeks ago by a friend. And it says, I'm in the top 2% of users on Stack Overflow. My content there has been viewed by over 1.7 million people, and it's unlikely I'll ever write anything there again, which may be a bigger problem. Stack Overflow is the repository for programming Q&A. It has 100 million users and saves man years of time and wig factories worth of grey hair every single day. It's driven by people like me. But since GPT-4, it looks less and less likely any of that will happen. And this is the whole conversation, the sharing of information, the answering of questions. What happens when we stop pooling our knowledge? When it comes to time to train GPT, it risks drinking from a dry riverbed. And I've basically read you the first line of every paragraph he wrote, and there's much more detail around it. And I think there's a couple of things that immediately come to mind. When I can't code, right? So when I talk to people who can, their immediate response is always that it's great, it gives me great information, but then I check it and I find the errors and I work out what to analyze. So we have human discernment and experience and knowledge that we use to work that through. So in a way, I think it's sort of commoditization, which as a lawyer, we used to do that with contracts, right? Who wants to do 100 sales contracts that are the same? You commoditize, you learn, you pass that over to an automation. But you still, when it comes to anything clever, want that human intellect there and that discernment. So unless we're going to get to singularity, I think we will always have this need for the human and the skilled human. And my concern is how do we get to that skilled human in the future? You're sitting here as a room full of skilled humans. How do we bring the next generation through? How does the 5-year-old sitting in school right now become the 20-year-old or the 40-year-old passing on wisdom if it's all going to get into the machine and if that knowledge isn't going to be shared in an open and collaborative way that we're all used to? So I think we have some major issues, but I'm not quite sure how we get to the next stage or whether it's quite as immediate as we all are making out right now.
I don't see the issue. Right? So it's like the model. It does a prediction based on the information that it's giving. The way that we use that information that we share, we'll keep doing that. I mean, we're part of this backbone of these technologies, and I run an open source company, so I know that the information we share, those kind of things, that doesn't change. It's just feeding our creativity as humans to build things faster and more efficient.
So the leap, and I'm not against AI, so don't take it that way, but the leap from here, where we are today, to the future, if we are going to streamline this process through AI, how are we going to create the collective knowledge pool? How are we going to have the Q&A? How are we going to have the conversations that we have today if the answer is spat out from that and we don't keep doing that learning iterative process? How does that work?
I guess it's a question about the black box.
Sure, but I mean, so we can ask a question to the black box and it gives us a subjective or an objective answer. If that answer can be interpreted as something, that comes with some form of interpretation, we can discuss it as humans, right? So it's like I think the point that I'm trying to make here is that I think that I appreciate the concern, but I'm not sure if there's a lot to be concerned about because it's just a faster way. So let's take Stack Overflow. Maybe Stack Overflow just transforms, right? So that, I mean, I'm using Stack Overflow a lot. So it's like maybe that there will be suggested answers. And then in the comment section, we discuss the answer that the model came up with.
Right, so you're looking at it, I think, more like a sophisticated search tool as opposed to the provider of an answer.
Yes.
So not a substitute for the human.
Yeah. And
so just a tool.
Exactly. And I think we should not forget the thing that it does is that it makes a prediction about one word coming after another word. That's the only thing it does. That's also why it hallucinates, right? So that thing that will not go away because we could have a discussion about a certain topic, right? So, and I could speak complete nonsense, like the model does, and I don't see how that's different than having like human-to-human interaction or human-to-machine interaction.
Question: is anyone using AI in their workflow right now? Maybe you could tell us how and like what you've learned from it.
But you need a mic.
We need a mic. Here.
It's not a coding workflow, so it's more like what I'm looking at the moment is like how can I get all the information that we have within the company, that we have like in Google Drive, in mails, in Slack, customer conversations, everything. Like how can I get this into a GPT or on top of some other model, and then how can I get answers, and whether that is on the management level or if that is on a customer problem level. And I think I have a slightly different view from this, like it just improving our own performance, because like I can also see that the abstraction is so much higher. Like if you look at the plugins, if you see that the language model is actually able to understand an API and not to produce the YAML that we need to feed into the API, talking directly to the API. So like what if there's an alert from Prometheus coming into GPT selects the right cluster, like you have 200 EKS clusters, GPT connects to that cluster, figures out what's going on, applies a few of runbooks that are in the intranet somewhere, and if there's still a problem, then actually involves a human. So that's a completely different abstraction from just like having a tool, a command line tool that produces some YAML on my machine to make my life easier, right?
So it's the end of DevOps, not the end of programming.
Everything. Like you also like you don't need to automate stuff anymore if the AI can just connect APIs for you. Like you don't need to write the software that does.
But that is what we see. I like that example. That use case we see. So if your use case, if you want to store that information, that's what people use a vector database for. And we see a lot of those kind of use cases. And in my mind, it's super exciting. It's like...
I'm excited about it too. But still, we are talking about not only getting faster, but also replacing... you don't need that many people for this, right? Mm-hmm. So you need... there will be skilled humans that are going to do that. Like a friend of mine does a joke. We are the ones that are working longest. Mm-hmm. Because we are evolving into AI and building some tools, and other people can stop working earlier because there's nothing to do, right?
Okay, but now we're getting somewhere. So do I understand correctly that the concern is that people lose jobs over this? Is that the concern?
I think there's two concerns. I think there's a question rather than a concern about whether there will be a need for humans. And then I think there is a question, possibly a concern, about where the AI is going to get the knowledge it needs to hallucinate in the future, right? I like the term you use, hallucinate, because to hallucinate, you ingest something. And what we're thinking about also is what is the AI ingesting? What is it learning? Where is it getting it from? So what kind of trip is it going to go on in the future if it hasn't got anything decent to take?
So what you say is getting somewhere. Where do you think he's getting with that? Then you're talking about the data and the storage, and we're also then talking about kind of the optimization almost of workflows and processes. Does this optimization of workflows and processes lead to the end of programming?
I hope so. It's a lot of work. So it's like everything we can do to automate that away. It's like that would be extremely helpful. Wouldn't it be great that you can just have a description of what you try to solve? And I'm starting to see those use cases. I mean, it's still very experimental, but especially in the front end world, right? I'm trying to do X, Y, Z, and then it outputs like a React front end that kind of solves that for you. And still it's buggy and it doesn't always work, but we see where this is going. So I would say, yes, that's where it potentially would go to. This is also where this thing comes from, and it's a little bit overhyped now, but where people say it's moving from programming to prompt engineering. Mm-hmm. Because the better you can write your prompts, the better you can get your output out, right? So, but that is... So that I mean, I hope the answer to that question is yes, because that might be extremely helpful. You could even get into situations where the system starts to optimize itself, based on certain things. So,
but that's going to be not a might. That's going to have to be a necessity if we're not building humans who learn from experience year after year, trial and error, doing different things. If we become dependent on the AI for its outputs and its guidance, it's going to have to be able to do that. It's going to have to be able to have that thought process if we don't have the skilled humans, and we won't if they can't learn.
Yeah, I mean, it's like if we could snap our fingers or wave our magic wand and we would take very traditional databases, right? We would just remove them now, waving our wand, and Cassandra would be gone, right? That's like a database that's, how old is that, 15, 20 years? Nobody can do a financial transaction anymore. So it's like it's a necessity. It is already a necessity, and the machine learning models are just another iteration on making that more efficient. But that's why I'm trying to understand really the core of the concern, because if the core of the concern is we're getting too dependent on the technology, then it's already too late, because we kind of already are. So it's and then adding AI to the mix or not, I don't think that changes then a lot.
Who has a question? Or any other? Yeah, there we go. Or actually, let's go over here, if you don't mind, and then I'll go to you, Bruce, okay?
Thanks. So one of the fundamental things I love about open source is being able to, fork a project, spin something up myself, have a play with it, take it for a spin. With the large language models, yes, some of the fundamentals are open source, but it's essentially impossible for me or anyone else individually to train at that level and get something of a similar quality out the other end. So are these systems now the most proprietary and closed systems that we've ever had?
It's a constant question, right? And everywhere I go, people are asking me, and I said at the start, these are hard questions and I don't know if I know the answers. Last week, the European Commission, and I think this was leaked, are suggesting that AI is going to be regulated and required to show the copyright and everything it's learned from. Now, we've all been concerned about how open source licensing is going to work, how attribution is going to work, how we know where the AI's got the information it's got. And if you imagine this, in a way, it's really good for open source, because you'd have that attribution, you'd have that knowledge of all of the code that it had run through. On the other hand, you're going to have a situation where that's a huge job, right? And unless you're inheriting an SBOM effectively with all of that data in it, how are you going to build it? And maybe there's a tool that can do it for you, maybe there's not. But potentially that's going to be a restriction for people like yourself as well, versus these big companies. So I think we've got the actual technology, we're going to have the regulation around it. How are we going to manage all of this on an open and collaborative basis and make sure that the AI is creating the best code it can?
I'm pretty sure that this will be resolved. Right? To give you a very pragmatic example, so Google Search is a very big vector database. It took them a lot of money and a lot of time to build it, right? So like, billions of US dollars to just build what Google Search is today. We're a 30-person company. We've been relying on the research that was coming out of this. So very specifically in our case is the ANN index and those kind of things. And now with a 30-person company, significant less amount of funding than Google Search has, we're now building this and democratizing it basically through open source. So what I'm seeing, what's happening in the research and the software that's being created with these models, this will happen. You will be able to train this for a decent amount of money in the near future, because there's so much innovation happening in the indices, going from GPU to CPU, those kind of things. The common crawl basically is probably a lot of software there is being created to optimize that's coming out of that. So the point is, if you want to train it now, you're just a little bit early, but it will become significantly more easy. And what we will see, I dare to place a bet for this year, we will see an LLM running on our machines this year, because I've seen so much CPU innovation on that. So I'll bet you a nice ball of wine, and we're going to see that this year. So and that will be pushed to the open source channels, right? So I noticed that myself. So I think there's this. This is not a time for to potentially be worried about that, but actually be happy about it, because contribute, make stuff. It's happening right now.
So what's the best open source that you would recommend people in this space? So what's the best equivalent to ChatGPT?
Sorry, what's the
best open source equivalent to ChatGPT?
Yeah, so I mean, I think almost all the models that you see on. So if you look at ChatGPT, we have to look at the model. So the GPT model that's behind it. If you see the models that are now being open sourced on Hugging Face. Right. There's like this, and I forgot the name, that was one that was recently released. Well, what's happening, of course, with Facebook, I love the fact that Facebook made that model open, and it was like on the torrent network. It's like, hey, back to torrents. That we will see that one at some point on Hugging Face. Hugging Face plays a very important role as like the GitHub of these open models. That's happening, but I think there's a difference between having the model available and being able to train it yourself. Look at the fact that Bloomberg trained their own GPT model. Now you might argue, well, I'm not Bloomberg. Fair enough, but Bloomberg is also not Google or OpenAI/Microsoft, right? So it is already happening that it becomes easier for people to adopt these models or train them. And then you can decide if you want to make... So there's a difference between... For example, you could say, I'm going to make the software open source that I use to train a model, but the model that I create, I keep that as proprietary model. I don't think that's a problem, because that's a way to just generate money and give the software to people to do that themselves, and that is already happening. So it's not that it's a closed ecosystem.
Bruce, I want to get to your question quickly.
Where do you see the actual evolution of the CLI, or the actual interface? I mean, how's this going to change the life of the developer on a very pragmatic way? I mean,
through the CLI.
And I'm also, I mean, what would you? It's probably too early to say, but like 2 years from now, 3 years from now, do we need programmers? I'm kind of thinking of, I've always used John Carmack's.
Sorry, what?
John Carmack.
Yeah.
Of his genius as a programmer, right, an engineer. So, are we going to still need this genius? And I mean, or not? I mean.
Well, I hope so, because he makes at least for great podcasts. So it's good podcast.
But I guess, going to Amanda's concern though, and it's like you have to take a step back the whole time.
We got to get going. So
you'll need somebody to actually verify that.
May I answer the question?
Quickly,
I'll be quick. So, two questions in there, right? A big one, a small one. So the small one's like, what will we see first? If I had to make a prediction, for example, if you use GitHub, you have the depend-up bot, right? So the bot says like, hey, you have like a vulnerability or something, right?
Right.
I would imagine that one of the first things we're going to see is that the depend-up bot not only says like you have a vulnerability, but it says, if you accept this pull request, I've also made the changes in your code to make sure that. So that's one part of. And the second part of your question with John Carmack, those kind of people. Of course, we need those people, but these roles that they will fulfill in society will just change, right?
Will blossom into other ways.
Exactly.
Like I think, for instance, my big question about open source is how will we treat biases? Like how what's the question of biases in open source in open source AI?
I think the first step has to be understanding what's being used, right? So that disclosure, that SBOM-like requirement is going to be the first step to understand what it's learning from.
Yeah. Great. Well, thank you both for the time. Let's give a big hand. And I just want to say thank you to the team who put together this great community conference. Let's give them a big hand. Native Rejekts is the community event now, I think, for this space. So great job to all of you who put it together. Thank you very much, and have a great week.
Thank you.
Yeah. Thank you. That was good.
Testing, 1, 2, 3. All right. So we have a larger crowd now. Everyone is excited for this talk. Leon is going to tell us a little bit about system thinking and what does this mean?
Yes, good question. All right, thank you so much. Thanks for coming. Everyone have a seat or anything? No, you can stand over there, it's fine. So, thanks all for coming. Today I want to talk about systems. And systems, they're all around us. Like, you are a system, I am a system, our bodies are systems, each cell in our body is its own system. And dev organizations are systems, and they're made up of teams, which are systems, and they're made up of developers, which are systems. So once we start understanding that about the world, and also starting to understand how systems work, why they behave in a particular way, why they don't behave the way that we want them to, that will help us really understand what's going on and change systems the way that we want them to. So by the end of this talk, you will hopefully leave with a new language, a new toolkit, and just a new way of thinking about these big problems that can span multiple teams or organizations or even generations. So a little bit about myself first. My name is Leon. I am a developer advocate with Loft Labs and the Chief Karaoke Officer of the world. You can find me on the Bird app, on the Elephant app. You can send me an email. You can go to LinkedIn, try your luck there. And in my former life, I should mention that I work for a company named Loft. I know, I always forget about it. We provide building blocks for platform engineers. And if you want to know more about that, you should talk to me after this talk. So, as I said before, in my former life, I used to be a consultant and an engineering manager, and I think I just really always was interested how to create the environment for people to be able to do their best work. And that's how I ended up being super interested in systems. So I'm going to start with an ancient thought experiment named Ship of Theseus. Theseus was a mythical Greek founder king of Athens. He saved the children of Athens from the Minotaur. So he slayed the Minotaur, saved them from King Minos. And to commemorate that, the Athenians would take his ship out on a pilgrimage each year. And the ancient philosophers of the time were posing this question: if we do this for centuries, and ever so often we need to replace individual parts of the ship one by one, after hundreds of years, is it still the same ship? So in systems thinking, what we need to call something a system is elements. And these elements need to be interconnected in some way, and then all of this needs to have some kind of function or purpose. So in systems thinking, we would say, as long as the interconnections and the purpose or the function remain intact, it's still the same system. So yes, if you just replace the wooden planks of a ship, it's still the same ship. If you change the interconnections, so instead of a ship, you just have a pile of wooden planks, that's not the same system. You can use the planks to maybe, sit on the water, but it's still not a ship. If you change the function of it, so you have a ship, now you flip it around and make it a church, which is something that the Americans do, that is still not the same system. It's not a ship anymore. It's not Theseus' ship anymore. So in systems thinking, we say elements can be changed. It's still the same system. If you change interconnections, it's not the same system. If you change the function, that is definitely not the same system. And systems can have subsystems, which is very important, because whether an element is part of a system or not part of a system depends entirely on the problem that you're trying to solve, like the perspective you take while looking at the system. So there's no right or wrong, really. It just depends on your perspective of it. So let's talk a little bit about the elements. So there's a type of element which is called a stock. A stock is anything that you can see, feel, count, or measure. It represents the store or the quantity or the accumulation of material or information over time. So the stocks don't need to be physical. A stock can be like information, or can be someone's patience, for example. Then we have flows. Flows have an interconnection to these stocks, And if the sum of all inflows is bigger than the sum of all outflows to a stock, then the stock grows. Vice versa, it shrinks. If they're the same, then you will reach some kind of equilibrium at some point. The stock in between in and outflow is quite important, because if you have a stock like this, it means the in and outflow can be completely independent from each other. They don't have to know about each other. And when one thing changes, the other one is not necessarily affected by it, which has a lot of advantages. So, as I said, the independence, but also having a stock buffer like this gives us a bit of time to maneuver if we want to change something. But it can also have downsides. Because of this delay or this buffer in between, sometimes we don't immediately see the consequences of our actions. And then finally, as I said, systems need to have a function. So I use the word purpose sometimes, I use the word function. The difference is that a purpose is something that's human. Humans look for purpose in systems, or try to imbue a system with purpose, whereas a function is just a property of a system. So function doesn't need to be super explicit, and sometimes it's also not the purpose that we want our system to have, and that happens quite a lot actually. The first function of any system most of the time is to ensure its own survival and its own perpetuation. And then finally, there's something that is not necessary for something to be a system, but it just tends to emerge from systems, which is behavior. Behavior is something that persists over time, regardless of any changes in in or outflows, because there's a mechanism that creates this behavior. And we call these mechanisms feedback loops. So typically in systems, you will have a bunch of loops, and some will dominate others. And if a system behaviors change, that's most often because the dominance of loops changes. Not all systems have feedback loops, and the existence of a feedback loop does not necessarily mean that the system works really well, because it could be completely unintended. So let's look at one simple example of a system. In this example, we have one stock, which is the room temperature. And because it's cold out, because we're in Amsterdam, over time, you will have hot air leaving the room or cold air entering the room. And we also have a radiator to heat the room temperature. So these are in and outflows for the stock room temperature. Now, the function of our system is to keep the room at a toasty 20 degrees Celsius. That is 68 Fahrenheit for friends across the pond. And we will check the thermometer. And if we see there's a discrepancy between our desired stock state, which is 20, and the current one, we will jump into action and maybe turn on the radiator or close a window. So this is a feedback loop. And any kind of feedback loop is triggered by a change in a stock and affects the in or outflows of that same stock. And it doesn't need to be, it can be a human, it can be automated. Again, it doesn't matter what the element is. It's completely interchangeable. So this particular feedback loop is stabilizing the stock. So therefore, we call it a balancing feedback loop. So balancing feedback loops are stabilizing, goal-seeking. Eventually, they will get you to some kind of equilibrium. So this is how the stock could look like over time. It could be that it oscillates around this goal and never really completely hits it. This is what we call a dynamic equilibrium. So another example of a feedback loop where we start with the rabbit population, let's say in your backyard. So the population grows when more rabbits are born, and it shrinks when the rabbits leave, however they will leave. And the function of this system is pretty straightforward. It's to survive and thrive, to procreate, to adapt, to ensure its own survival. So if we don't control anything, we just let our rabbits, do their thing, and it will lead to more fertile rabbits that will birth more rabbits, procreate more, which grows our population even further. So this type of loop is called a runaway loop or a reinforcing feedback loop. It amplifies, it self-multiplies, it can grow as a fraction of itself, and sometimes also snowballs. Because this growth is not linear, it's exponential, like this. And if we leave it unchecked, it will eventually collapse the system, because exponential growth like this is just not sustainable forever. All right, so personally, I think systems thinking is super great. Most of us are able to grasp kind of a system, you know, the cause and effect relationships, even if we don't have the language to really express it. And the reason why we're so good at understanding systems, at least superficially, is because of system storylines or system archetypes, or sometimes they're called system traps. So archetypes are system structures that produce common patterns of problematic behavior. And in this next section, we will look at 3 different archetypes and learn how we can draw out a systems map to make inferences from that, and also learn how we can get out of these traps. So our first archetype is called fixes that fail or fixes that backfire. So I'm going to tell a story first. In 1967, the Romanian communist government decided that their birth rate was declining and they needed to do something against that. So they issued Decree 770, which outlawed abortion and contraceptives. And as a result of that, the number of births almost doubled within a year, but by 1970, it plummeted again. Because what happened was that the government did not really account for what to do when these babies actually grow up to be children. So there was not enough food, shelter, education for these children, and the families just couldn't cope with this economic pressure. So what happened was, as you can imagine, people started to try to circumvent this decree. So wealthy women would be able to illegally obtain contraceptives and abortions, and poorer women would put themselves at incredible risk to undergo very dangerous procedures to get rid of unwanted pregnancies. So as a result of that, the mortality among pregnant women and children became the highest in Europe. And yeah, the question is, what exactly happened systemically that caused this archetype to happen? So here we're starting with a problem. We have a problem, and usually when we encounter this archetype, we don't actually understand the problem well enough, or we're fixating a lot on a problem symptom. And then we're implementing a quick fix. And this will take care of the symptom, but not the actual problem. And we're expressing this in a systems map by by this plus there that I'm going to point to at some point, maybe. You can see it, right? We're getting to a dynamic equilibrium around this. Okay, so there's an arrow and there's a plus, which means that if this stock grows, then this stock grows as well as a consequence of that. And what we're now doing, we have this like short-term solution, and now that will reduce the problem symptom. So that's why we have a minus there. So that stock grows, and as a result, that stock sinks. And this entire loop is a balancing feedback loop. So the general rule of thumb is, if a loop contains an uneven number of minuses, then this is a balancing feedback loop. Sometimes when you see this, it might say S or O, which stand for, I think, support and opposite, but it's the same meaning. It's just instead of plus and minus. So the problem now is, we didn't actually solve the problem. Instead, we just did a short-term fix, and now we're introducing unintended consequences. And the unintended consequences come with a delay, and that is the 2 lines striking through the arrow. So the more of the short-term solutions we build, the more unintended consequences we introduce, but somewhat delayed. And as I said before, the delays can be really useful because they can act as stock buffers, giving us time to maneuver. But in this case, they're very problematic because they somewhat separate the action from its consequences. So we might not even realize that these consequences happen because of our solution over there. So what happens here is, the more we work on that short-term solution, the more we're actually making the problem worse. And if you're looking at this entire loop here, we have 0 minuses, and the rule is, if you have an even number or 0, which is also an even number, then you have a reinforcing feedback loop. And we can totally ignore the arrow here in the middle, because we're looking at what actually happens between these 3 things in the bigger picture. And what we have here is a reinforcing loop. So there's a specific case of this archetype. It's called policy resistance. And policy resistance has to do when the underlying problem is caused by various actors in the system pulling the system stock to their own goals, which are detrimental to each other. So this balancing loop here on the left could be its own subsystem that as a function or as a side effect causes our problem symptom. So we can't fix this unless we take care of the loop over here on the left. In your development organization, maybe you might have encountered something like this, where leadership just decides to completely pivot. We're just using Kubernetes now. We're doing platform engineering now. I'm sure you are familiar with that. They think this will make the devs faster, but because these actions don't actually address the underlying problem, like lack of slack time for education, R&D, or simply involving engineers into their decision-making process about their own work environment, empowering and trusting them to do their best work, these policies will just garner more resentment and people will resist them. Ooh, I'm kind of slow. All right. So how can we get out of the system trap? Basically, it's about stopping this cause-effect relationship. Break out of that. Let go of the fix. Bring in all the actors to seek out a compromise that we can all kind of we can realize everyone's goals, or redefine a shared goal and find out what every actor needs to pull toward that goal. So in the 1930s, for example, Sweden also saw their birth rate declining. The Swedish government decided there is something we can all agree on, all the stakeholders can agree on, which is that every child should be cared for. They should not be in material need. They should feel wanted, should have access to education and healthcare. So as a resulting policy, what the Swedish government did was actually seems quite counterproductive, which was to provide contraceptives and abortion, widespread sex education, making divorces easier, increasing the investment in obstetrical care, education, healthcare, all of that. And since then, the birth rate has raised and declined, is currently on a downward trajectory again. But the point is that the Swedish government and people just decided that they are not focusing on the number of Swedes in the world, but instead to make every child born in Sweden or every Swedish child happy and wanted. So a similar archetype to that is shifting the burden, where okay, sorry, I'm just this cursor is making me. Okay, so in shifting the burden, or addiction is also sometimes called, it's something like, instead of getting a good night's sleep, you just drink coffee. And then at some point you're like, I'm not even awake before I had my first cup of coffee. That's not healthy, by the way. That's actually not good. So here we start with a problem symptom, and we know we could implement a long-term solution, but it just takes time. It's maybe a bit difficult. So instead, we opt for a short-term solution that gives us instant gratification. But the more we implement the short-term solution, the more side effects we introduce. And those side effects make it harder or less desirable to come to long-term solutions. So the system will rely more and more on the short-term solution to keep the system running and not let the problem escalate. And here we have two separate balancing loops. They're all problem-fixing loops. One is a bit more popular than the other. But when we keep in mind that actually the system includes the side effect loop, and we look at this entire loop, we see this as actually, again, a reinforcing loop. And we call this archetype shifting the burden because we're not addressing the actual problem again to keep the system alive, but instead we're relying on the short-term solution, and even worse, the system becomes addicted to the short-term solution as the mounting side effects just make the long-term solution less and less viable. And in my time as a consultant, where I've encountered it is when organizations become so dependent on external consultants, not only to innovate, but even just to maintain and operate their own applications. So how can we get out of this? Again, it's about breaking this cause-effect relationship here. Reduce dependence on the quick fix, increase the investment in the fundamental solution. Create a vision of an alternate future, that compels the actors of the system to invest in this future. And where it's necessary to continue using the quick fix, just build towards the long-term solution, right? Try to find a quick fix that doesn't undermine the long-term solution, but just builds towards it. So in one of my engagements as a consultant, we were contracted to build a CI/CD platform, but some of the engineers were just not comfortable doing CI/CD. They were just not used to deploying so often the little changes. Some of them they never deployed themselves ever. So what we did was we built like a hack that allowed them to bundle up specific versions of their microservices that they have tested against each other. Okay, when I say microservices, they did not build microservices, they built a distributed monolith, but that's a different talk. So basically, we allowed them to fix their versions and then deploy that bundle to production. But we built this in a way that to the CI/CD platform, it just looked like a variation of the pipeline. So it wasn't like a real hack. And by the end, they could, once they had the confidence to actually use the platform, then we could just flip the switch and go to real CI/CD. I said I needed 27 minutes. I might need more. Okay, so this is the final archetype. It's the most complicated to draw, but it's very straightforward to understand, I think. It's called tragedy of the commons, and the most common example for that is overfishing. Overfishing has existed for a long time, before the Industrial Revolution, but since then, in the modern era, it's become really bad because of the advances in technology, but also because of globalization. And led to depleting of fish stocks, collapse of fisheries, and in the worst cases even entire communities that are dependent on fishing. People are losing jobs, there's food insecurity, so it's actually pretty bad. So here in this archetype, we start with an actor A, and the actor A does stuff and gains stuff from the things that they do. So this is a reinforcing feedback loop. The more they do, the more they gain. Now in this archetype, this is all about shared resources. So A's activity is part of the total activity, and the more that A does, the more total activity we have. The bigger the total activity, the less everyone gains per total activity, because there's a resource limit, and the return of investment gets smaller. So if you're digging for oil or you're fishing in a pond with a limited number of fish, at some point there's so little left that to get to that little bit, you have to invest more time and money and effort. So the less is gained per individual activity, the less actor A gains for their own activity. And this is in fact a balancing feedback loop. There's an upper limit, so the system will self-regulate as the gain per activity goes to 0. And because I said this is a shared thing, so we have the same thing for actor B, and there might be hundreds and thousands of actors. So this archetype will illustrate what happens if you exploit a shared resource, because the feedback that gets back to actor A is delayed. We have a delay here where the loss in gain of individual activity happens a bit later than you would expect. But while this is delayed, that reinforcing feedback loop just keeps going and keeps each actor cranking out more and more activity. So how do we get out? Generally speaking, and that's for every single archetype, once you make people aware of how these things fit together, that will already help. You can just educate your people on what will happen if you continue exploiting a shared resource like this. You can also restore or strengthen this feedback link by either privatizing the commons, so each user feels the direct consequences of their action, or regulating the commons, by regulating access to the resource. So for example, if you have a bunch of developers who just willy-nilly spin up pods on a shared cluster, not caring about resource limits or all of that, then you could give them each their own cluster and let them deal with resource management themselves. Or you can build a platform on top of your shared cluster and then restrict access to the platform. Or you could maybe do both, and if you're wondering how, you should come and talk to me or go to love.sh. Okay, so this is the final section. I want to share some small sound bites to help you think in and with systems. So right now, the hot button topic in DevOps is platform engineering. I think we can all agree on that. And I love platform engineering because I think this is the right way to address a lot of the problems that DevOps as a pattern or anti-pattern, depending on which religion you believe in, attempts to solve. So platform engineering really looks at issues in a systemic way and tries to solve it systemically. So taking that as an example, if you want to build your platform with systems thinking in mind, these are the things that you can consider. So most people are more used to advocacy than inquiry. Sorry, my notes are very small. Most people are more used to advocacy than inquiry. So before you touch any system at all, you should conduct systems interviews, you should talk to people, ask them, how do you see this? And before you like tell people this is wrong, just like listen and make them feel listened to and understood. Because people really need to understand that you care about them before they care about what you understand. Next, try to get I'm a bit late. Okay, try to get the mental models out there. It's very important to understand, like, why do people believe that? There's a lot of people out there who have different, really deep beliefs from you, and it's important to build on top of that, because those are things that you can rarely ever change. When attempting to solve a problem systemically, you should not try to optimize each element of the system, but the relationships between them. So instead of trying to like make every developer super fast or give them the right IDE, that's the perfect IDE, think about more like, how can I make it so that a developer is empowered to pick the best IDE for themselves? Make use of feedbacks and feedback loops. That is how systems behave. That is how systems work. Build in feedback policies into your system so it's able to self-regulate and self-heal. Maybe that's because why we love Kubernetes so much, because it's able to self-heal. So make use of the reconciliation loop of Kubernetes and put that and to fix any extreme state of stocks that you might encounter. Take a view of responsibility. So when people look at a system systemically, as I said, what will often happen is they understand that it's their own behavior, that leads to these issues. And being responsible, feeling responsible for the problem, doesn't mean that I have to blame myself, but rather it can be very empowering, because if you are responsible for the problem, by definition, it means you can be part of the solution. And then finally, understand buffers and delays. So try and utilize them correctly. Once you start thinking in systems, you can start identifying stocks, like compute resources, for example, but also something like the amount of cognitive load that a developer has. So if you notice any wild, stock states, then think of the stocks that you have and think about, maybe if I just twist the in and out flows, maybe I change something or I introduce a feedback loop here. That might help, instead of just, again, trying to optimize each developer by themselves. Okay, so I read 2 books, that's how I know everything, and I can recommend them to you as well, because they're really good. So the first one is called Thinking in Systems. It's a primer. It is very, very good to just get into systems thinking, just get a feel for how systems people think, and talks a bit about system traps. I showed 3, they're 15 or something. So what are systems traps and how to get out of them? And this other one is called Systems Thinking for Social Change, and that book really focuses on, processes that you can go through to really make organizational changes, but in a systems thinking kind of way. So, 31 minutes. That's not too bad. Okay, thank you so much for listening, and yeah. Come to me for stickers. No questions.
Yeah. No, we actually have 2 minutes.
Oh, we have 2 minutes?
We have 2 minutes, so we can take at least one
we have
question.
2 minutes.
Yeah. Is there any
man, I was stressing out
questions?
about it. Questions?
No questions?
Yes, these are glitter stickers. Yes, I know, that was the one question everyone wanted to know. If you have more questions later. Yes, Bart, please.
Leon, I read that you started with something else. I forgot. Would you have preferred to study anthropology or social sciences instead of going?
I studied law because I really like pain. And then I decided to do something more practical. I think it's what you study and what you learn doesn't determine what you have to do. I was talking about that earlier with Whitney, that there's no waste of time if you first pursue something else, because you never know when that knowledge might come handy, right? I went to law school for 3 years, and there's a lot of that stuff that I learned there that is very useful to me now. For example, how to draft legislation. I mean, not legislation on a state level, but even drafting policies for teams to work together. It's very helpful to understand because there's a lot of principles in law about how to draft something that's fair to all sides, even if we don't know those sides yet, that I can use now to inform my work now. So no, I would not like to be anywhere else than I am right now.
All right.
Yeah.
Thank you very much. It was a great talk. All right. Next talk coming up. Taylor is going to tell us about WebAssembly and how it fits in our future. Welcome, Taylor.
Yeah, thank you. Thanks. Thank you. Thank you, audience plants. Yeah, I am Taylor Thomas, and this talk is called WebAssembly, a recovering Kubernetes engineer's view of the future. Just a little bit about myself. Some of you are actually, I'm just going to ask this question right now. How many of you were at the talk that Brooks and I gave this morning? Okay, half the audience. Good. That helps me gauge what I need to repeat and what I don't need to repeat. Yeah, I am a director of engineering at Cosmonic. Big in the Rust community, contribute in a lot of different languages, but Rust is my favorite. I'm a co-creator of the Crustlet project and Bindle, as well as an open source maintainer and an emeritus Helm maintainer and core project maintainer for Wasm Cloud. So I want to give a little bit of history about myself. Normally I don't like to talk too much about myself, but this matters in context of this talk. So I got started with Kubernetes and Docker around version 0.6 of Docker, and Kubernetes since like 1.2. So it's been I've been there since towards the beginning of both of them. I built Kubernetes platforms at Intel and then Nike, and then I helped build AKS at Microsoft. And I was a core maintainer of Helm for 4 years. I wrote a pretty decent chunk of Helm 3, if you're a heavy Helm user. And my deepest, darkest confession in the Kubernetes world is I wrote the wait flag. If you know, you know. I regret that every day. So yeah, that's my deepest, darkest secret. But all of this is just the long way of saying basically like, I get it. Like, I understand the pain points of Kubernetes. I understand the strengths of Kubernetes. I've used it in all sorts of unholy and terrible ways, and I've used it in all sorts of really good ways. And we're going to talk a little bit about that in context of WebAssembly, because it always comes up, especially as we're here around KubeCon. So what's this WASM thing? Sorry for those of you who attended the beginning. Some of this will be a little bit of a repeat. I am going to make sure everybody understands, and I'm not going to spend too much time on it, but there's these 5 things up here that are the critical points to understand. This is what WebAssembly is, neither web nor assembly. It's not either one of the things, but it was adopted by the web first for these reasons up here. We like open things. It's small, safe, and secure. It can be compiled to from any language, and it's portable, runs anywhere. Those things that make WebAssembly good for the browser also make it very, very good for the server, right? We want things to be open standards. We have things in Foundations for that reason. We want default, basically sandbox by default. We want things completely closed off. We want to have things that are efficient and fast. We want things that are also functional in any language, and then we also want it to be able to run anywhere. We're going to talk a little bit more about each of those things, but let's talk a little bit about like what it can be used for first. What can WebAssembly be used for right now, or what we think it's the best for? One of the things is microservices, so general server-side computing, microservices, functions as a service, runtime optimization. Those kind of things are very, very good for WebAssembly. You can choose your runtime and how you compile WebAssembly at the actual point of running it. So you can choose whether you want to do JIT, interpreted, AOT. You can also choose whether or not you want to use an optimized runtime for a embedded device or a general purpose runtime. All of these things are decided at the very last possible moment. Constrained devices, as many of you heard me say this morning, I'm the edge with very large air quotes. Nobody actually knows what the edge is anymore, but in this case, I'm meaning constrained devices or devices that are further out from your normal data centers. For some people, edge can even mean their own data centers, but for here, like, it's very good on running on those tiny devices. It's also very good for plugins, especially with the changes that are coming with the component model. Plugins and libraries. It has the potential to be the last plugin model we'll ever need, and one of the best ways we can share libraries with each other. And then, of course, it's very good in the browser. Just ask big companies like Autodesk or Adobe or those people who have like AutoCAD and Photoshop and all those things. All those that run in the browser are almost certainly using WebAssembly because it's more performant than trying, to write image transforms in JavaScript. So one of the things I wanted to mention before, it's an aside, I mentioned this partially in our last talk, but I'm going to just a little bit deeper here, is this idea of the component model. This is what enables us to have libraries and enables us to have these kind of plugin systems. And the idea of the component model is everything works using an interface. Each of these interfaces are defined, and if you are able to share them, then anybody can use that interface. So we already have some group effort around this in the WASM community called WASI Cloud. And the idea is like, here, these Lego blocks are a perfect example. Let's say you have an HTTP proxy everything has to go for. If you're using Envoy, your HTTP proxy could be using Envoy underneath the hood, and then you have like your open tracing stuff and things on top of it. But also you could have, at your big company, you could have your own custom sort of stack that's going on, or your own custom HTTP proxy, and you can plug it in. Everything becomes just basically little Lego bricks you can put together to make the final thing you're going to use. They're easily swappable. And so that's what the component model allows you to do. It says, here's an interface. Do you satisfy this interface? Then if yes, I can combine you. And did something happen with my... Okay, perfect. Whew. Okay, so what are the pain points inside of WebAssembly right now? Networking is still difficult. We're moving along quickly, though. We have things that we had WASI sockets land 6 months ago or so, and those are starting to come in. We have a lot of work around and a standardized like HTTP contract that's going on for the component model. Things very much are in the fast-moving stage. They will bleed. I call it the hemorrhaging edge. It's not even the bleeding edge. It's the hemorrhaging edge. You will get cut and you will bleed just because if you're doing all the latest things because it's just so new. From an execution speed standpoint, you're never going to get as fast as native code with WebAssembly. I think it'll get closer and closer as people start doing all sorts of crazy optimizations with it. But right now, if you're trying to do super performant, low-level system code, it might not be the thing you're going to want to use. And then just the tool chains aren't really there yet for some languages. That's getting better, honestly, week over week at this point, but there are still things where if you just try to go, hey, I really love my Python, and then you just try to compile to WebAssembly, you're probably going to run into a bunch of problems. Python is getting there, and it's very close, but you have to know some of the rough edges. Now, we have this tool called WASM Cloud, and to make it very clear, WASM Cloud is an open source project. Everything is entirely out there in the open. It's owned by the CNCF. My company, Cosmonic, we're major contributors to it, and we do stuff with it for our company. But WASM Cloud is an application runtime. And sorry, once again, this is a review for those who came this morning, but runtime versus application runtime is an important distinction. Think Docker versus Kubernetes, or JavaScript versus React. One allows you to build applications, and yes, you can build applications with lower level blocks, but it's a lot harder. You have to do a lot more manual assembly. It's the same thing with WebAssembly runtimes. WASM Cloud is the thing that lets you run applications easier on top of a WebAssembly runtime. And we use distributed capability-driven development, which I'm going to show just mostly how this all works through demos, and explain some more about the different points there. So that's where WASM Cloud comes in. So I want to go ahead and talk about just like a basic overview of WASM Cloud, what it does, and why it matters here for this conversation. Then we're going to talk a little bit more about this in context of Kubernetes. So over here, this is what we call the washboard. It is our built-in dashboard that comes with WASM Cloud. I actually will go ahead and just show you how easy this is to work. I'm running some specific versions for testing, but I can just run our command line tool. Come on, bigger, bigger, bigger. There we go, sorry. Okay, so I can just run our command line tool for WASM Cloud, which is called wash, and I can say wash up is the most generic one. I haven't updated the latest version, so I'm making sure I'm pulling down the latest WASM Cloud version, and it's going to go ahead and start everything up for me, and it's all running. And then I'll have this washboard available for me to look at. So I'm going to do the most simple of all demos. This is the same demo that we showed earlier, but I'm going to do it do a couple things in some different ways. I'm going to go ahead and start from the registry, our key value server. So this is WASM Cloud. It's at 4, right, Brooks? 0.4. I always forget when I'm on stage. Okay, good. We'll give that a second. It's going to download. Okay, there we go. So that pulled down from an OCI registry. It's not a container. It's just stored in an OCI registry. And I started one of these up. I'm also going to go ahead and start the Redis provider, the Redis server. Version on that again, Brooks, because I'm having a hard time remembering right now. 19. Thank you. I'm just showing you this all manually so you see like everything that's going on here. So we'll give that a second. Once again, we're going to hope the Wi-Fi is not slow. I had it cached, but we'll see if it stays cached around. So I'm going to start that up, and then I'm going to start up a Redis server locally. This looks very similar to what you do most of the time. Like if you're doing local development. So I just started Redis locally. I have this Redis key value store working. And so before I do this next step, so I have what's called an actor. This is your business logic. This is where the actual code is at. Then I have a provider. This gives me a connection. It's a dependency. So in what we've done in Wasm Cloud is we've pulled out all these dependencies so that they're no longer part of your code. And when we look at the actual code involved here, this will look familiar if you were here this morning. It is a simple saying, I am an HTTP server. I don't care what gets me the HTTP request. I just want an HTTP request. There's no port setting up. There's not that same 10 lines you copy from every Go project to get your server going. There's none of that stuff. And then down here, I say, hey, there's this key. I need to talk to a key value store. So I'm just going to talk to a key value store. Once again, there's no connection strings, there's no clients, there's no anything. It's just saying, I would like to talk to a key value store, I don't care which one. So that's all the code is. That's 49 lines of code to give us this KV counter. And so now what I do is at runtime, because it's not connecting anything, I have to do a link definition. And so this thing I say, hey, I'm going to connect these two things together, and I'll go ahead, and I actually don't have to add it. I can add some configuration, but I'm just going to let it connect to localhost. So that's automatically going to put everything together. Everything started up for me, and so now I can go to here and define one more link, which is with, oh, I need to start it. It'd help if I start the thing. Okay, so in this case, I'm starting an HTTP. There was, dang it. It's going to tell me an error in a second, so. There we go. Should take it a second and should be up. Okay, so now we have an HTTP server, and I'm going to define a link between that. So I'll say KV counter, HTTP server. And this one, I'm going to give it some configuration. I'm going to give it an address of 0.0.0.0. We'll say 8081. Sure, why not? Okay, all of that's there. So now I can go to localhost 8081. Ta-da! Okay, so I just took that code that you saw, had nothing to do with Redis, none of that thing, and I said, hey, connect me to Redis, connect me to an HTTP server. And now I can increment this key value store. This demo is purely to show you the basics of what's going on here. So this is all powered by WebAssembly. That code is WebAssembly. It can run on any system, and I'm going to start showing how this all connects in. So we're going to do that. But first, before we go back to this demo, I'm going to talk about how do Wasm and Kubernetes play together here, and then demo something even cooler than what I was just showing. So let's bust a few myths first. These are some common questions and statements I've heard from people as I've talked to people out in the community. The first one is Wasm going to kill containers? If I had a dime for every time, sorry, if I had any money, I'm not in the US, shouldn't use US currency, but if I got money every single time I had this question asked, I'd be a very rich person. But WebAssembly is not going to kill containers. This is evolutionary. There's things that just run better in containers right now, and sometimes you already have stuff set up for containers, or it's just easier for you to, there's all sorts of requirements. This isn't going to be a container killer. I do think, however, that lots of applications will be written in WebAssembly as opposed to containers in the future, particularly microservice-based ones. So that's the first myth. The second one is, hey, I should just run my WebAssembly in containers. No, you shouldn't. That kind of is defeating the whole point. WebAssembly offers you the sandboxing, the cross-platform, all that stuff you'd expect. But if you take that and you have a slight overhead because it's not native code, and then you wrap that in a Docker container, which adds more overhead, and then you often put that inside of Kubernetes, I mean, you kind of just wrapped it in a bunch of cruft it doesn't need. So don't just run your WebAssembly in containers. There's other projects, which I'm going to mention here, if you want to run like WebAssembly directly in Kubernetes that you can use that are going to be more efficient. The other thing I always hear is WASM and the various runtimes of WASM and Kubernetes are in competition with each other. Also know, and I'm going to show that exactly why. People have invested a lot in Kubernetes. There's good things for Kubernetes to do here, and we don't want to just, it's not competition here. They actually can help each other out and help get to places that each of the others can't as easily. So what can you do now with Kubernetes and WebAssembly? You can use RunWasi. The RunWasi project is a really cool project that I think a lot of people at Microsoft and the Deus Labs team worked on, and then a couple other people in the community. And it essentially runs, if you're familiar with the Kubernetes underlying stuff, you have container dshim. It's essentially running a container dshim underneath the hood, but instead of being container D, it's running WASI runtimes. So this is a way you can do it, still run it like it's a normal pod, and run WebAssembly underneath the hood. Also, if you've never noticed before, things like Envoy already have WebAssembly in it. You can build filters in WebAssembly and use it as a plugin. So it's already there. And then we can also use Wasm Cloud, and I'm going to show that today, how you can use Wasm Cloud with Kubernetes. Now let's go to the other side. What does WebAssembly do better than Kubernetes? It is going to run smaller for you. End of story. Let's put it this way. You have, well, first off, let's start with some numbers we've seen. Most equivalent applications, it's hard to do apples to apples, but most equivalent applications in a well-maintained Docker container versus in WebAssembly, the WebAssembly is about 1/10 of the size. So if something is 20 megabytes and you've done all the work to keep it really small and it's on Alpine or whatever, or Scratch, you can get it down to like 20 megabytes. That same thing running in WebAssembly is going to be about 2 megs or less. So it's a lot smaller, and that means faster download times. It also runs a lot quicker because you don't have the overhead of the Docker container, or the Docker container in there. But also, let's have a real talk. The default max pod limit for a Kubernetes node is 110 pods. Even if we assume there are 5 containers in every single pod, which is a bit ridiculous, you have 5 containers in every single pod, that's 550 containers you can run on a single node. One of these, I actually was testing something and had broken an algorithm the other day. I scaled it up to 6,000 of these things running on my machine simultaneously without blowing up. Nothing froze. I didn't come to a screeching halt. Like that, there's a massive amount of scale here that you can gain from WebAssembly. It's also entirely sandboxed. Docker, and especially Kubernetes by default, is not like very, there's a bunch of security policies, there's a bunch of things you have to do to really lock it down. By default, WebAssembly can do nothing unless you give stuff to it. It's also entirely cross-platform. We've been deceiving ourselves for years by saying, Docker lets me run things anywhere. No, it doesn't. If you want to actually run a Docker container everywhere, you have to build a container for every single architecture. And that's not even to start to mention the fact that there's a difference between Linux containers and Windows containers. Containers for Mac don't even exist. There's no cross-platform. WebAssembly, a lot of the modules that we have been built on Macs or random Linux machines or Windows boxes. Doesn't really matter. They all are able to build and run anywhere. And then the edge. Kubernetes is not very good at the edge. Now I'm going to first shout out to the K3S team and the people at Rancher who did that. It's an amazing project. They've done a crap ton of work to make that so easy to use on smaller devices. But really, for production use cases, it's very hard to run Kubernetes at the edge. Kubernetes is meant to live in the same localized data center. And I know people have done work to do out there, but it really starts to break down and become very complex when you take it out of there. If you want to connect multiple devices, for example, if you're a telco and you need to connect to things on cell towers, or power company and you need to connect to devices running in your power distribution nodes, or people who are running embedded devices in stores, or whatever it might be, Kubernetes doesn't cover that very well. There's a lot of work required to make it actually play well together. And then there's this thing I like to call the lower bound problem, for lack of a better term. you're talking about cold start speeds, and I'm not getting into the nitty gritty of, oh, well, this is 4 milliseconds versus 20 milliseconds. I'm not talking about that. I'm talking about, like, just think about the day-to-day operations. If you need to move something close to a customer, and this is real life stuff we've talked to people about, Fortune 100 companies who come in and they say, I need to get this thing close to my user. It needs to have fast response time. The time to get a container up and then respond to a request is often larger than about 200 to 300 milliseconds, and that matters. WASM can start up quicker, clean up quicker, and use less resources than what you're going to get with containers. So that's what WebAssembly does better than Kubernetes. But here's a possible view of the future that I'm hoping to, like, these are just the future according to Taylor. So all of these are probably going to be wrong within 6 months, but I'm going to say them anyway. The first thing is that I truly think that all functions as a service platforms will become WebAssembly based. Instead of having to add custom, like, Docker container runtimes that know how to run language X, Y, or Z, what if you just take something that compiles to WebAssembly, or just a WebAssembly binary that can be written in any of these languages, and run it? So I think that in the future, that's going to be functions as a service. I also think many true microservices, and by true microservices, I don't mean your super large Java thing that runs with 20 megs or 20 gigs of memory that you dumped into a Docker container. That's not a microservice. I'm talking about true microservice architectures. I think those are going to become WebAssembly modules over containers. I also think that WebAssembly is going to be the plugin model to rule them all, especially with the landing of components. And then I think there are going to be a whole bunch of newer waves of platforms or tools that are built directly on top of WebAssembly that leverage its ability to be distributed everywhere. So with that in mind, let's talk about WebAssembly and Kubernetes in action. So I just showed you this local demo that showed everything running. I'm going to go ahead and actually, like, spin that down. So what I'm going to do right now is I'm going to start showing you this in Cosmonic. This is not a product pitch. It's just Cosmonic is running WASM Cloud for you, and it has a nice UI for me to show you what's going on. Makes all this easy. So first thing we're going to do is, this is what we had. Okay, I had, like, my laptop that was running a provider, had the KV counter that was talking to another provider, talking to Redis on my local machine. And we're going to spread it out to this. So I actually was going to be running this on DigitalOcean, then made a last-minute choice to switch it to AKS for fun and profit. So I know that says DOKS, but this works anywhere. So I'm going to run something inside of Kubernetes and then have something running in Cosmonic and show this all work for us. So what we're going to go ahead and do is come over here and say, so here's my Cosmonic dashboard. I have a node running that's hosted by Cosmonic. And then we have two different ways. If you're doing WASM Cloud, just plain open source, we have a Helm chart that, like I said, Helm maintainer, so I wrote a Helm chart. And so the Helm chart is in here, and you can actually use this to do exactly what I'm doing. Inside of Cosmonic, we just actually added something that we're not technically announcing to tomorrow, so you all get a preview, called Cosmo Connect. And so this is just going to set everything up for me. And it's going to connect to my AKS cluster that's running. It's going to start some resources for me. It'll take about 10 or 20 seconds more, and it'll be all up. Meanwhile, we'll go ahead and run, oh, perfect, there, it's all done. So if we come over here, it'll take me a second, probably because of the internet. Yep, there we go. And then you'll see that there's two hosts running inside of Kubernetes. And then it's also spun up a couple other things to make everything happen automatically for me, these things down here. And so I'm going to go ahead and start up the KV counter actor over here. Let's go ahead and, there we go, sorry. So I'm going to start up the KV counter, and I'm going to run it just so you know it's running, like, on the Cosmonic managed host. You can see it here. I'm going to launch it. Give it just a second to spin up. Okay, now it's up and running. So I'm going to say, let's say, connect this up to, I need an HTTP server for it. But I want to connect it to something running in Kubernetes. So I'm going to connect it to my Kubernetes HTTP servers that are running. This is just an automatic routing layer that's there. And I'm going to give this one of 8081 as well. We'll do 8081. Okay, so we can create the link. And we can actually come over here and say kube control get service. Hey, look, there it is. We're going to be making these nicer names. That's just the ID of the, yeah, I know, I see the laughter out there. Don't worry, we're going to make those nice names. This is the ID of the code that it's running to. So every single one of these has an ID that's like right here. You'll see it's the same thing that's down here. And so anyway, we're going to make that a nicer name. But right now it happens automatically, spins it up, has the right port ready to use. And so what I can do is take this and can say kube control run. I'm do this just so you know, I am not pretending. I am starting just a pod right here, and I'm going to literally do an app update, apt install curl right in front of you, so there ain't no lying going on. And we'll let that install for a second. It'll take, yeah, there we go. And we're going to have it. So while that's running, I'm going to go ahead and say, I need to connect this to a key value store. Now, I can run this inside of Kubernetes, but I accidentally deleted that pod, so we're going to change this, and I'm going to connect it to my local laptop running here. So I could have this, I'm going to start at this provider. You're going to notice it's the same thing. I'm going to say, oh, I actually have to do one more thing. You can also, over here with our Cosmo tool, say, this is the same thing. Once again, can do this with normal open source WebAssembly. I'm just going to connect my local machine to Cosmonic as well. So it's going to take a second while it sets it up, and there we go. Okay, so yep, I have a new, it even told me I have a new host, and it just created everything. And then I'm going to spin up a provider on that host, KV Redis, and just so you know I'm doing it again, we're going to say OS is Mac. Sweet, connected that up. Okay, so now I have this running there. And I'm going to connect it up to that key value store. I'm not going to provide any configuration, just so it's there, and now it's all set up. So now we're going to go back to my temp thing over here, and I'm going to say, okay, I should have curl now. So curl, okay, right, there's the ID. And then API. Oh, I forgot the V. It's API, right, Brooks? Yep. Let's see what it's doing. Yep, I am. Thank you. See, this is, once again, in case you didn't think it was a real demo, I'm missing the port. Okay, 8081/API. Okay, perfect. So I think I have to set default for this one. Is that what it is, Brooks, for counter? Did I do that wrong? Okay, anyway. Is that right? Hold on, this is where I go double check my own code because apparently I forget it. API counter, there we go. Ha! Counter, okay. Perfect. There we go. So you'll notice the counter is 7. That's because I just hit the counter before on my local machine. So this is a Kubernetes cluster running in, I think I ran it in US, like east somewhere. Kubernetes cluster running there, my laptop here with the database on it, and then a pod. That pod, I'm just using that pod as if it were a Kubernetes service. So that could be anything you're already running in a container can now talk to this service and then hook into the logic you're already using. So this is a very powerful pattern because you're starting to like extend things out to the edge. And I could also try to do a Redis. Let me see if I can remember the command. There we go. Perfect. I'm going to install Redis on my Kubernetes cluster real quick. While that's running, okay, there we go. Perfect. Should be up. So kube control get pods. It's still going to pend for a second. So we'll go back to that. So I'm going to actually swap out to another thing just to show. So we went through, I had to change from a Redis database running in Kubernetes to a Redis database running on my local host. And I'm going to go ahead and swap this out and say, you know what, like, okay, I'm running this KV counter on Cosmonic, but what if I went ahead and deleted this and said, you know what, I'm going to run this KV counter on my local machine. So once again, we'll go to find host and say, make sure this is on my Mac, please. So then now it's started up. We'll take a second, then it'll be started up. Okay, now it's all started up, and it's still running locally. And I can come back into the pod and should get 8, because now yep, 8. Okay, so now I just completely moved my computer around without changing code, without changing configuration, without changing anything else. And then I could also do something like this and say, you know what, I'm gonna swap out my provider. I'm gonna use the one that's built into Cosmonic, or I could be using like DynamoDB, or I could be using Cosmos DB, or I could use whatever it might be. So I'm going to change this out to, oops, not the wormhole. Built-in key value, there we go. So I'm going to start this up, and now I'm going to take it as soon as it starts up. Perfect. And I'm going to delete this one and say, you know what, I'm going to change where it's linked from here to here. Create link. And I can come back, and this value is going to be probably much higher because I've done this before. Oh no, 5, sweet, it's new. So perfect. So now I'm doing this with, now I just changed it again. So I'm still running this service in Kubernetes. I've changed databases, I've changed where it's running, and I've just shifted this all around however I wanted to. So you can see how this could be really useful. If you want to take advantage of some of those cool things I was talking about with WebAssembly, I know you don't want to rewrite your whole application. No one does. But like you might be rewriting one significant part of your service, or one small part that's like the thing that's costs you the most money. And you can run it in WebAssembly using like Wasm Cloud, and then just automatically extend it out to the edge. We've extended it out to my laptop here. This could be a Raspberry Pi. This could be whatever I want it to be. So, and that kind of shows that full flow. So what we're going to do is, I'm just running out of time, so I'm going to close it up here so we have time for questions. I'm leaving myself a little bit more time. So for those who attended the last talk, I gave these points, but I want to talk about them one more time in context of this. So what could you do now? What can you actually do? First thing is what, like I mentioned, you can start with that small service, whatever that thing might be, and move it over. You can do it in Wasm, and with these things that allow you to connect to Kubernetes, you don't have to change any of your other services. You might have to change which service it's talking to, right? The automatically created service that we do for you. You have to create that maybe. But then you could also do one part of a service. You could move part of it over and have all of these talking back and forth. You can also have stuff running in WebAssembly talk back to Cosmonic. Or sorry, WebAssembly talk back to, like running Cosmonic talk back to Kubernetes, or you could have it running in just plain Wasm Cloud. Like I said, this is all entirely available in the open source. And then you could also have a full stateful application, which we showed one of those earlier today with a pet clinic example, where you could run the whole thing on Wasm. So that's what you could do now. So with that, I have these up. These are the same ones I had in the last talk as well. If you want to join the Wasm Cloud Slack, it's on the left, and on the right we have the landing repo for Wasm Cloud itself. But I want to leave time for some questions here at the end. So I think there'll be a few. We have one back there.
Thanks. With your managed product that you demoed, what technology are you using for your networking?
Networking is NATs. So underneath the hood, it's all like that. That's not for the managed product, that's for everything. So Wasm Cloud uses NATs underneath the hood as its connecting layer. And then we have what we have in Wasm Cloud, and once again, this is all the open source stuff, is a bunch of signing and other things that go along to make sure everything's secure in between each of these things. But we use NATs underneath the hood to connect everything.
So you're, serializing TCP connections over NATs, are you?
It depends on the thing. Yeah. There is an RPC protocol in place here. Right now, I think we might use message pack underneath the hood still, and so that's what we're using right now. This is going to keep changing and being even more efficient with the advent of basically components, because components have their own like lifting and lowering logic, so we can essentially go down to bytes across a wire and then translate it on the other ends. So those are our things we're heading for right now. But yeah, underlying network stuff, we keep that as optimized as we can. But obviously there is still a penalty technically, but we keep it, it's still pretty efficient, all things considered. It's not any slower than anything you would do like Kubernetes that's spread across multiple areas.
Thanks.
Any other questions? Okay, awesome. Thank you so much, everyone, for coming. Have a great rest of your day.
All right, we have a longer break now until 4:10, so go enjoy some fresh air or beverages. slide. Yeah. I'll introduce you quickly and then you can start. All right. All right, so we are back from the break and we have Roman here who's going to talk to us about monitoring our Kubernetes deployments.
Yeah, hello everyone. Nice to meet you all, and that's the first time I'm on this conference, and really pleased to give a talk. So my topic is Kubernetes monitoring and why it is so difficult to monitor it. And who am I? I'm basically an engineer and also a co-founder of Victoria Metrics time series database. Everyday work is engineering for me, so I've seen the problems with Kubernetes from the real-life experience. And what is Victoria Metrics? That's an open-source time series database, and this is where I see these problems with Kubernetes monitoring, basically. So this is a screenshot from one of the researches done by Chronosphere.io from 2022. And according to this research, like 70% of companies are concerned with the growth of their telemetry data. And when business says it is concerned, that basically means it is too expensive. Like it basically means that expenses are higher than they expected, or they just can't scale up at the required pace. And scaling of telemetry data is not usually correlated with the value which that data brings. So when you are concerned with the growth of the telemetry data, probably you don't have enough value from it, or you don't see increase of the value when this telemetry data is increased. And this is also a good screenshot from this same research, and it shows how businesses increased in scale with time, and how the same was to the telemetry data they collect. And you see that at some point, telemetry data started to scale much faster than business value scale, like 2-3 times more. And another important thing is that on x-axis, you see that those businesses were slowly moving to the cloud-native approach. So basically, they were moving to a microservice architecture. They were moving to running Kubernetes. And another report made by CNCF from 2020, and that's basically a question, what are the main challenges from running a microservice architecture? And 40% of respondents are concerned with complexity they face every day when they move to cloud-native approach. So why Kubernetes monitoring is so challenging? How we end up here? Kubernetes is like almost 9-year-old or almost 10 years old, and probably a lot of people started to learn and use it like 3, 4, 5 years ago, and it is likely Kubernetes was already complex by that time, and you just accepted it as a fact why it is so complex and why so many metrics are exposed by Kubernetes. So let's try to understand why collecting telemetry is so complicated in Kubernetes. Well, first of all, Kubernetes is quite complex. It contains a lot of components, and if you go by that link, you will see that each component of the Kubernetes exposes some specific set of metrics. And to understand how Kubernetes works and how to track the state of Kubernetes, you need to learn what are those components and what are those metrics. And another problem is that the amount of these metrics also grows with the time. Like, it is increasing every year. If you're comparing the amount of metric names, unique metric names, not time series, just metric names, comparing to 2018 and 2022, it increased like almost 4 times. And at some degree, you could say that if we consider that you need that many metrics to describe this process, then at some degree you can say that the complexity of this process is represented by the amount of metrics you need to use to describe it. So at some point, I can say that complexity of the Kubernetes also increased comparing to 2018. And the same is for the most popular exporter. Everyone runs on each Kubernetes node. For node exporter, if you see, the amount of metrics compared to 2016 also increased like 4 times. That means that, from my perspective, node exporter became 4 times more complex. You can argue that it's become more detailed, but if you take a person who started using Node Export in 2016 and the person who started using it right now, they will need to spend different amount of time to understand what are metrics exposed by the Node Exporter. So basically, that's also a complexity. And here are some simple formulas to calculate the amount of metrics exposed by every Kubernetes node. So at minimal, if you set up just a basic Kubernetes cluster and you install the basic things on each node, the minimal amount of metrics you can expect this time series from each Kubernetes node is like 2,500 or something like that. And that's just the minimal. Realistic number of values will be like 4,000 or even more. That all depends on the amount of hardware you have, amount of and containers you run. So yeah, and 4,000 is still not a lot, but if you have like 10 nodes, it will be already 40,000. So you have a multiplicator here, and multiplicators are a very dangerous thing. So what are these metrics? Well, back then, before Kubernetes, running an application was quite simple. You have a hardware server, just an instance, and you have your application, and you run that application on the instance server. Now you have the same instance. You have installed virtual machine. On that virtual machine, you have a pod. Inside the pod, you have application, which consists of 1 or more containers. And all these metrics in Kubernetes need to describe you what's happening inside of these layers. So if something happens, you could understand from these metrics what exactly happens. And this becomes worse when you start to scale, because you have multiple hardware servers, multiple pods or applications can be deployed on the same hardware server, and again, you get increase of complexity. And this is how it looks in practice. So if we deploy a very simple application, Nginx server, with 3 replicas. And we start to collect metrics from the cAdvisor, not even from Nginx itself. Only cAdvisor will give you like 600 more new time series to describe how this deployment runs. So another very important problem is time series churn, which also very interesting part of the Kubernetes. So before you had time series. Time series is a consecutive, ordered by time list of observations. And when you ran an application on the old-fashioned way, on just a physical server, you had this, for example, HTTP requests metrics, and it was labeled with the instance, IP address, or name, or whatever. And it doesn't matter if you restart the instance or you restart your application, you will still have the same time series. In the Kubernetes, you have a pod name, and pod name is a label which is attached to each time series exposed by this application. And every time you redeploy your application, just restart or change a version, you have a new pod name, which means that one specific metric will be replaced by another metric with a new pod name. And this is quite complex for monitoring solutions to keep up with this churn rate, because Kubernetes teaches you to not afraid of frequent redeploys. It's like the philosophy is that you need to deliver as fast as possible, and it is totally okay to make new deployments like 3-4 times a day. And if you see this formula, it also has some multiplicators. It basically, you have container stat metrics plus application metrics, and then it is multiplied by amount of deployments and replicas that you have. The more replicas you have, the higher will be impact of each redeploy. And yeah, by the way, what do you think is the average lifetime of a time series nowadays in Kubernetes? Like how long? Hours, days, weeks, months? How long could it take for time series to be alive? Yeah, you're right. So from my personal, work experience, we observed some metrics from a big cluster, which was collecting metrics from Kubernetes, and it had like 80 million of active time series. Active time series is a time series which exists right now, or was ingested in the last 30, 60 minutes. So that's your current metrics. The current number of time series is 80 million. But if you calculate the amount of active time series collected for the last 24 hours, it was more than 1 billion. So in fact, it says that all the set of metrics, all 8 millions, are changing more than 10 times per day, right? So that's quite a concerning thing. The average lifetime of a metric is about 2 hours. And comparing to old-fashioned way, time series just existed as long as they could. And this is what, for all time series databases, are optimized. They are optimized for long-lasting time series, and they are all vulnerable to time series churn. I mean, Prometheus, Thanos, Cortex, Mimir, Victoria Metrics, all they are vulnerable to time series churn. Okay, so we have a lot of these metrics, and we have a churn rate. Do we need all these metrics, actually, that Kubernetes exposes? There is no easy answer for that question, because some people could say, no, we don't need them. We need only those metrics that we actually use. Metrics which we run in our alerts, metrics that we plot on our dashboards or build in our reports. Let's keep only those. But there are some people which are concerned about some specific event which could happen at unpredictable moment of time, which is called usually an incident. And when that incident happens, you want to understand what happened. And when incident happens, it is likely anticipated event, not anticipated event, sorry. So you start to dig into all the metrics that you have in order to find a correlation, to find an answer why this incident happened. And probably you will need all those metrics exposed by Kubernetes, or at least you want to scroll through them to understand maybe something will help you to get the answer. Okay, how we can determine which exact metrics we need? There is a tool from Grafana Labs called Mimir tool, and what it does, it actually scans the list of your alerting rules, recording rules, and Grafana dashboards. And from that, it forms a low list of metric names, which is then used in relabeling. And each metric which doesn't fall into this allow list will be dropped. And according to Grafana Labs, if you apply this Mimir tool to the regular Prometheus kubestack installation, you will keep like 8,000 out of 40,000 of metrics. So basically, you will save only every 5th metric, and the rest of them aren't used. If you take a look at kubeprometheus stack, which is usually used by default, it exposes like about 1,200 metrics. Metric names, and only 300 of them are actually used in the dashboards and alerting rules. So there is 76 unused metrics which you don't use every day, and you collect them just in case, and you store them just in case, and you pay for them every day. Okay, how we can, what we can do with this, like how we can reduce this amount of unused metrics. Maybe there is some monitoring standard which could help us to unify all this. Well, there are some standards. For example, this is a use monitoring standard, which stands for utilization, saturation, and errors metrics. Usually people use these standards for monitoring hardware, but it is not applicable for applications usually. So there is another method called RED, and it is applicable for applications, and it stands for rate, errors, and duration metrics. And also there is an alternative from the Google engineers, and it is called 4 golden signals, and it is like more a mix of RED and use, which also helps you to think about how your metrics needs to be formed. But still, all these standards doesn't help because they are not binding. Like, they do not force you to do something, they are just recommendations. And since they are just recommendations, many companies can use them or not, or they can have their own standards or their own libraries for instrumenting applications with metrics. So you end up with a huge amount of metrics in each solution. And another painful thing is that this amount of metrics changing over time. That was metrics which were useful like a year ago, today might not exist, or may be renamed, or just not used anywhere. And yeah, you can find many articles in the internet arguing what to do with this, but still no strict, not defined answer what to do with this. Yeah, and that's one of the results of how fast everything is moving. On Grafana.com, you have a list of community dashboards, and people usually use it. And why? Because you see the amount of downloads that usually is hundreds of thousands of millions. And those dashboards are not updating for 3-4 years. So basically, if you install them now, it is likely they will be not showing you the full picture or won't be working at all. Of course, you can say in Kubernetes you can have mixins which generate your dashboards from the upstream, but still there is like no coupling between dashboards alerts and metrics. There is no like a binding power. You can create a metric, but no one obliges you to use it, and this is the point when everything can go out of sync. So what are the challenges which were brought by microservice architecture? Well, now instead of one single application, we have a bunch of microservices, and also those microservices are installed, are having like multiple instances, and each instance have their own metrics. And as far as you go to bring your single application to microservices, the more metrics you will have. Right? Now, when you have this many microservices, users need to understand the full picture of what's going on. Users need to track and correlate events across all those microservices and instances, which is also a complex task for monitoring solutions. Ephemerality, or the thing when you have these pods restarted all the time, only brings more complexity in the thing because you have all these labels all the time changing, and now you need to somehow ignore those pod labels or account for those changes and try to locate what happened to your application. To overcome these new problems, some new solutions were used and introduced in the modern monitoring, this distributed traces, and in Grafana stack you have exemplars, which bring more context to the events. In distributed systems. So basically, trace or exemplar could give you more information without contributing to the metrics cardinality. And all this is only to overcome these challenges from the microservice architecture. Also, when you have a lot of microservices, another very complex thing comes into the play. It's networking, because if you have many microservices, they communicate with each other, and then you have a network which connects those microservices. And network is also a very complex thing. So now you need to account for the problems with network in your application, and that also needs to be monitored and explained. And also, another thing is collocation. So Kubernetes allows you to deploy multiple pods on the same instance, and it does it very well. But sometimes it creates a problem of noisy neighbor. I don't know if you've seen that, but I've seen it a couple of times when one application starts to behave, one pod out of 100 start to behave oddly. And this is only because it was deployed to the same instance where another application was saturating compute resources. And there is like no good way to understand what's happening until this pod is redeployed to another instance and everything becomes okay again. Okay, what else Kubernetes bring into the complexity of the modern application deployment? Well, Kubernetes itself needs to be monitored, and we already said that it exposes a lot of metrics, and you need to collect them, you need to store them, process them, and understand them. So this is cognitive load, and this is the place where you need to pay money for storing those metrics. if you think about that, like I just Googled yesterday, like how many Kubernetes clusters are out there in the world, and it is likely 3 million of clusters running everywhere. And if you add, I don't know, 10 more metrics to the Kubernetes stack, it will be immediately multiplied by 3 million, and that's already a huge number. So you need to be very careful when you introduce any changes to the Kubernetes metrics, because once you add it, all people and engineers over the world will need to collect those metrics, store it, process it, and understand. So that's a huge impact. What else? Active time series churn, which is, I already said that it's quite complex problem for all monitoring solutions, but we'll talk in more details later. So all these challenges from microservice architecture and Kubernetes architecture, what we do with in the monitoring area, what we do with them, we spend a lot of time to overcome these challenges. We spend a lot of time to remain efficient and to deal with these problems, to give users more better tools in order to understand what's happened with these complex distributed systems, what happens with network, with compute, with all the microservices. So a lot of time is spent only on that. And maybe if there was no Kubernetes at all, if we run that in old-fashioned way or in some other way, we won't need these distributed traces. We won't need exemplars, because the complexity will be lower, and you won't need to explain it with new tools. And maybe if there was no Kubernetes, all this time which we spend in the monitoring area can be used for doing something more interesting than just dealing with big amounts of data. Maybe I don't know, automated root cause analysis or anomaly detection or automated metrics correlation. But no, if you take a look right now at the Tanos Cortex Mimir promos, they are all bragging about we are dealing with tons of metrics. So all what competitors in the monitoring section do, they are just bragging about how much data they can process and how efficient they are at this. Okay, this is a good quote from Brian Brazil, who was core contributor of Prometheus, and this quote from 2018. And Brian is answering the question how many metrics application should expose. So Brian says that a very complex application with a lot of moving parts, he expects it to expose about 1,000 time series. And in the same time, Prometheus is, I think, is a very complex thing. And Prometheus at the time was exposing 700 of time series. And this is quote from 2018. So if you try to count number of metrics right now, it is 1,600 metrics exposed by time series exposed by Prometheus. So almost 2 times, more than 2 times since 2018. So you could say that complexity of Prometheus increased with time. And it's not only about Prometheus. Vector metrics is also doing that, so entropy only grows. Amount of metrics we expose now is 3 times bigger than we exposed when vector metrics was released. And we use only 30% of them in our dashboards and alerting rules. So you see the entropy always grows, and all solutions become more and more complex. So we need to strive to reducing this complexity at some point. What you can do with that? Well, in Kubernetes, you can disable some metrics or build an allow list, and to expose a little bit less metrics, only expose those which you use. What does Prometheus? Well, Prometheus basically changed the storage layer just to deal with these challenges introduced by Kubernetes. If you check this quote from the article when Prometheus 2 was released, it basically says that Prometheus needs to adapt to new challenges introduced by Kubernetes and Mesos. So that's basically the reason why Prometheus 2.0 exists, only because of Kubernetes. But still, even after that, high cardinality issue and churn rate didn't disappear. They're still there, but Prometheus is just more efficient at this. So there are a lot of issues about Prometheus resource usage. What Victoriometrics does with that? Victoriometrics also tries to be like more efficient with the resources to do the same work. It also uses like short-term indexes to improve performance for storing these high cardinality metrics with high churn rate. And it also supports streaming and aggregation, which helps you to pre-aggregate data before they got ingested into the database, so you don't spend those extra resources like you do with recording rules in Prometheus. So you can do some calculation before they got into the database. How we can improve the situation? Well, we need to think first how to reduce this complexity in the first place. We need to always think carefully about amounts of metrics exposed by Kubernetes or by your application, because adding metrics is easy, removing metrics is what really challenging. We also need to take care of amounts of label value pairs exposed by application. Usually histograms contribute a lot into that, so we need to be careful when we choose label value pairs. Also, what can be done, horizontal pod autoscaling or frequent deployments that result into high churn rate. We can probably also think how we can reduce that. For example, keep pod names stable, which will improve situation drastically. And probably we should have a better coupling between metrics and their usage. So if you define a metric, make sure that it is used at least somewhere. You know, in the Go code, for example, if you define a variable and you don't use it, your program will not compile. So maybe we should do that as well. And yeah, I ask everyone to think about this when you have a few minutes. Maybe you come up with better ideas. Also, some of this topic was discussed with Dotan on this, and that's the article with the same ideas, and there is an interview with CTO of Victoriometrics regarding the same problem, so feel free to check it. Yeah, that's all. Questions?
Do we have any questions?
You talked about removing metrics as a good thing, and in general, I agree with you. I guess there is always a kind of cultural blocker to it that I've seen, which is you have an incident maybe many years ago, and a metric proved useful, and it's forevermore being included maybe on a dashboard. No one really looks at it. Mm-hmm. But the idea of removing it from people is a very scary one, right? So even though we might know that actually we've got so many metrics now that no one can see that as useful, people still cling to that metric because there was that incident back when they used it. Is that something you've seen? Do you have any ideas, when we talk about removing metrics, how do we overcome that?
Yeah, I'm not saying that metrics need to be removed. I'm saying that you need to think carefully before you add a new metric. So basically, maybe if one metric proved itself worthy, maybe when you need to describe a new process inside your application, maybe you can contribute this value to this existing metric. Maybe you can repurpose it. Or take a look at the SLI purpose, why people have SLIs and SLO, because it's far more easy to hide the complexity of application when you express it via one or two of metrics, which are basically saying everything is good or everything is not. So this is like a good way to keep the cardinality under control. You have like a limited list of metrics describing your process, and you need to think carefully when you add another one, because it's very easy to add 1,000 of new metrics, and developers usually do that because okay, Prometheus can handle it or another solution can handle it. That's okay, but this is like a snowball. The volume increases with time, as you've seen, and at some point, existing solutions just can't keep up with that.
Thank you.
And I would add to that maybe of the benefits that you look at, you give the example. Maybe I would add to that you gave the good example that someone actually used that and incorporated in dashboards. But what he showed, and I can testify, I see the same or roughly the same numbers as well, is that 75% or even more of the metrics aren't used in dashboards, aren't used in alerts and rules and anything. So these are the no-brainer ones to at least consider removing. So what you described, at some point in the past, it was used and it was left in a dashboard or a rule, that's okay, but that's still only 25% of the metrics. That's amazing, the mind-blowing part of the stats, that 3/4 of the metrics aren't being put to use in any rule, any dashboard, any alert, anything.
Thank you. Do we have any other questions?
Are you familiar? Thank you for the talk. It's interesting, and I'm curious because this is a challenge for the entire community. And the question is, as far as you know, is there a concerted effort to open it up for a community-wide discussion on standardizing on the? I know that different vendors try to tackle it locally. You showed it also on the talk. But is there a concerted effort to bring them all together around one table to formalize some best practices or recommendations or guidelines to streamline this?
Yeah, I'm not aware of it. I'm not aware of such global initiatives to do that, and that's one of the reasons why I'm giving this talk, just to pay more attention to this problem. Because actually for us, for Victrometrics as a time series database, which is selling point is that it is high performant, we actually benefit from the huge amount of metrics. And if Prometheus can't keep up with that, people start using Victrometrics. So for us, it's like a good thing. But as an engineer, I am pretty concerned with this increase in metric volume. And I'm seeing like every day how people just store everything they have and they don't use it, and they just add more and more and more hardware until something breaks, right? And this is a wrong path, I think.
Thank you.
Right. Okay, thank you all.
You guys ready? Okay. All right, next up we have Gustavo Carvalho and Lucas, who also delivered a really cool talk upstairs yesterday. Yeah. So they will be talking about versioning CRDs. We'll have this half-an-hour session now. We'll take a few questions after, but I also want to bring to your attention so you can plan this better for later. We are going to have a series of lightning talks after that. And yeah, this is supposed to be the most fun segment of Rejekts as we've seen over the years and with several iterations. So it will be like 5 minutes and timed talks. I don't know if you've seen the roster in the whiteboard as well. We've just kept some space for spontaneity and for anyone to sign up if they're interested in giving like 5-minute talks. But yeah, just letting you know that that's what's coming right after this. We'll have a short 10-minute break, and then we'll have the series of lightning talks. All right then, so take it away, Lucas and Gustavo.
Thank you. Thank you for the introduction. So yeah, we'll be talking about version and CRDs, the good, the bad, and the ugly. The presenter is off. Okay, so my name is Lucas. I'm an engineer at Red Hat. You can find me at those handles. Gustavo is engineer at Container Solutions, and please talk to us, reach us out for any questions and talking about operators and anything on Kubernetes. So this talk is not about external secrets, even though we use a lot of examples from it, external secrets operator. It will be interesting to people that are trying to develop Kubernetes controllers or operators to run inside of Kubernetes, and especially if you're dealing with like upgrading API versions. But in any case, reach out to us to talk about external secrets. We wouldn't mind, of course. Yeah, why we are doing this talk. So we wanted to provide a good experience, like when upgrading our project to have new features, and then because of that having new API changes. And when doing this type of API versioning and like trying to change things, we like encountered like poor support in Kubernetes, like mostly in documentation, and like having difficulty finding other examples of doing that like properly, like giving usability to users when they have a hard or like a breaking change, a hard upgrade path. So yeah, the idea to give this talk is to have this being open on the internet, and people can find this talk and see the difficulties that we have and the things that we did like to overcome these difficulties. So what we mean by API versioning? So versioning in general is a pretty like controversial topic, and sometimes it's hard to keep up, like with Windows going from 95 to 98 and then 2000 and XP, Star Wars going backwards and forwards and all that. But like for us, we are focusing not on the software versioning. So when we're thinking about Kubernetes, we're not thinking about 126, 127, and all that. We're thinking about API versioning, so internal API versioning. And if you applied some custom resources or even Kubernetes resources, you're probably familiar with this like concept and this standard. So V something alpha something, V1 alpha 1, V1 beta 1, and all that. The idea is that on alpha versions, it's kind of free for all. The changes can be breaking changes. The idea is that you want to get things fast, so you can like get feedback, and while you're considering yourself not stable, you take advantage of that to make changes fast. The idea that when you go to beta 1 or beta versions in general, you try to avoid breaking changes, but you can still have them, but it's better to like have a bit more comprehensive instructions for people to upgrade them to new versions. And the idea is that when you go to like stable versions, like actual versions, V1, V2, V3, the idea is that inside a version, you don't have that many changes, no changes, ideally, and things are stable, and people can consider that, okay, this manifest that I'm applying will always work. Okay, so why do we say that this is hard? So when you're changing APIs and like fields are optional, like it's optional fields, it's okay, mostly okay to change things there, but when it's a mandatory field, and it's like a big structured field, like in this example, you have like authenticating this field, it's the key, and then yes, please is the value, and you're changing like to, okay, the key here will have an object inside with this key value, and then this is a breaking change. This will make life hard for users and for developers because they have to deal with support and all that.
So, what do we mean about what we want to do here? Basically, we want to provide some examples, some real-life examples that we faced while on external secrets operator. What are the paths that you can do when you need to introduce that breaking change on your project? Because our crystal balls are not perfect yet, so we cannot really foresee how our software is going to be used.
Guys, can you shut up, please? Sorry for...
Thank you.
Thank you.
I cannot go with this presentation without talking about the very first use case, which is how to do a breaking change, how to provide a good path for your users. You don't. Sometimes you don't really need to. The case that we have here on ESO itself, recently we have released this push secret CRD, very cool feature. If you don't know about it, talk to us later. But when we released it with a bug. The actual spec that was here was a little bit different than the one that we designed for. It was basically here was an array, and we really wanted to only have a key value pair here. When we caught that, we thought, well, this is a bug. We need to fix this bug. When we did that, we didn't really thought about providing a path for users to not break their setup because this was a bug. We just documented that as a bug, put on the release note, this has happened, sorry, please provide it. We did this fast, though. So how does it work? Well, here we are thinking, I have this very missing important feature in my project. So we go from V1 alpha 1, create a V1 alpha 2, break things, do this over and over and over again until we completely get our domain, until we have everything complete. When we are onto this stage, then we are, okay, good, done. I can now move my V1 alpha onto beta and onto stable GA, generally available. My job here is done. My operator is complete. That's very nice until our fancy user here realizes that this project is not stable at all. So he's just like, cool, very cool, nice features. I just wanted something that didn't break my production setup. I would just go use that other project just because it's easier to manage, easier to deploy. This here is actually the problem when we don't provide an upgrade path. And by don't providing an upgrade path here, what I really mean is documentation only. Most projects that we see on CNCF only have documentations when they provide breaking changes. There is a reason for that. We first started with this. We thought, okay, that's not good. Let's find other ways. Before showing other ways, pros of that setup. Super easy to manage. No extra code for the whole things that you are adding. You only have the documentation. You don't need to bump it away from V1 Alpha 1, just like in our case in external secrets. We just replaced it. And sometimes, like for bug fixes, it actually makes sense. And as we already told, some cons here. It really limits the possibility of us really saying that our project is using a beta version. It's not really future-proof. Just like I said, it's very hard to get the domain design of our controller from the very first day. And you do get the low credibility with any enterprise users. If you're thinking about open source software health, this is a very, very big issue. How can we do it differently? Second option, scripts. How does scripts work? Basically, what we did on ESO, a little bit of context before going there, some history. ESO used to be called Kubernetes External Secrets, a project that was designed on JavaScript, using a JavaScript operator based on the Kubernetes JavaScript client. That client got deprecated. So what we needed to do was to switch from the JavaScript implementation into Golang, because the whole cloud native space kind of supports it better. When we did that, it was a whole community effort. We also kind of figured out that our domain was not properly right. So we went on to breaking things. Instead of having authentication things here, we decided to have a proper CRD for authentication and another one for the actual manifest. How do we do scripts? The logic is that we're going to have a given group for the first version that we have. That is the group that we want to deprecate. We are going to create a new group here and provide a script for our users to convert. After that script is there, we can safely deprecate the old one and do the life cycle of the new one, however we want. This life cycle here is a life cycle. So that one, the new group, you intend to promote to V1, Beta 1, to whatever, to keep adding features, etc. And that's the problem. Your user here kind of caught on the train later. 5 years after you did that script here, when you're already on V3, V4, they want to upgrade it. So they're starting to wonder, how can I actually go from this one here up to this one here? That is only possible if you actually maintain that script over and over again for every new version. You already get the pain, right? So obviously, pros. It is very good to have the all-in capacity for any customization need that you want. For ESO, it was kind of the only way around when we were doing that transaction. Your use cases can be scaled out by the community as long as you also open source the tool that does the conversion. And multiple controllers are supported, so literally different code bases can be made compatible. Very cool feature. Cons. That's not a typo. All-in is both a pro and a con. Having the extra code to manage the extra complexity, the extra issues that comes with it, is not really for free, and it's not for a feature. You're just providing an upgrade path, and you have to deal with a lot of stuff. This only really works if every new feature that you have, you backport to the CLI tool. Otherwise, you're going to have the issue that we mentioned. And from experience, doing a live migration, which is being on one project in production and going to the other project, can be tricky for many different reasons. One only to mention, ownership of your resources. So you need to be careful with that. Both of these two options here don't use any Kubernetes infrastructure at all. It's basically outside of Kubernetes, trying to handle with migrations. Before that, this is the link of the open source tool that we had. If you want to check it out, you can also see that the community adherence for that was pretty low, so it happens. The only way to do that Kubernetes native is by this bit here called conversion webhooks. For those that are not aware, when you define a CRD, you can define the conversion mechanism. Kubernetes supports two. One of them, the conversion webhook, you configure it the way you want. The other one is called none. That's right, Kubernetes provides two ways, either none of it or full-fledged customized. That's really something that can be pain. An example of how we use that to external secrets is the very basic example that Lucas gave. We had a data from object in our V1 Alpha 1. We wanted to add a second type of data from for our users. So we got the old one and wanted to wrap into a field. So the old one is now under data from extract instead of simply data from, just to add another way of people to get information from. That works marvelously in theory. In theory, all you need to do on your CRD, you tell Kubernetes, talk to a webhook. Super marvelous. What's the issue here? The custom resource definition defines how our application works. On that bit, we are now starting to add environment-dependent information. The service that the webhook is using, where the namespace where the webhook is installed, what certificates are the webhook using. Certificates. We also need to handle certificates. Your user is going to be very, very frustrated when they find out that this happens. Even worse, this is only useful for any user that is here. Any user that is here will be just pissed that they need to install a whole webhook just to handle conversion. And it becomes very tricky because now you need to address all of this type of things just to add this little temporary conversion. It does have a nice pro feature. Migrations are live, handled by Kubernetes. So literally, your user, when they are migrating versions, won't feel it unless there are some, outages while the migration is happening. It's also cool that you only have one source of truth, so everything is embedded in the same code base. You don't need to handle type conversion like you would need to do when using scripts. It is well integrated with the code base. However, it's very complex to set up certificates. If you have an outage, you now have to deal with etcd version migration, just like any other version upgrade. This would work for Kubernetes as well. This is dangerous if you have an outage. You may need to template your CRD definitions. This may here is actually you will need to. So if you have Helm users, forget about them. They will be complaining forever. They do complain with us. And this one here that I didn't talk yet, cluster networking starts to become important. This is true for if you already are using a validating or a mutating webhook. If you are not, it means that now you will start to have issues like, this project doesn't work on my EKS version 1.8.3 Fargate because the port's not right. And it's true. Or this project doesn't work on my GKE Calico-enabled cluster. And it's true. There you need to enable a host network. If you're really looking at for the users, like we said we're doing, you now need to allocate capacity just to answer them. You need to look to their specific environment. So you also need to be aware of that. Note that this is the only Kubernetes available way of doing conversions. When we did that kind of in the order, first one, second one, third one. When we did the third one, it was a little bit last year, close to KubeCon Valencia. I went to KubeCon Valencia, started talking to a lot of CNCF projects. How did they do that? How did they use conversion webhooks? They said to me, well, we don't. Or, well, we use scripts. And I was like, okay, why didn't I find this information before? that was kind of why we decided to actually try to do this talk, because community needs to know somehow that they don't need to spend a whole year, get a ticket to KubeCon, talk to people to figure out that, no, this is just hard.
Yeah, this slide is basically showing a silver bullet being shot at a swarm of bees. So not even a silver bullet can kill a swarm of bees. The saying that a silver bullet solves everything. And it all comes down to like requirements and understanding like the impact that you want to have and the effort that you want to put in. And yeah, so we're starting to think, how could this look like a little bit better from the Kubernetes side? Because doing this talk and all the experience that we had, it all comes down to like, it's too hard to deal with Kubernetes API versioning and API conversion. And as Gustavo said, it's a new thing that you need to put on customer clusters. So it's a new certificate manager. You need or to tell them how to use a cert manager somehow, or provide a certificate manager yourself and code a webhook from scratch and deploy that to the customer cluster. And it's the only way to do conversion like natively. And the CRD definition, as Gustavo said, carries everything. So context-specific information, the namespace where the webhook is running, everything. And we thought about this and, okay, maybe separating the conversion-specific things from the custom resource-specific things would help improve this, but it's not that simple. And then we thought about something even more complicated, but it would give a lot of quality of life value, like having a dedicated manifest for like custom conversion definition. In this manifest, we will define, okay, 2 versions and how to convert from one version to the other. And this would be a bit easier, making Kubernetes controllers or making operators would look like something that you could deliver and then make users have a actual upgrade path that makes it usable. But we understand that this is a big ask and maybe a huge Kubernetes enhancement proposal. Getting something like this into Kubernetes would take, I don't know, years. And maybe this also doesn't make sense because it was like 2 people thinking, and then when you open to the community, maybe you can see a lot of problems that could arise with this. But yeah, it's just something that we could think about. And then, like, since we don't have that, we can think about everything that we already talked in this talk. So the first thing, you need to try to provide a clean path for upgrades, avoiding breaking chains. But if you can't, and well, you won't most of the time, especially if you are like in the beginning on alpha, try to introduce breaking changes as fast as you can, like right away. If you get a version out, you notice something wrong, try to change that as fast as you can and take advantage of being in alpha if you are. This will save you the trouble of handling API versioning and conversioning later on. And the thing about like thinking about clean upgrade paths, it's also at the design time. When you're thinking about your API, you're designing your CRD, you're creating a discussion, you're creating an issue, a pull request, you're getting everyone to contribute. Okay, this field won't work because this feature in the future will have this and this and that. We'll need more fields. We need it to be an array or maybe an object. And like these discussions will save you time in the future. If you need to introduce a breaking change later on, maybe after you are on beta V1, beta 1, or something like that, if you're trying to avoid like complicated things, maybe you want to go for scripts. Maybe you just want to say, okay, you're like changing domains and use this script that you provide, or maybe go through this documentation and you can like go from one version to the other. But then you have to think about using conversion webhook when you're thinking about usability, and you're already using maybe some validation webhooks on your cluster, you're already managing certificates, you're like familiar with that, and you're providing a project, maybe it's in the internal operator inside your company, then you can go with like managing and instructing how to manage certificates and writing a webhook from scratch. Yeah, and the idea is like, don't do this alone. we kind of did this alone because we looked for other projects, like how they managed conversion from going from one API version to the other, and we noticed that they just don't. They do breaking changes. They say, okay, this is our release notes, this is the documentation, if we have it, and deal with it. And yeah, doing this talk was like, okay, we need this to get online and people to start discussing conversion like in a way that is actually usable by people. You can find us on Kubernetes Slack, on external secrets or external secrets-dev. And yeah, please talk to us. And yeah, let's make this better. Questions? Thank you. The microphone. Yeah.
Firstly, great talk. I super sympathize. I should say the reason why I super sympathize. I'm Nick Young. I'm one of the maintainers for Gateway API. We are building like a Kubernetes upstream API using CRDs. We have all of the problems that you have discussed, plus more. And a couple of questions I wanted to ask you was, when you were looking for this, did you ever get referred to the API conventions doc or the API changes doc?
Yeah.
You did? Okay, good. Because those are the Bible, right? Like those are all of the experience that the upstream core stuff has had that can really help. It is hard because they are both like 10,000 word documents that really need better summarizing. It's been a wish list of mine to do it for a while. So it's not much of a question, I'm sorry. But like, what I wanted to say was for everyone else who has these sort of questions, there are other people who are doing this. I am Young Nick on Kubernetes Slack. Please feel free to reach out to me, any of you guys, anyone else who's watching this recording. I'm always willing to talk to people about CRD design. I've had to do it a lot too, so yeah.
That's perfect. Yeah. Thank you. Yeah, let's.
Sorry to not really ask a question.
Let me move the microphone.
Thanks a lot for actually putting yourself out there as well. It's like, we do need it.
So you gave probably 3 options. 1 is don't do anything. 2 was you have to use bash scripts, and 3 was the conversion webhook. But if you look at the source code of Minio, they have the same problem with their internal schema for their config file. And what they simply do when they load up is they look at what's present and they automatically upgrade and write back. Why wouldn't you just do that in your operator?
That's actually a valid option. Even if you look at Kida, they actually do something similar. They have external providers that they maintain as a single config map. Back at the time, we didn't want to introduce the config map because we had from one side a very forced config block. The other side, we wanted to keep things on a Golang level more structured. So it would be a breaking change if we just opened for a config map like Kira did. That's why we did not consider. It is valid, but then you start to need to have some thinking about runtime validation. The config map will be just a map string. So
sorry, just to interrupt. I'm not suggesting you use a config map. If you load up, like we did this for Kubernetes when they changed the ingress, right? So you have either the one that was in the beta namespace or the networking v1. You can load up your operator, external secrets operator, scan for objects for the old type, then either delete them and recreate them or create the new ones and delete the old ones. Why wouldn't you consider that as an option?
So no conversion, deleting, and just replacing.
Yeah, whatever way you want to do it.
But then you're considering different groups, right? And like going from inside a group and going for another version, just upgrading.
Well, you showed that in your breaking changes, didn't you? Like, we'll have alpha v1 and alpha v2, and you just got to move. So you could do that through your operator, and you've got the knowledge of how to upgrade as well.
That
rather than using it for Kubernetes conversion webhook, you build the conversion process into the controller.
Yeah, and that that's called a database migration. It's been around for 50 years. You know,
if we
don't
look
need to
at
reinvent the wheel.
If we look at the Kube Builder support for it, which is where external secrets is based, is a little bit tricky to ask for Kube Builder to maintain 2 API versions of the same group. So we would need to have to split them apart in 2 groups and have 2 controllers.
Yeah, that's custom code, yeah.
Which is kind of mixed between scripts, right? I mean, the script is not running on your cluster. What we're basically doing is making the script into the controller, sort of. We really didn't want to do that because we had a very bad experience with scripts. So we decided when we needed to face the problem again to try something native with the CRD versioning, which honestly I kind of regret it, to be fairly honest.
So you could still do it by, in the new version, you just watch and operate only on the new objects, but then every time every time you just have a loop that kind of watch for old objects and converts them to the new one. Anyways, yeah.
The issue with that is that on the CRD level, when we think about versions on the same group, you need to tell them which one is going to be stored on etcd, right? And only one can be stored.
Yes.
Which means that you expect a given controller to only be working for a given moment in time, and that controller will try to update things, right?
Yeah. So what about GitOps in general?
So I mean, I would say that the approach you're talking about does work. I think the biggest problem.
Thanks.
Thank you.
Yeah. The approach you're talking about with using a built-in controller thing, it does work, but the biggest problem that you're going to have is what you said, is that you're going to duplicate the types, and you're going to have to maintain the duplicated types, and it works best when your types are relatively similar. If you've made a really big breaking change between API versions, totally, right, and it sucks, right? And so I mean, for Gateway API, between V1 Alpha 1 and V1 Alpha 2, we completely changed the way that some stuff worked, and it requires a person to perform the conversion. Sometimes the changes that you are making are going to be big enough, they require a person to perform the conversion because it needs to be semantically reinterpreted. And in that case, you can't do automated migration, right? And you are better off saying to people, no, this is a breaking change, a person has to do it, we'll give you a tool to make it easier or something like that. That happens also with, say, conversion from ingress to Gateway API, is another example, right? There is a semantic change between the two things, so there's no point trying to make it automatic. You need people to do it. And so I think it's a really good point that you've called out, that the risk with the script sort of automated model is that the number of changes you can make are limited, and and sort of the scope of the changes that can be supported for that code thing are limited. And then, of course, as you called out again, then you have to maintain that for. Let's be charitable and say the foreseeable future rather than forever, but it's all, to be real, it's forever, right? That code has to live forever for some given value of forever, and that sucks, right? Having to maintain that forever sucks. So I think your points are really fair, but I do think your point about it is possible to do it in controller, and that's a fourth option, is fair. But it does, there are trade-offs there too, just like with everything else.
Certificates, then it's basically the same thing about that. About those issues.
The main reason that we wanted to show these 3 options is just because are the 3 options that we ended up using due to very different reasons. But just like we put here, we do know this is very opinion-based, and this is just the path that we took. And I actually appreciate, because here we have so many people that are way more knowledgeable.
Yeah, and it's interesting that we have 3 people that have experience in this, and when we were actually Gustavo were on previous KubeCon, he talked to a lot of projects and then just said, okay, just don't do that.
I know, at least we have all 3 done very big migrations. Anyways, did you consider using the certificates API for getting the certificates?
I think we're probably running close. I think we're already running out of time.
Sorry to bug up the mic, everybody. But what I actually suggest is, please, anyone who's interested in this, reach out to me on Kubernetes Slack. I would actually like to try. I think that it might even be worth us trying to start up a working group around solving this problem a little better. It's going to be a SIG API machinery thing, which especially for folk who haven't talked to Jordan or Lavalamp. Yeah, but I mean, I think that there's enough things now using CRDs that it's probably going to be worth having another crack. So
totally agree.
Yeah. So, but thank you very much for this talk, guys. Really great. I'm going to be telling everybody to check it out on YouTube and stuff. So
thank you so much.
Yeah.
Thanks.
Give us some applause.
Series of 5-minute talks. Yeah.
31. I'm on? Hey, if you can pull anybody else who's out there into here, that would be great. Anybody who is doing a lightning talk, please be up here. I hope everybody who is doing a lightning talk is in the room. Are you folks all doing lightning talks? Good. Okay. So we have, is that the number? 1, 2, 3, 4? Are all allocated? Oh, this one? That's you? This one? Okay. We know this. Corey? Okay. This one? No. Liar. Okay, not that one yet. Okay, this one? Oh, that's Andy. Okay. Here? Docker files are dead? No? This one? Okay, so we're missing 2. Okay, good, we got Corey. Good, we got one of those. So we're missing the Docker files one, I think, right? Nobody's here for that one. Okay. Good. Then I will put a note here. Okay, hi everybody, thank you for coming. We're going to start the lightning round here. These are 5-minute talks, and a couple of these were in the schedule. Most of them are actually signed up on the board here, and we are going to go through them as everybody gets 5 minutes. We will be using a timer for that. When your 5 minutes is up, you'll be pulled off stage. Hopefully you come voluntarily, but force will be applied if needed. And so... yeah, the speaker can introduce themselves, and because we want to go very fast. And so you're the first speaker, right, Hannah? Good. I'm going to give the mic to you. And your time will start when your slides, if you have slides, actually show up. So don't worry too much. We're not taking time away for there. We might go over a little bit, but I don't think so. Okay. No, you're good.
Okay. Job done. Hi everyone, my name is Hannah, and today I'm here to talk about 5 product management practices that I think every platform team needs to know. But first, why am I talking about this? I'm talking about this because over the past 5 years, I've seen far too many teams struggle and fail to launch development platforms on Kubernetes. The worst of these platforms were burning through time, burning through money, and burning out their engineers. Having seen what works and what doesn't work in the real world, I've come to believe that treating your platform as a product and adopting product management practices is a key to success for scaling a platform, a cloud-native platform, that delivers value for the organization you work for and that delights its users. You do not need to have a dedicated product manager or have product manager in your job title to adopt some of these practices. So I'm going to share it with you today in the hope that you take a few ideas home that you can implement within your own teams. Too many platform engineers can't tell me why they're building their platform. So my first piece of advice today is to make sure that you understand what you're trying to achieve. What is the reason to build this platform? Understanding the why will give you focus, and it will help you prioritize what to build. My second piece of advice is to go and find your users. When you find them, talk to them. I know, controversial. Get to know them, get to understand their problems, frustrations, and pain points, and then set about solving them with the service that you provide, with the platform that you provide. Build empathy for the challenges of their role and uncover new opportunities to make their lives easier, not harder. I recommend you do a little bit of reading about how to conduct a good user interview when you go out and you talk to these people. Start by asking open questions, not leading questions. Try not to bring in your assumptions and solutions into the discussion. Try and just seek to understand the problem better. This helps us avoid field of dreams engineering. If you build it, they will come. When we create solutions and then go seeking a problem to solve, that is a sure way to waste everybody's time. Which leads me on to my next piece of advice, which is that time is money. It's as true today as it was in 1748, which is when this quote comes from. My third piece of advice is about being much more intentional about how we spend our time and whether or not we build ourselves or buy the solutions to the problems that we're aiming to solve. Because the IKEA effect is a thing. The IKEA effect is a cognitive bias in which people put disproportionately high value on things that they partially created themselves. This just doesn't apply to just flat pack furniture in your Billy bookcase. It also includes anything you've built in-house, any custom solutions you built, or open source projects that you've contributed to. You'll need to fight the natural urge to place higher value on those things that you've helped to build to make the right decisions for your team. We often ignore the cost of ongoing maintenance, that we ignore the risk of creating knowledge silos, and we ignore the time it will take to onboard new people into your team if you've developed a custom solution in-house. In platform engineering, we're kind of lucky that we have a lot of empathy with our users just naturally, because they're also engineers and they share a lot of similar needs to us. If you think back to the last time you had to adopt a new technology or product, what are the things that made it a great experience or an absolute nightmare? I'll bet it had something to do with the documentation and education that came alongside it. It is part of the user experience, and you need to invest time in these things. You don't have to start with a blank sheet of paper either. You can curate the best available public content, the stuff that's available online already, and then you can augment that recommended public content with your own specific recommendations that are relevant to your platform and your organization. But whatever you do, don't forget this part of the process. Poor documentation can cause your users pain, so go and ask them for feedback on that whole experience. So as I come to the end of my talk, the final piece of advice I have is to now get out of the goddamn way. You've understood your users' needs and you've delivered a solution that works for them. You've documented how to use it. Now you need to make sure that you are not the bottleneck. Humans do not scale, so you need to drive towards a self-service model where people can get what they need without talking to you. Imagine if you had to talk to someone at your cloud provider to get a new VM or a new cluster provisions. You would just not use that provider. It wouldn't work, and that's what you're doing to your users, your internal users, if you're putting manual processes and human interaction in the way of getting what they need. So get out of the goddamn way and make your platform self-service. So I'm going to wrap up with a quick summary of the 5 product management practices I recommend for building a successful platform. Understand why you're building the platform first and foremost, and then get to know your users, build empathy from them, and try and solve their problems. Then beware of the IKEA effect. Be really intentional about what you build or buy, because your time is valuable. Use documentation and education to make sure you smooth the process for your users who are going to adopt the platform. And then finally, get out of the way and drive towards self-service. Thank you for... I hope you all have a fabulous week at KubeCon.
Thank you. Okay, next. Good. Then I will give it to you. Do you need slides or anything?
My slides are controlled from there.
Okay, good.
Can I have the slides up? Thank you. And my time starts now. Thank you. Hi, I'm here to talk about how you can do fine-grained authorization with open source. Who am I? I'm Abel Matthew. I'm a software developer. I am very passionate about community and writing. I'm involved in communities like Author Ambassador Program, Google Cloud Champion Innovators, and yeah, that's pretty much about me. So let's start with the scenario to understand what we are trying to do over here. We all work for organizations, and our orgs want to manage budgets. How do we do that when, let's say, an org has multiple nested departments? To give context, a small example would be something similar to this, wherein your organization has multiple divisions like product, legal, finance. Product underneath may have product engineering, product design, and product engineering underneath may have product engineering Bangalore, Amsterdam. To give context, at least in my firm, this nesting is at least 7 levels deep, and a lot of companies have multiple nested departments like this. What we want to do over here is to manage budget for departments like engineering Bangalore, and the people who manage the budget are people who manage multiple departments at once. We want to do access control so that they have access to just the resources they want to, and not to someone else's financials. It's possible to write it using our own code, but what we want to leverage here is a tool which is able to do it out of the box. That's where OpenFGA comes. OpenFGA is a CNCF sandbox project at the moment, which is based on Google Zanzibar research paper on which the Google's authorization model is completely built upon. So The idea is you have relation to an object, and if you're related to the object, you have access to the object. So in the above context, the way it would work, to give very small summary, is that the node that I'm mentioning here are the divisions. So a node can have a manager, a relation manager, or a node can have a parent, which could be a node itself. So a department can have a department as a parent, very similar to how we saw in the diagram. So if you see line 6, what I'm trying to say here is that a manager can be assigned at department level, or it can be managed from the parent level itself. And this actually is the DSL language accepted by OpenFGA, which can be directly converted to a JSON, which the SDK supports. So this is not just pseudocode. The playground supports converting this directly to JSON, which is easily understandable. So using just this much, and assuming this hierarchy, which I showed previously, which is product, underneath has product engineering, and which underneath has product engineering Bangalore. And let's say we have budget 2023 for a particular department. This is all the data that we have. And Jane is a manager for, let's say, the department product. Using this, so given Jane is manager for product, and underneath product comes product engineering, and underneath engineering comes product engineering Bangalore, if I'm Jane, I would have access to budget 2023. So with using just this much, without writing any additional code whatsoever, I'm able to understand that the relation between if user Jane is a manager for the department, or if user Jane has access to the budget, can be easily managed. So using just these entities, I'm able to know this without actually having to write additional code. If a new department comes underneath product, I don't need to configure additional accesses. If a department moves, let's say, from engineering to, let's say, design, for whatsoever reasons, which happens during reorganizations, I do not need to rewrite large chunks of code. All I need to modify is very small bits in the authorization model. And this is exactly what OpenFGA does. To give context, which is for later, if you want to add, let's say, a location constraint, wherein I work in a department which is in, let's say, in Bangalore, I want to access just budgets of Bangalore. The only thing that I would need to do is just few lines of change in the actual authorization model, which would look like the highlighted parts, wherein a location can have employees, and I have defined that a manager requires to be an employee from the location. That's all that is required. Once I do this, even if I've got access to, let's say, the node product, I will not be able to manage it if the location does not match. All of this is done as part of the authorization model, and this ensures that you're able to scale it independently. And this reflection, once you make changes to this authorization model, is immediate. So that's pretty much about the project. It's a CNCF sandbox project. If you want to meet the amazing developers who maintain it, they would be at the KubeCon venue. There is a booth there. Feel free to connect with them. And that's about me. Feel free to connect with me if you want the slides. You can DM me. And that's pretty much about me. Thank you. Have a fun week.
Okay. Next. Yeah. Let's see if you hooked up there. Here. There you go. Be positive. It will work.
It will work. It should work.
Yeah, other way. No, in the middle. Yeah, in the middle. Other way.
It'll in the middle, other way.
Yeah.
It's not working.
There you go.
Oh, cool. Cool. Thanks. Hi, I appreciate the chance to talk today about reducing the toil and risks of multi-cluster Kubernetes version upgrade using Alodal Nova and just-in-time clusters. I'm Ann Holler. So Alodal Nova simplifies the management and usage of multiple Kubernetes workload clusters. The way it does this is by introducing a single Kubernetes control plane cluster that automatically schedules Kubernetes objects onto a set of workload clusters as per a set of placement policies. Nova has recently introduced an optional feature called just-in-time cloud workload clusters. Nova just-in-time clusters put cloud clusters that have been idle for a specified amount of time into standby state. And standby means either delete them from the cloud or at least reduce their resources to only the cloud hidden control plane. Nova just-in-time exits the clusters from standby, restoring the resources to the clusters when Nova schedules objects to those clusters. And Nova JIT can optionally clone, create additional cloud workload clusters if they're needed to satisfy a placement policy. So let's look at how this technology can reduce the toil and risk of multi-cluster Kubernetes version upgrade. This will be a simple use case, and the associated YAML files are at this link. So basically, we'll start with just one Kubernetes control plane, which is the Nova control plane, and then 2 Kubernetes clusters, one for dev, for our application of interest, and one for prod for our application of interest. So we see that. We see our control plane for Nova. We see the policies coming in and the placement requests coming in. So this setup is hosted on 3 EKS clusters. So the Nova CP cluster hosts the Nova control plane cluster, and then the Nova work dev is the workload cluster that's running our workload of interest. Let's say that's the guestbook app, and the Nova work prod is a cluster that's hosting the other copy of our app of interest, which is the prod version of it. And so this is the 3 clusters at EKS, and you can see that the 2 workload clusters are currently running version 1.24 of Kubernetes. And if you look at this cluster from the standpoint of the Nova control plane, it knows that there's 2 workload clusters. It knows that they're at version 1.24, and they're running, they're not in standby because they're busy. So what is the low-risk, low-toil way of upgrading those clusters? Let's start with the dev cluster. It's basically a 3-step process. The operator requests that Nova control plane schedule via policy a dummy pod to a non-existent cluster. And so Nova clone creates that cluster. Then the operator requests an upgrade of that cluster to the new version of Kubernetes that they want. And this upgrade is straightforward and low risk because that cluster is not running anything interesting from the standpoint of the user. And then the 3rd step is the user changes the Nova policy that scheduled that workload of interest to the original cluster to schedule it on the new cluster. And so when this is done, when the policy is changed, Nova automatically reschedules all the associated objects from that are governed by that policy to the new cluster. And now the operator can check and make sure that the dev workloads are running fine on that new cluster. If they're not, it's easy for the operator to change that policy again to kind of roll back by sending the workloads back to the cluster that wasn't upgraded. But if all goes well, we're done with the dev cluster upgrade. And this is actual, execution of these 3 steps. So at the top, you see the original 2 clusters. You see the policy that deployed the dummy pod. You see the upgrade. So you see the new cluster. And at the bottom, you see that the new cluster that's running version 1.25 is now ready. It's not idle. It's running the dev clusters. And the other cluster at 1.24 is idle. So rinse and repeat, do the same thing for your prod cluster. You hope it works because it worked fine for dev, but sometimes things happen. And so finally you get to this post-upgrade state where you have the 2 new clusters running 1.25. You have the 2 old clusters running 1.24 in standby state, and they've actually been deleted because this standby state policy was deletion from EKS, and all you have now are the 2 active 1.25 clusters. So that's it. I really appreciate getting a chance to talk about this, and learn more at our website, and thanks a lot.
Thank you. All right, next up. Thank you, stayed right under 5 minutes, perfect. Oops, that's funny. How is that happening? There's some caching somewhere. Let's hope it works. Let's go. It's going to come. Always takes those. There you go. Okay. So, time starts. Yeah, thanks.
Welcome, everyone. My name is Koray. I work for KubeCon, and I also appreciate the chance to talk today. So last month in Hamburg, we had Container Day Security, and as a company, we were supposed to do a workshop. And for that workshop, we decided to do a capture the flag session with some attendees. And yeah, I did it for the first time, and I didn't want to use some hacking tools to get some secrets or the data out of the Kubernetes clusters. So I was like, okay, let's do some configuration issues, and then people can just access to the cluster. And well, using Kube API server would be too obvious, so I was like, okay, let's use Kubelet. Maybe you already know Kubelet has also an API. So this is a recap. You know, all the control plane stuff talks to Kube API server, which talks to etcd, as well as kubeproxy, Kubelet. They also talk to API server, and your kubectl commands also talk to API server as well. However, for some stuff, the job of Kubelet is to get the pod specs from etcd through Kube API server, but it also provides the functionality of kubectl logs, kubectl port forward, kubectl exec, which are actually coming from your laptop to Kube API server and to the Kubelet, where this API is actually used. You may think that, okay, by default, most of the clusters have, so it by default uses port 10,250. And you may think that by default, yeah, this is closed on the firewalls and everything. But even if you check for the internet, there are some, maybe not too many, but there are some clusters that are open, and the kubelet can be reached there. Fortunately and unfortunately, it doesn't have an API documentation, so it might change over time. So you cannot find actually the documentation of it with the parameters and everything, but you can check the code, and as you see, there are some paths, like endpoints, like a /ran/exec, attach, etc. there. And now I will show you some scary stuff about this. And okay. Thank you. Thank you very much. On GCP, I have one VM which runs a kubeADM cluster, one node kubeADM cluster. If this works, you will see it. Yeah, this is the IP address of it, and here I have a pod which actually uses a secret DB credentials. So there are some users and passwords over it. So I will just export the API IP address here, and then so one of the endpoints here is the running pods. So I will do a curl. Also, another thing is that, of course, for this for the sake of this demonstration, I made some changes to the Kubelet API. Kubelet. So you see, by default, of course, you shouldn't have the anonymous enabled, and also authorization mode should not be always allow. But yeah, for this, you will see it. So if I do this command, it gets me a list of pods that are running on this node, of course, by the Kubelet. And I am actually interested about this volume test pod. As you see, this is the name of the pod on this namespace, and it has this container. And if I do a curl to, I will just copy paste some stuff for easy. Yeah. As you see, right now I'm on the default namespace on this pod, on this container. I ran this ls-l command, which shows me the stuff there. Well, okay, you can try it out, but I know where the secrets are. I can do etc, what was it? etc config secrets, password, for example. Yeah, sorry, secret. So I get the password. There's even more. Sorry, you can even get the container logs. Yeah. For example, these are the etcd logs. So be careful about your kubelet configuration, and make sure that it's all safe and secure. Thank you very much.
Okay, thank you. Next up. Okay. Do you have a USB-C? I think so. Do we have an adapter?
Yeah. You can have this one.
There. Throw all the adapters at him. Always.
Perfect. 6:15, second day, best time for a security puzzle and troubleshooting, right? Yeah, that's usually what happens. You're like, great time to attack. So, we've been moving towards an identity-defined world. We know that, right? Everything is defined based on identity. Not all of us have moved to saying what that identity means. An IP address is an identity. It means less when you get to NATing and other things. But a cryptographic identity, especially a short-lived one with a root of trust, it's pretty valuable, from everything from mutual TLS to code signing to any number of other things. Show of hands, how many of you guys use Cert Manager in your clusters? Okay, most of you guys. Good. So you know it's pretty easy to deal with Cert Manager, get certs signed, deploy them for applications and whatnot. How many of you allow your users to basically sign certs for the apps, saying, hey, here's my cert, sign it? Some of you are shaking your heads, yes. So the thing to keep in mind is this is not that. Cert Manager, tools like this make it super easy. Getting certificates is easy, rotating them is easy. Applications have to do some work. We have a project, open source QuickSec, that makes that easy for applications. But as you start to think about this, ultimately, identities, certificates, rotation, how you use that identity to validate, all depends on trust. And it depends on trust all the way up the chain, right? So if you start to think about this, and you see a manifest like this from a user, I just picked one of my sample manifests, right? Okay, look, I have a cert issuer. I'm signing a certificate, some metadata. Sounds good, right? Anyone see a problem here? What is the trust from the issued cert all the way to the root of trust to others that are now trusting the certificate within your domain? So if someone embeds something like a SPIFFE identity into a subject alternative name, gets a certificate issued, how do you trust it? You have to go back and you have to establish that root of trust. So if those of you who are not familiar with what a SPIFFE ID is, the first part of that SPIFFE ID is a trust domain. And you have to be careful, you have to be aware, especially as a number of your platform architects, how you establish that trust. So if you allow certificates to be issued and you haven't established that there's a trust in place, that is a problem within your domain, right? So just a key point to make there is keep in mind that trust needs to be carefully thought out within your trust domain. And one of the things that makes it easy is, by the way, Cert Manager. I don't know if you folks are familiar. Cert Manager released a new edition called Cert Manager CSI Driver SPIFFE. It is a CSI driver, right? So when your pod starts up, your workload is attested by Cert Manager. There's a daemon set running. And as long as you set up the CSI plugin correctly, in other words, when you set up the CSI plugin and install that using Cert Manager, you're going to associate a trust domain with it. So in other words, your users, your applications don't need to go create the certificates themselves. The platform assigns an identity. And establishing that last mile of trust to the application is important. So that's all I wanted to say. This makes it easy to create trust, but doing this consistently across the cluster is important. CSI Driver SPIFFE does that. We have a separate open source project we just released called QuickSec, which makes it easy to consume certs in an application for things like mutual TLS. And the point I'll make there is now increasingly certs are relevant to the application, not to the gateway, not to a proxy, because you're using identity for any number of things now. So keep that in mind. That's my spiel.
Thank you.
And let me introduce Karthik Prabhakar, Pod 8.
Thanks. I'm up next, right? Yeah, you're up next, Andy. Okay. Whose was this? That's yours. Andy's my boss, so he can use as much time as he wants, okay? Almost. I think you might need to use that other one. Oh, it's coming. Something happened. I think that cable. Oh, there it is. Yeah.
Okay.
Okay. Your time starts now.
Thank you, folks. So I'm Andy Randall. Most of you may know me as an organizer of Rejekts, but I have a day job, and one of those aspects of my day job, I'm product manager working on a project called Flatcar Container Linux, which I have talked about at previous Rejekts. So this is pitched as an update to share kind of where we've come with the project since we last talked. But first of all, for those of you who've not familiar with the concept of a container Linux, really it's quite different from a traditional Linux, which is designed for general purpose workloads. It's really designed specifically as a host OS for running containers, so it has the minimal set of things you need to run containers. It runs on an immutable file system, which has all sorts of maintenance and security advantages. It comes with automatic updates, and it comes with a declarative provisioning model, which is very similar. In the cloud-native world, we use the declarative provisioning for our applications, for our clusters. You can do this for your hosts as well. Where Flatcar came from actually goes back a long way. In fact, all the way back to Chrome OS, Google had a great idea of how do you make desktops really simple and with this immutable and automatic updating capabilities. Core OS turned that into an OS for servers. And then when Core OS was acquired by Red Hat, the team at Kinvolk decided to create Flatcar as a friendly fork of Core OS in case maybe one day the original Core OS might get end of life, which ended up happening pretty quickly. And so Flatcar continued as an independent project compatible with and taking forward the original Core OS container Linux. One of the things that happened a couple of years ago is that original team at Kinvolk got acquired by Microsoft, and around that same time, Microsoft said, look, we really want to drive this to be much more of a community-driven project, and we've really kind of taken it from being something that was very much kind of driven by Kinvolk to really being much more open to embracing the community around Flatcar, which has really grown, as we'll talk about. But one of the main development areas has been simplifying and opening up the build system and making that accessible to new developers, as well as opening up our processes, chat groups, investing in things like monthly office hours, so putting time into those to really share what's happening on the project and allow users to come into the community a lot easier. Key thing up here on the top right, we have submitted Flatcar for consideration by the TOC in CNCF as an incubating project, so we're going through the due diligence there. That all looks positive, but obviously there's a lot that we have to go through, but we're comfortable with the CNCF as a home for Flatcar. I'm very excited to be going through that process. Just to give you some idea of the kind of momentum and velocity around the project, I know when Kinvolk was acquired by Microsoft, there was a lot of concerns about would we continue to develop the project, continue to have the team working on it. I can say we've doubled down on it. We're doing as much work as ever, more work than ever, and we've attracted a lot of contributors from the community who are, and it's not a huge amount of the code, but PRs here for a bit of documentation issues, all of those kind of things there's quite a bit of activity happening on the GitHub. In terms of what's actually been going on in the project, a lot of stuff over the last, probably most of this has been over the last 18 months or so, updating the kernel. We retired some old stuff. We really simplified the SDK, added a LTS capability, a whole bunch of features, as you can see. I'm pretty excited about the ARM64. We've seen a lot of interest in that, particularly from the cloud native community. So really a modern and and continuing project. Big ecosystem, it runs everywhere. We may be Microsoft, but we're not focused on Azure. One's great on Azure as well, but also everywhere else. We see a lot of uptake in the community. You can see the growth here. In terms of our update server, we see over 50,000 end nodes connecting to it, but that's a small estimate of the total number that's actually out there. Going ahead, we've got an active roadmap, a lot of security things. Biggest thing here is introducing SysExt as a way of making FlatCar more extensible and composable, and enabling users to build versions of it more easily with custom sets of packages. And that is it. Thank you very much.
Thank you, Andy. Okay, next. Michelle? Okay.
Let's see how we're going to handle two persons with one mic.
I'm going to give the mic to you.
Yeah? Yeah? Nice.
Yes.
Your time starts now.
Perfect. Hello, everyone. Nice to be here at Cloud Native Rejekts. Super happy to be here and deliver this very improvised lightning talk. Hi, everyone. My name is Andrea. Together with me is Catalin. We're both part of FikaWorks. FikaWorks is a cloud native collective with an open source heart. A lot of nice words over here. Open source, cloud native, collective. What does that mean? What are we trying to create? Well, both Catalin and I, we're both freelancers. We're both freelancers. We don't have the same amount of mustache and beard, but we look quite similar to this guy most of the time. You know, we're happy coding on our machines. Sometimes we do coding, sometimes we do training, sometimes we deliver talks at conferences. But still, there are a couple of problems in being a freelancer. The first one is that working alone really sucks, and working remotely didn't really make it much better, right? The second thing, if you're a freelancer, or if you're as well an employee looking into freelancing, you might have some questions. And the question sometimes is, how do I find clients? How do I make a project proposal when I go in front of a client? How do I, discuss my rates? Do I do a project-based proposal or hourly rate proposals? I guess the question here is there are many questions whenever you get started into freelancing. Bureaucracy being another one of them. Sales, how do you set your rates? How do you do sales again? How do you find other people with you? And in general, what you're looking for is somebody that can do what do I do when X happens? What do I do when my client doesn't pay me on time? What do I do when I don't know how to solve a certain problem? How do I handle this tricky situation with the company I'm working for? And this is why, together with Catalin and some other people, we created FikaWorks. FikaWorks is a collective of freelancers, meaning that we're a group of people, a group of independent freelancers that we are all together in this. So we try to give, we try to keep each one of us independent while being together in this.
Yeah, so how do we operate? So we're an open source community. We basically fork a Git repo from another consultancy in Sweden who kind of like put on the table how to actually run something like this. So we're operating the company like an open source project. We're doing PR for important decisions. We copied from CNCF the concept of SIGs, SIGs for running new initiatives. We're trying to be as well open to other communities. So we have a member that are involved in other communities, with Docker, with CNCF, with Helm. We have people which are ambassadors with Cloud Native Foundation. And we have next to us, we have trying to build as well a community. in the true sense of getting freelancers, which are in the same space as us, to work together with us on bigger projects. So we look like a real consultancy towards other companies. And we're trying to be open about that as well. So in Netherlands, there are 1.3 million freelancers, not only in IT, but in general. So it's a very entrepreneurial country. And in all the countries, this kind of concepts of tech cooperatives is getting traction. So we want to share our model, and if anybody else want to copy it, you can fork it and create a better one. Advantages for companies that want to work with us is that we look like a regular consultancy. We can have more people onboarding on a project. We can create a team of people that know each other and trust each other, and can basically run end-to-end a project like a regular consultancy. So we share some links here. So the DNA is our main repo, which is forked from Crisp, and it's kind of like sharing all the info on how to actually run this. There are other tech communities as well here, so we're going to have another lightning talk a little bit later. There's a Slack channel on CNCF about running tech cooperative and how to actually cooperate on that. So if you want to join us, look at that channel. And there's a quite intensive list of tech cooperatives, so it's not like we're the only ones or we invented it. So if something happens and you're a freelancer, or you'll need to switch to freelancing because, I don't know, you're a big tech and tomorrow you don't know if you're gonna have a job, look here. You're gonna find something in your country, so you can decide if you wanna join maybe or start a new tech cooperative. Thanks.
Thank you. Okay.
Yeah, sorry.
It's okay. We got time for everybody.
I'm going to demo like half of the presentation.
So you need my hands?
Yes.
All right.
Let's see how something happened on my screen.
Just cue me when you need it. Okay.
Yeah.
Your times, or hold on.
Technology is hard.
All right. Time starts now.
Yep. Hello, my name is Christopher, and I'm going to talk about using Tailscale without using Tailscale. So before, I'm going to explain quickly. Tailscale is a mesh VPN, which allows you to kind of get rid of this kind of old-school legacy VPN setup where you have a lot of VPN concentrator jumping between a lot of boxes from you to your target. But by allowing you to set up like secure, lightweight connection to everything, and all of the hard parts are solved for you. And the way this works is by having an open source client that runs on your machine that kind of connects and facilitates everything for you, except it needs to tell your other friends in your network where they're located, and they need to exchange some information like cryptographic keys and all of these things. And this goes via a control server, which is a web service run as a part of the Tailscale SAS product. And a while back, before I joined Tailscale, a friend and I, we made an open source project which kind of like re-implemented this control server and made it open source so everyone can host it for themselves as like for hobbyists and all of these people that do this at home and want to run everything within their own frame, so they don't have to depend on like big corporations or whatnot. But you know, this is fun and all because you run it for yourself, and yeah, that's it's for the self-hosting people among us. So after a bit, one of the cool things that was built on top of Tailscale is that so it was easy for everyone to connect between your nodes, but sometimes you're developing maybe like a tiny application and you want to be able to show it to someone who's not using Tailscale. And then we launched something called Tailscale Funnel, which is a bit like ngrok and other things that allow you to kind of like shoot something out on the internet and let people test it quickly. And quickly after this, someone posted on Hacker News, is it now possible to use Tailscale to serve a Headscale instance onto the internet, so you don't have to use Tailscale, but you do it by using Tailscale?
Quickly, one of my colleagues, she wrote a blog post about, of course you can. So we're going to try to do that quickly now and see how that works out. Okay, so let's see. Oh, okay. So I have a server, and I'm going to set up a headscale instance quickly. I have configured a headscale instance that runs on a domain name that's bound to kind of like how funnel works. You get assigned a random-ish tailnet name, which your friends can reach you at. So this is my, maybe a bit bigger. Okay, so this is the the server URL part here. So I'm gonna start a headscale instance with headscale serve, which now creates a new database and all of these sorts of things. And oh, sorry, yeah, so that's better, hopefully. Yeah. Okay. So, and in addition to this, I'm going to activate funnel. So funnel can be activated by saying funnel on, which I already done. Cheats a little bit because it needs DNS propagation. And then I'm going to say terminate all TLS into a port locally on my computer, which is the headscale instance. Then I've set up 2 clients in Docker for tailscale, which currently is logged out, like they can do nothing interesting. And then I'm going to log in using my alternative login server, so not the official tailscale one, which hopefully should return. I'm very afraid of the demo ghost. Let's see if I can actually copy it. And then you don't have to actually read what's on that page, but that's the very, very naive login mechanism we have. So this is going to ask for a username, which I haven't created yet, but I'm going to do that. And then I'm going to create a new user because I didn't have one. And I'm going to register my node. And after a bit now, this node is going to be logged in over into a headscale instance that runs over the tailscale network. And I'm running out of time, so I can't log into the second node. But I promise it works. And if anyone is curious, come drop by and ask me. 30 seconds. OK. 30 seconds. Fine. Second one. Oh no, the demigods are not kind today. Too much. Okay, we have 2 logged in nodes, and I can ping the other one from this one, hopefully. Yay!
Awesome.
Thank you very much. Thank you.
All right, thank you. Next. Who is next? Me. Okay, good. What do you need? Is that good for you? Okay.
Yep.
Okay, good. Start now.
Cool. I'm going to kick off 2 builds, and I'm going to explain what this is in just a bit. Hello, everybody. I'm Ram. I am Chief Evangelist at the Cloud Foundry Foundation. But today I'm here on a slightly different capacity. I'm a self-proclaimed BuildPacks evangelist, and I wanted to showcase what BuildPacks can and cannot do to the community. So the reason I wanted to give this lightning talk is because a lot of folks here seem to be interested in learning about what BuildPacks are and what they had to offer. And so I thought it would be a good chance for me to introduce this to the community. I will start with a confession, though. I'm not a big fan of the title that I made up because something doesn't have to be dead and something else doesn't have to be a long live in order for it to be interesting to the community. But I think it's the trend now. But it's definitely better than the other title that I had in mind because Docker files definitely seem to represent a kind of cognitive overhead for like a lot of software development teams, especially those that are trying to build platforms and trying to make a use case for very homogeneous builds and things like that. So a little bit of history about BuildPacks. So BuildPacks were pioneered at Heroku about a decade ago. Like, I remember the first time I did a git push master Heroku kind of thing, and it really was a bit of magic the way, you know, my code went into like the Heroku dynos or whatever, and then it came back with a URL. And so since then, BuildPacks have been used a lot by the community at Cloud Foundry as well. And it has been very successful in sort of porting this experience of, you know, here's the source code, convert it into an immutable artifact that we can deploy, and here's a way to deploy that to you. And so today, that has taken a new shape and a new form in this era of containers and cloud native technologies. And so cloud native BuildPacks are a thing. So if you go to buildpacks.io, it's a CNCF project right now. It's been very actively worked on by a ton of companies. And so it provides a way for engineers to containerize their applications and have them deployed without having to write Docker files and maintain them, because they can obviously be a bit of an overhead. So what I kicked off at the start were two deploys. So they were both for like two different languages. So like the first one that I kicked off was for like a Node.js app. And the second build that I kicked off was for a Go application. So the hipsters and the nerds speak, right? So what this ended up doing was to create two containers. And then the commands that I used to do that was just pack, build, and give the container a name. So pack is basically the CLI that does the containerization, and then you have to configure pack with like one of the builders. And so builders are available from Heroku, from Google, through a project known as Paketo, which is a Cloud Foundry Foundation project. And basically it creates this build out of the source that you have. So the point being is you didn't have to create an alternative metadata file that had details about what the dependencies are, where is the entry point to the container, what are the other things that you needed. So it's a very convenient way of building containers, and these are all exported as OCI containers. So they could go to container runtimes of your choice, and you can watch them, run and actually be functional. So I'm going to try and get these to work in the next 30 seconds before Chris kicks me off stage. But essentially, you can use these in your local development workflows. You can use these in your CI/CD pipelines, what have you. So if you go back to the browser, open up like localhost 80. I'm going to try 81 first. So the container is running, it's functional. my demo didn't quite break, so happy with that. So check out more about the project. There's obviously a lot we can do in terms of getting folks to contribute. This can work with your favorite CI/CD tools, what have you. It works with a lot of platforms, and there's a ton of people that are making use of it. So thanks.
Thank you. All right, thank you. All right. Yeah, sure, no problem. Is it mirroring, or are you good? All right.
There we go. All right, time starts now.
Okay. My name is Tim. I hope you're still with me because you're going to listen to some crazy Kubernetes controller stuff in the next 5 minutes. I'm going to take you on a journey towards horizontally scalable Kubernetes clusters. So what is actually the problem? Kubernetes controllers don't scale horizontally. It's a fact. It doesn't happen. But we see even more large-scale controller deployments these days, and they're becoming much more widespread, so we need to fix it. What's my idea? Let's apply some sharding patterns from distributed databases to Kubernetes controllers, because they have been proven since years, well applied in many distributed databases. Let's imagine a simple controller. It reconciles some foo objects, runs in some pod, and it does some leader election. And there we have the problem. The leader election is supposed to ensure there's only one active controller instance at a time. So if we add another controller instance, it will be in the passive mode. This is active passive HA. This is not horizontal scaling because there's only one active controller instance at a time to prevent any conflicting actions. We can do fast failovers with this topology, but we can't scale up the capacity of the controller. So if we get even more objects, we are still limited by the single instance. We can only scale it up vertically. So what was my idea in the study project? Let's partition all the available objects using labels. That's Kubernetes native. We all know labels. And then our instances can use label selectors to only watch a subset of all the available objects. And then we add another component, which is called the sharder. It watches the leases you see down below, which all the individual components maintain, so we know which instances are in the system. And then it can assign the objects or a portion of the set of objects to individual instances. And with this, we can apply many patterns from distributed databases, like from Bigtable, which uses this lease mechanism inside, or Cassandra, which uses consistent hashing under the hood to assign the objects. And I have to conclude that's a perfect match. The Kubernetes controllers can be sharded horizontally with this approach, and it is a controller native implementation. So everything we know from Kubernetes, the API, the labels, and so on, all the controller clients don't have to change for this. There's no fancy pub/sub mechanism happening around that. And I have implemented this in controller runtime to try this approach out in my study project. And you can find out the full implementation right here in this link. There's even an entire thesis with, I don't know, 50 pages about this for my master's studies. So if you want to check out the details, feel free. There is even an example operator which uses the implementation and some results for demoing that it's working. With that, happy KubeCon week.
Thank you. Short and sweet. All right. Which one are you?
I'm at 6:30. So Monique, well, it's on the schedule.
Okay. Yeah, no worries.
Thanks.
as soon as it comes in, just yeah, perfect.
All right, so I believe this might be the last talk. So we got one more coming. So you can let's just make sure it's working. So we've got one more coming, so you don't have long to go. But so for the next 5 minutes, I'm going to talk to you about Kubernetes API. I'm not sure this is working. Let me just switch this. Oh, it's working. Excellent. So next 5 minutes, I'm going to talk to you about Kubernetes API. If you don't want to listen, you can shut your eyes and imagining you're dreaming about Kubernetes API. So we've taken all these YAML files and applied to the Kubernetes clusters, and it's been quite easy. That's what we think it is. My name is Salman Iqbal. I am a, let me just switch this because I think this is playing around. Give me a sec. Let's see. This is not a. It's not a rolling update, so yeah, there's a bit of downtime in this one. There you go. Let's go. Oh, the other way. Mirror it. Let's see. All right, here we go. Pretend none of that stuff happened. Hi, my name is Salman Iqbal. I'm a solutions engineer up here, and I also work for LearnK8s as a trainer. We take a YAML file and we submit that to the cluster. And what we want to do is on the other side, the request goes in to Kubernetes cluster in the control plane, and it's received by a component called the API server. And on the other side, the request gets persisted inside the database. But what actually happens? There's a bunch of components that request has to go through. The first one being an authentication component. In that, it's just checking: are you allowed to have access to this cluster? You need an external system to do that. If you are allowed access to the cluster, the request is then forwarded to the authorization component. And the authorization component is just checking: are you allowed to do what you're about to do? So can you create a deployment that you're doing? And this is done using RBAC, so you define that inside your Kubernetes cluster. And after that, this is where the interesting parts start. There's a mutation admissions controller. When you submit the request to Kubernetes, it might be missing some default fields. The mutation admissions controller will attach those requests, those default fields in there. For example, if you submitted a YAML file and you didn't include image pull policy, it will add that. That's not the only field it adds. It goes through a bunch of checks to make sure it adds all the fields. Otherwise, it just rejects it and sends it back. And then after that, it is going to check if the YAML file, for example, a pod, does actually look like a pod. If it doesn't, rejects the request. And then after that, there's a validation admissions controller. So this is like, let's say you submit a request, and you want to create something in a namespace that doesn't exist. That gets rejected. That's not the only thing. It checks through a number of things in here. You can have a look at that. If there's not enough quotas, it might just reject that request. So the request will get rejected. One of the things about these controllers, the mutations admission controller and validation admission controller, is that we can extend them. There's webhooks in it. If you have heard of Istio, I'm pretty sure you've seen this, how it plugs into the mutations admissions controller. It injects the sidecar container. And for validation webhook, think about policies. So if you have open policy agent, you can define a bunch of policies that the request has to pass through before it gets submitted to the cluster. For example, you only want to allow images that come from your private registry. And then there's some open policy agent is not the only one. There's a few other options. You can also write your own scripts if you wanted to, but these are pretty good projects. You should check them out if you want to. And after that, there's a few more things it does, and then persists the information to the database. So in summary, what does actually happen? Well, I don't want to go through everything, but you can see if any of these things fail, the request will get rejected, and on the other side, it'll go ahead and persist it inside the database. I'm Salman Iqbal. Check me, follow me on Twitter, LearnK8s. Just check out. We got some great blogs on there. Thanks all, and have a great week.
Thank you. And now we have the last lightning talk, which I've been assured will take us out with a bang. And then right after that, we're going to have Andy up here to close it out as he opened it at the beginning. Do you need me to hold it, or you got it?
Kia ora. I am Hippie Hacker. I do need to plug that in somehow. Just the normal, yep, that'll do. In the hole there, it'll spit it out. All right place. Put my stuff up here for a moment. My name is Hippie Hacker, and I'm going to display some things for you, possibly. What I'm holding is called a... Oh, I'm going to look over there, look left, look right, look down. Pardon me. Whoa. Sorry, I didn't realize it was going to be. I'm the professional guy here. Maybe if I turn around and look the same direction you do, it'll be easier. There we go. Screen, network, something. Displays, thank you. We're going to mirror it to make it easy on my old man. Ooh, there's lots of things going on here. Let's do less of that. Arrange. And, ooh, decimator. That sounds very intense. Disconnect anything that's not local. Oh, that's better. All right. And let's mirror. Let's just mirror the built-in display to make it. There we go. Hi, I'm Hippie Hacker, and this is my coconut toko toko. And in Maori culture, if you're speaking, sometimes you'll use your stick to make a point. So sometimes I will do that while we're looking through these things together. I forgot to bring my clicker, so I'm going to put my toko toko down for a moment. And these are my boys, Asher and Benjamin. I like them a lot. I'm pretty partial. I like all of you, but they're my favorite. They like to play games, and we go out and do things together. But I spend a lot of time helping people cooperate and create a culture of cooperation. And one thing I've noted is that we often think about it in the context of a busyness or a corporation, but we often don't think about the space between us. And that's where you're and I, and I'm and I, and then there's things between us. So I want to move it forward a little bit. The culture of cooperation and pointing to positive things and being to share your feelings that we have at II isn't something that I just do for, hey, I know you, I'm trying to do stuff. But it affects all of those around you. And so I want to read you something that's very precious to me. This is written by my 10-year-old son. He goes by TT for Tiki Tucker. I'm Hippie Hacker, so he's kind of following in Papa's footsteps here. But he wrote this, and I want to read it to you. We're in the midst of leaving New Zealand and bringing the culture of there to other places. And he says, there are many things in life that hurt you, and there are many things that heal you too. When I feel sad, I want to cry, and it's hard to be happy when you're sad, and I find a way around it. Focus on positive thoughts, that's it. When you focus on positive emotions or thoughts, you feel good. But when you focus on negative thoughts, you feel bad. When you don't know what's going to happen, you feel scared. When you don't understand what's happening, you feel scared. But when you understand it, you feel better. I've had all of this happen before, and it's happening again now. When you focus on negative things, you're not focusing on positive things. When you focus on positive things, you're not feeling bad about yourself or others. You have value. Remember that. You have the power to make decisions between positive and negative thoughts. Remember that too. Don't feel scared about sharing your thoughts or feelings when you are uncomfortable or unhappy. I won't read all of these chapters here, but I'm going to go through and read another book because culture is important, whether we pass it on to the people we're now by or our children. What's fun about this is I was able to cooperate or create a cooperation with my son using just old normal computers. And we have a little thing called II Matey, so eyes are eyes. If you have II Matey, what it does is you can kind of see in the little demo here in the website, and this is matey.ii.nz. You just type a little thing and you start it, and then it gives you a URL, and you can give it to your friends to say, can you come join me in exploring the inky blackness of this little black terminal thing? And And beyond doing that, we said, well, how do we make that a little better? So, without getting all technical, that's about as technical as it's going to get today. I want to read to you a little bit of a book about 3 things to know. And I'm dedicating this one to my son, Asher, because I have given this book to so many people all over the world, and I haven't given one to him yet. He couldn't be here yet, but we're going to bring him to KubeCon NA and do the Kids Day there. So here we go. Somebody might hold the mic for me here, because it'd be a little awkward to turn the page. You should get a picture of yourselves. So, if I can get the book, can we see? Good. We'll bring it down a little bit, a little up. And so Asher, my son, I love that you were able to write such a beautiful set of words based on the things you've learned. Sometimes I don't know if you're listening, but when I see the words that you've written and it inspires me and it encourages me, I want to share that with others. So this book belongs to a very valuable person called Asher. And of course, you know, hippie hackers, your papa. And when 2 or more eyes are together, it's good stuff. So that's what I got it right where we can see it on the, somewhere around that angle. I'm going to pop this up a little bit. When you look at you, tell me, what do you see? A Tonga? A treasure? Or do you disagree? Asher, do you see someone great? Do you see someone small? One that matters a lot? Or not really at all? Because sometimes we think to be someone who counts, we must act the right way or somehow stand out. But that's just not true. I'm here to tell you, whether you see it or not, you already have value. What does that mean? Well, it means that you're great. It means that you matter, no room for debate. If you're big or you're small, tall, lean, or stumpy, happy or sad, or incredibly grumpy, brainy or brawny, inspiring or fun, if you speak several languages, or maybe just one. If you love to play sports, or are great on guitar, none of that changes how special you are. Because, my son, you had your worth from your very first day. And nothing and no one can take that away. Hey, I like the eyes to eyes here. So, Asher, learn to be you. Be as you can be. Because you being you is what everyone needs. So when you be just you, and I be just me, and we be just we, then together we'll be so much more than we would if we did it alone, succeeding much more than we could on our own. I'll go fast. Oh, we lost the screen. It's like, oh no, not with the books. It's okay. If you don't pass the ball, then I can't score a goal, and the batter can't hit if there's no one to bowl. A kite doesn't fly if there isn't a breeze, and hugs are no fun if there's no one to squeeze. There's no uncles and aunts without nephews or nieces, and the puzzle is unfinished without all the pieces. Look, there's a piece missing. If we all work together, we'll get the job done. For when you rise, I rise, like the stars or the sun. For you can succeed when someone helps you. And you can help them because they matter too. And they had their worth from their very first day, and nothing and no one can take that away. From the littlest baby to the greatest of queens, the smallest and tallest and all in between. If they live in a mansion or they live on the street, if they like to stand out or take a back seat, if they're mean or well-mannered, if they're nasty or they're nice, or maybe there's someone not everyone likes, or maybe there's someone who doesn't like you, there's still someone valuable and just like you.
They have worth. They are special. So treat them with care and call out the greatness you know is in there by encouraging, helping, or just being kind. We all need each other. That's how we're designed. So, the title of the book is 3 Things to Know. So 3 things to know as I start to farewell you. Firstly, remember that you have value. Take risks and fly high. Put your worth on display, because nothing and no one can take that away. The second thing then is to work as a team, succeeding together in reaching our dreams. And last but not least, before I say goodbye, no others matter, my son, so help lift them high. So I'll just be me, and you just be you, and let's all stand together in all that we do. My son obviously is influenced by the culture and the things that we read together and the things that we do. And I want to kind of bring that out of just my family and everything else. So if I go forward 1 slide, oh no, and it turned off again. There's some technical schmechnical, but I registered a domain, and it's Cloud Native, because this is the neighborhood that we're in. It's Cloud Native Co-op, and there is a Slack channel called Co-op Mode, because I'm kind of tired of playing single-player mode. So if your project or your group, or maybe you just want to stop doing it by yourself, well, come along, we'll have some fun and create some templates for cooperation so we can create a cooperation like me and my son did. Write some cool stuff together.
So Andy, I'm giving it to you to wrap up. Margaret, do you want to come up too? Or you helped open it, so. Off the cuff.
I can tell you don't get talks like that at KubeCon. That's what you come to Rejekts for. Right.
Do you want me up there? I don't think so.
Yeah, come on up. So, can we get my slides? Yeah, so I'm going to be very, very brief because I know we're already over. I just want to say thank you so much to so many people, to the sponsors who make this possible, to all the speakers, from the very first through to the very last. I thought it was just an amazing mix, and it truly is something special, I think, that we have here in terms of content and in terms of the networking and community that we're building. Thank you to all the volunteers who ran the tracks, who helped you check in, who just made things flow. Thank you to the venue staff and to the AV folks who just made everything go so flawlessly. Who have I forgotten, Marga? I think that's it.
Yourself.
Oh.
Thank you to Andy for all the organizing effort. But yeah, and then Venazir that should be here.
Thank you. And
yeah, and Chris, who's like the ideator of the whole thing.
Okay. So I think that's it.
That's it. There's another slide.
Yeah.
Oh, great. Me?
Yeah.
All right. So we already know where KubeCon is going to be. So we also already know where Rejekts is going to be. So yeah, see you in Chicago in November. Yeah.
Yeah.
And that's it. Yeah. Enjoy the rest of the week if you're staying here.
Yeah. And have a great KubeCon, everyone. Thank you. That's a wrap.